Okay, good morning guys, off we go. I'm gonna try to not walk around with this, but I'm gonna try to stick it right here and see what happens throughout the day. You guys in the back, if I get a little faint, let me know. Never been accused of being faint, but here I am. So it's been about 3 years since the last time we met. So once a cycle, whether you need me or not, here I am. So we'll talk about sprinklers today, what to look at for rough and final inspection, but a little bit about me first. If you haven't seen this show in the past, I'm Jeff Hugo. I'm from Bay City, so I go all over the country to do this class, and the classes such as sprinklers and whatnot. And it's glad to be, drive an hour and land here. So it's wonderful to see people that I know and neighbors and whatnot. So even Joe's gone. Nice. Jeez, try to give Joe a little love, and he just walks out on me. So.
He had enough of you.
Yeah. I know, Joe. Anyway, so I'm a registered building official, building inspector, plans examiner here in Michigan. I've been registered since 1995, and I've been working with the National Fire Sprinkler Association since 2005. So for about 17 years, I've been outside. I do a little bit of plan review, a little bit of inspections for Frankenmuth and Hampton Township over in my neck of the woods in Michigan. But for the most part, I am full-time. I'm a vice president at NFSA, vice president of codes and standards and learning and development. So we have like, I have probably like 10 guys on my team getting into codes and standards throughout the country, throughout the world. So we probably got like 250 different technical committees. A lot of them have to do with, obviously, fire sprinkler systems, so NFPA 13, NFPA 13R, and 13D, NFPA 14 for standpipes, 20 for fire pumps, and all that stuff. So hopefully today is a good class. It's very similar to the class you took about 3 years ago. A few updated slides, but I'm here to be with you the whole day. I hate to take this beautiful day and make you sit in here, so we'll try to get out at a reasonable time. We'll get your hours in, and then we'll leave, right? Eventually. All right. So eventually. So I think you have my contact information, but it's up there. It's hugo@nfsa.org. I'm more than happy to come and visit you all, or come see you, or sit down and do a plan review if I have time, and answer your sprinkler questions. But I think sprinklers became a thing of mine, obviously, right? When I was a brand new building inspector out in Tuscola County, out in the thumb of Michigan, in 1995, it was like I found that sprinklers were a thing, right? And this is not where I came from. So I eventually, through working with my mechanical inspector or mechanical plans reviewer, it kind of fell in my lap, and I eventually moved into Bay City and did some sprinkler review and whatnot there, and eventually got hired by the NFSA to do this for a living, which I just find a lot of joy in. So contact me anytime. That's my cell number. Call me, text me if you need anything. And very quickly, the NFSA is the National Fire Sprinkler Association. We've been around since 1905. We represent the industry in the code arena and legislative and regulatory issues. Code adoptions, technical help for contractors, for AHJs, for code officials, and so we've been around for quite some time. We're probably an association of, I believe, 58 people or so, 58 staff all over the U.S. These are the numbers I have. I think they match your numbers. I hope they match your numbers. But if you're a CFI, so a certified fire inspector, there's 7 hours of credit here. You got a smattering of learning units there, all the way from admin to plan review, and even a communication credit, so which is good. A couple of plan review, because it's really hard to do a rough or final inspection without doing some plan review, right? This entire class is about what you did on the plans, what you approved on the plans, and what's supposed to be in the ceiling or in the walls, right? So plan review is a critical part of our rough and final inspection. So, and then if you need a ICC preferred provider credit number, that's in the bottom. So there you go. If you need this up later, I'll pop it back up there. But let's go forward. I think let me drop this down just so folks in the back can see a little bit. Hopefully that's a little better. So I gave Sue the handout last week or so. So you either have the handout digitally or print it out. So that entire handout probably lasts a good 12 hours or 16 hours of content. Don't worry, we're going to land somewhere around 3 o'clock today, right? There'll be a number 3 in front of the time we leave today. So we're not going to go through all that content. We're gonna kind of hit some spots that I think as mechanical inspectors is important. I know there's a few building inspectors out here who have dual registrations, and I think that's important. With some of these rough and final issues and get through the day. What your questions, your content, your issues are more important to me than my stuff is to you. So I want to tailor this course for you all. All right. So let's get into a little bit of code nerd stuff, right? So in Michigan, we have a little bit of a dual jurisdiction when it comes to sprinklers. You know, Chapter 9 in the Michigan Building Code is enforced by the building inspectors, right? And then also in sprinkler world, the mechanical code. The mechanical inspector has a lot of responsibility too. So there's a little bit of a two-person thing going on here, right? Multi-jurisdiction thing going on here. So we'll talk about the 2015 edition of the Michigan Building Code, Michigan Mechanical Code, and primarily their reference to NFPA 13. We're going to spend most of our time in here today, which is probably something that you know, a good refresher of what NFPA 13 says and does is what's needed. Michigan's probably about the only place in the country that really has 2 different editions of NFPA 13. Your mechanical code references the 2010 edition. The building code references the 2013 edition. My 2013 edition is so beat up that I had to bring my 2016 edition. So just to keep all the pages in the book. The rules from 10 to 13 to 16 really don't change. They don't really change at all. All we've done in 10, 13, and 16 is add some new stuff, right? Change a few things, add a few things, and I'll point those out along the way. Currently, we have the latest edition of NFPA 13 is out, and that's the 2022 edition. So you're not as far behind as some states, but you're getting there. So we need to get you all updated to a current standard. The 2022 and the 2019 edition make some big changes, mostly in format. If you've been around long enough, you'll know that in 1999, going back a few years now, in 1999, NFPA rearranged the entire book. So if you learned the 94 or 96 or earlier edition of 13, like I did, in 1999 they rearranged everything, right? And it took a while for us to understand and learn where all these sections were and all these rules were. And in the 2019 edition, 20 years later, they did it again. So when we get to that stage here in Michigan, having another NFPA 13 review and update class, I think will be important for you all. Just because the arrangement's different. We'll go through the arrangement of NFPA 13 here in a second. So how do you guys rectify this 2010, 2013 difference? What do you enforce? 10, 13, latest and greatest? 13. The 13 edition? Do you have a 10 back there? Okay.
We're using your 2013.
Okay. Does anyone in the room accept a newer edition as long as the contractor takes the whole new edition, not pieces and parts that they like? Yeah?
Yes. As whatever the plan is stamped, if it's a 16 edition, it's done by the 16 code.
Okay. What are you finding out there in Michigan for the sprinkler contractors? They're using the latest?
Most of them are using 16 at IMC.
Okay, good deal. Yeah, the 16 edition is the last edition before they make the big rearrangement. The 2019 edition really doesn't have any technical changes. It's just been rearranged. So chapter 5 from here, you know, for hazard classification starts in chapter 4 in the 2019 edition. So, and on and on. I don't want to get too many numbers in front of you and not show you. All right. Any questions before we get too deep? Joe's back, so we can get going. Thanks, Joe.
Okay, thank you.
All right. So I won't get too deep into some of these. We'll get into some of the technical stuff real quick. relationships between the mechanical department, mechanical inspectors, mechanical plan review, and the building and the sprinkler contractor, and the contractor in general becomes really important, right? Because if you're not in this standard every single day, there's certainly a contractor out there who is, and that's a good thing or a bad thing sometimes, right? There are some good contractors out there who can lead you and guide you on what these rules are in this book. So I think relationships do matter when it comes to an AHJ, just from that, you know, this is us as the township, the city, the county, representing the township, city, and county to our contractor members and to the public. So I think relationships are really important, you know, being cordial, being honest, having the ethics, etc., that you all have, and the professionalism that the mechanical inspectors do have in Michigan is widely known. I talk to sprinkler contractors all across the U.S. or even in Michigan. You know, they point back to, you know, their relationship with you all. So, you know, what you do out there, I get to hear from the contractor's perspective as a one-on-one. So you do represent yourselves very well, and I think that's super important. And then, you know, working with other inspectors. So as mechanical inspectors, you know, again, tag along with other trades, whether the electrical inspector goes out, and we had a little small discussion here this morning on duct detectors, right? The smoke detectors and the duct work, and how that interaction works between the electrical inspector, the electrical contractor, the mechanical contractor, mechanical inspector. That can get sometimes complex, right? So working with other inspectors, going out with other inspectors, tagging along with other inspectors, I think is important. And don't forget the fire folks. The fire folks, the fire marshals, fire chiefs here in Michigan don't have a whole lot of authority when it comes to sprinkler systems. In like 49 other states, they do, except for Michigan. They don't really have a whole lot of code enforcement responsibility here in Michigan. So we're it. When it comes to sprinkler systems, fire alarm systems, we're it. Now they have, you know, in the last few years they've had, they do have some jurisdiction in Chapter 9, and they, you know, do have a plan review, plan review registration, an inspector registration now in Michigan. So that's improved in the last couple of years. But all in all, keep everybody in the loop. So the one of the classes that we do, and actually I'm doing it next week at COCM in Bay City, is plan review. So whatever that plan review that you do becomes super important, because that really becomes the code or the standard you're using to inspect the building, right? So whatever is on that plan that you approve, that you have the responsibility to approve, it becomes your code book or your standard to go out and look at the structure, right? So having your documents from your plan review at your rough or at your final or at the acceptance testing becomes super important, because that's what you looked at, you know, a few months ago or a year ago, whatever. So especially now when we have a lot of projects that were shuttered over the pandemic, now that are reopening, there's a few concerns there, right? If you approved the plans, set up plans a couple years ago and they got shuttered for the pandemic and now it's reopening, you know, you may have to do a new plan review. You may have to get a new set of water supply graphs and whatnot, because things have changed. So plan review checklist, whatever you use for plan review should go out with you in the field, and double check the things that you tag on that plan to make sure that they're accurate in the ceiling, they're accurate in the system.
Jeff,
Yes, sir.
could you go back to Michigan Building Code as a fire marshal? Doesn't he have to be registered?
Yes.
Under the Skilled Trades Act 407?
Yes. That's my understanding.
As a licensed planner?
Or a registered plan reviewer, yeah.
Registered.
Yeah. Yeah, that's my understanding, is that the question was, doesn't the fire marshal or fire service representative have to be registered under the act?
Skilled Trades Act 407.
Yep, they would, in order to have that jurisdiction or that responsibility, yeah.
Yeah, but that doesn't prevent you from sharing the plans with them, so they're aware of what's going in. And again, it's another set of eyes looking at the info.
Yeah, Curtis's comment was, you know, even if they're not, it doesn't hurt us to share the work that we have with them, because a lot of times those guys and gals are just naturally assume that they know what they're doing and how they're doing it. And a water-filled system of piping you know, seems to land in their lap a lot of times. So bring them along. And when I was in Bay City, it was the exact same relationship. The fire marshal there at the time was really good on fire alarms and fire alarm systems. I wasn't. And but I had the plan review side or the sprinkler side, so we worked a lot together. But that was 20 years ago down here, and you know, they didn't have that responsibility or registration back then. But we shared, like Curtis said, you know. Where do we go here? All right. Plan changes. Plan changes during the project happen, right? Plan changes occur all the time. And how you manage that, I guess that's really up to you. The code says, the mechanical code, the building code says that, you know, anytime there's a change in plans, what you approve is supposed to be on the project, right? With your stamp, your doc, you know, your ink on it, I should say. And that's the plan that they should be building from. But we all know that that's not really what really happens. Changes happen all the time. Owners make engineering judgments, or engineers make engineering judgments, and owners do value judgments, and plans do change. So that difference in plan change is important. To have a policy is important. So little things, maybe like, I don't know, hangar spacing, or you know, maybe a shift in a branch line here or there. Probably not a super big deal. But some of the major changes, like maybe swapping out, and this happens all the time too, where a sprinkler contractor may have submitted their shop drawings using Tyco sprinklers, and then you show up on the job site, and you start looking around, and maybe the Viking salesman had a hell of a deal for that contractor, and you know, sold them all Viking sprinklers. Is that a big deal? Maybe, maybe not. You know, if they're the same K factor, the same response characteristic, same all, it's probably not a super big deal, but again, it is something that you want to be aware of and be in the loop of. So again, I think that would trigger some sort of updated plan review. So how many of you have policies on, you know, construction project, re-looking at plans as that project goes through?
A few plans have to be on that job site.
Approved plans have to be on a job. Yes, sir. Yep, exactly. How often do you see that? Yeah, yeah. There's some contractors that are really good about this, and some not so good. You know, and there are times I've been there myself where that job looks nothing like the set of plans you looked at 3, 4, 6 months ago, right? And it's a bit of a head scratcher once you get on site. It's like, man, I got a whole bunch of administrative stuff to do during this inspection, that I'm supposed to be doing this. The whole project's going forward, and I'm getting ridiculed because I want to catch the paper up to the project, but that's important. It's not so important to the contractor at that day, right? It's not important to them, but it's important to us because it's in our files. You know, 5, 10, 8, 10, 15 years down the road, that documentation becomes super important, especially when it comes to sprinklers, because sprinklers are designed for the hazard and the commodity for that time, right? We could have a warehouse. We have a lot of warehouses. We could have a warehouse that is storing, let's say, mayonnaise in glass jars today, and we designed a sprinkler system for high power storage for mayonnaise in glass jars. I don't know who has a warehouse that big, but maybe somebody does. But 10 years down the road, you go back for something else, and you notice that the mayonnaise in glass jars have transferred into mayonnaise in plastic jars. Does that change the fire protection system? You bet it does. It changes the commodity, it changes the design. So having that documentation back in your file is super important. You can go back and say, hey, Mr. Owner, this is what you did 10 years ago. This is what it is now. The standard says that you need update, right? You don't have the level of protection that you once did or thought you did. So documentation, I think, is super important, and it's required by the codes and the standard. All right. So some inspection techniques. You guys could probably tell me more about inspection techniques than I can tell you, but walk the floor. Obviously, you walk on the floor. But for multi-story buildings, I would always try to start at the most remote area, the highest, the furthest away, typically, and walk that floor back and forth, and be consistent. Consistency for me as a department head was important because then my following inspectors could understand, okay, we know Jeff, we know the previous inspector starts here, and goes in this way, right, top to bottom, from top to bottom, and it's just a process that you can understand your fellow inspectors what they're doing, especially if you have multiple inspectors in a jurisdiction. So documentation is super important. But before I get documentation, let's go back to the you inspect the same every visit. So you be consistent in the way you inspect, not to be predictable, right, for the contractor, but to be, you do what, 10, 12, 15, 20 inspections a day. There's gotta be a mental process, I believe a mental process, that you can recall being at that site. Yes, sir?
Are these slides anywhere written?
Yes, Sue has them. So we send them to Sue. Sue can deliver them to you digitally or.
She did.
She did send out
Third day on the job.
Yeah. She sent out an email.
I'm fresh.
You're fresh, you're brand new, right?
Brand new, third
oh.
day.
Oh wow, Thursday, look at this.
I didn't come preloaded.
That's all right. But the slides are in an email somewhere to you. All right.
I'm gonna see this in the
All right. Not so much mechanical inspectors, but other inspectors, fire marshals, building inspectors throughout the country have a little trouble sometimes recognizing or understanding fire sprinkler system. So we give them this advice: be the water, right? Imagine yourself inside that piece of pipe and traveling through from the city water main through to up to the riser, down the cross main, out of branch line. Be the water, right? Follow the path. And that sometimes helps people understand how sprinklers work, how they operate. But at the end of the day, don't overcomplicate it. It's water-filled pipe, and I know many of the people who build this book, make this book, and they're not that smart. So don't overthink it, okay?
Say that one more time.
Yeah. I'm in this book too, so by the end of the day, you'll say, "Oh yeah, he's not so smart either." So. All right. All right, any other inspection techniques you can tell me? No? All right.
Risers.
Risers?
As construction goes on, up, the risers have to be off with the provided water.
Okay, good point. So, the building code, was it chapter 34, talks about construction, right? So when you're in a multi-story construction, the standpipe needs to, at 40 feet, the standpipe needs to be installed, and then as construction goes, it follows that as that construction goes up. And that's what you're pointing at there?
Yes.
Yeah, that's the construction fire safety out of the building code. I didn't think, well, so you're in the 2015 edition of the IBC. There's been a lot of changes to that in the 18 edition, the 21 edition, and a lot of reference to another NFPA standard, NFPA 241. So, as you're all very aware, there's been a lot of construction fires in the last 10 years. It's kind of a phenomenon because we didn't have this rash of construction fires. The last time we saw a rash of construction fires was about 100 years ago in the 1920s. So, and for some reason we're seeing it again. Probably has to do with a lot of the wood construction. Probably has to do with the type 5 construction gets as big as it gets because of sprinkler systems, right? Without sprinkler systems, wood buildings are fairly small. And also in the last 20 years, we've had a new construction technique called podium or pedestal style buildings, where we have a type 1A building underground, and then it comes up one floor, right? It's all 3-hour concrete. And on top of that deck, on top of that 3-hour horizontal firewall, we put a wood building. And whether it's a NFPA 13, it's a hotel, motel, business office. But a lot of times, if it's a hotel or motel, it's protected by NFPA 13R. So a lot of times under construction, that's what we're seeing as construction fires are those pedestal style buildings and the wood on top of it. So. Good point to bring up, especially if you're in a rural or a metro area where you do have multi-story buildings going up all the time. The fire protection for it, the other part of that fire protection for it as it goes up, it has to be connected to a water supply, right? Sometimes we see this standpipe going up through the stairwells that is connected to nothing, and it's like, well, that doesn't help out. So there needs to be the permanent water supply, or at least a temporary water supply needs to be connected to that as it goes up. They go up quick. Yes, sir?
No, I believe there's provision for a manual standpipe approved by the fire marshal.
Yes. Yes, question in the back, or comment in the back was, you know, can a manual standpipe be installed? And certainly, during construction, it can certainly be installed. Manual standpipe is where the fire department brings the water and the pressure, right? They bring the water, they make the connection, they bring it through a tanker. So that's acceptable too, but I can tell you right now that the response time of most fire departments compared to a lot of the construction fires we've seen just don't match, right? Once that building goes, once it's under construction, it's a bonfire, right? It is. And there's a few advances in technology over the last few years. There's a spray that, I don't remember the name of the spray, but it's not an intumescent paint, but it's a spray that you put on this building as it's being constructed. It does nothing post-construction, but it's supposed to be there to retard, you know, flames and heat and whatnot during construction. I don't know how effective it is, but it's certainly being out marketed to inspectors and cities and contractors. The other one is some wireless heat detection and smoke detection for some early warning. Some of these projects are huge, right? Some of these projects are being occupied while the other part of the project is being constructed. So the wireless alarm system works really well. And anyway, yeah, construction fires, super important. Any other questions? All right. As far as documentation on your inspection, you probably do a lot better job than I certainly do. I was always, you know, my building official always advocated for documentation, right? She always said, you know, make sure you write out when you get there, when you leave, the temperature, you know, who was on site, who you spoke to, the violations, etc. You know, that's inspection by inspection. And I've been to court a few times, like you all have. You've been to court a few times. You learn from that opposing attorney what they know, right? And what they know is that they're taking this book and they're reading it literally, right? They have no idea what the interpretations mean. They have no idea how they apply it, but they can read. And if you've been on that side of court, then you know that they can read, and they ask you questions that are really tough sometimes. So documentation is really what helps us out as inspectors in court, right? Even if we make a mistake, we can prove that maybe, you know, the mistake wasn't intentional. So documentation, again, really important. Use section, you know, code section numbers. This document becomes the law, right? We're essentially law enforcement. We're enforcing the law, and while we don't have a badge or carry guns or have handcuffs, at least not on us when we're inspecting, we do enforce the law. And to enforce the law, you got to set a section number, and we'll get a lot of section numbers today that you can apply. And then again, anytime you write a violation, you know, write it closest to a landmark, right? The 4th floor, grid line H, and grid line 8, whatever. You know, try to identify where it is, so when you send that out, the contractor knows exactly where you're dealing with. All right. Job sites, you know, while there's a permit on any job site, you're welcome to visit that job site. It's just, even if it's just a building permit, you can still visit the job site, right? You have authority to visit that site. You have authority to visit that site sometimes without a permit. But familiarize yourself with these projects, especially these large projects. You know, get on site, you walk around. If you can, get into the job site meetings and be a part of that job site meeting. You learn a lot. You know, sitting with the construction manager, the project manager, the mechanical contractor, the building contractor. You know, seeing how that project moves through its stages and being involved in that is really helpful to us as inspectors. You know, understand what previous inspectors have done. If the electrical inspector's been out there, done the rough inspection, the building inspector's been out there, done the rough inspection. You know, as mechanical inspectors, understanding who has gone before you helps you understand where you're at, right? And understand where this project is at. All right. Again, safety. Safety is no one's looking except for you. So, you know, be careful as you're walking. Most of the time, as a sprinkler inspector, we're looking up and we miss the things that we're walking on. So just look down every once in a while. You know, most of the youth today, they're looking down most of the time too, so they tend to miss the things around them because they're looking at this all the time. And we've kind of fallen in that too as we've gotten older, right? Looking at our phones and trying to record things on our phones as we're inspecting. All right. So, as boring as it sounds, one of the more important things to do as an inspector is to understand the codes and the standards that you're enforcing. And I think that's appropriate to go through this document that we're going to try to enforce, NFPA 13. Some of you may have glanced through it. Some of you may have, done deep dives on it. Some of you probably know this book better than I do. But I do want to go through and just kind of gently go through the general layout of the standard, just so you have a better idea and a better familiarity with how the standard is produced. So all NFPA documents, a lot of times, whether it's on a Facebook forum or you hear this verbally too, that I'm going to go talk to NFPA about this section or that section. Well, know that the NFPA does not. All the NFPA does and all the ICC does is publish a book, right? They're book publishers. Once Michigan adopts that book, it becomes law. It becomes us to enforce. But the book, whether it's a code or a standard, is produced by volunteers, right? They're made up of technical committees, of balanced technical committees, contractors, manufacturers, AHJs, code officials, other interests, to produce a standard or produce a code, all volunteers. So when you open up your NFPA 13, there's a couple of things right in the beginning of any NFPA document, including NFPA 13. There's the first few pages there that tell you the history and the origin of that standard. Boring as all get out, but it tells you a little bit of the background of NFPA 13. And well, the interesting thing about NFPA 13 is that it was the very first mechanical standard in the U.S. And it's the longest serving mechanical standard in the U.S. Does anyone know when the first NFPA 13 was published? I told you this 3 years ago. I have 1903 up here, 1805 over there. I quit the gap there. 1896, all right. So someone read their notes from last year, or last time that we spoke, or they know the history and origin of NFPA 13 by opening up the book and looking at it. So, good deal. 1896, so yeah, it's the longest serving standard, actually in the world, that's still in print. We certainly have updated it since then. But back then, we called it the pamphlet, right? NFPA 13 pamphlet. And for years, up until, the 70s, the 80s, it was literally a pamphlet. It was a pocket guide. It was definitely not this thick. So when you read that history of origin, every one of those paragraphs in those first couple pages kind of gives you a real 30,000-foot view of what the major changes are, and you can understand what the major changes are by reading that and understanding that. As you flip through, there's certainly the table of contents, and then before you get into the meat of the standard, you'll have a few pages of the technical committee members on NFPA 13. So NFPA 13 is made up of 5 different technical committees, right? There's a discharge committee, there's an installation committee, there's a residential committee, there's a hanging and bracing committee, and then there's a correlating committee that kind of sits over top of all of them. So anyway, all these volunteers, again, on a balanced committee, create the standard, approve proposals, vote on proposals, etc. So I bring that up to say because code officials are like the hardest part of that technical committee to get. In whether in NFP land or ICC land or any AWWA or the ISO, any of those standard development organizations always have trouble getting code officials. And if that interests you, which I'm sure it does a few, well, apply. And if you don't know how to apply to be on a technical committee, you have my contact, and let's figure it out. Most of the time, ICC and NFPA pay for code officials to be, or at least reimburse you to be on these committees. So there's really very little money coming out of your community's pocket or your pocket. So let's get into the guts here. So all NFPA documents, the first 4 chapters are laid out the same, right? You have chapter 1 is administration, chapter 2 is your reference publications, 3 is definitions, and 4 is your general information. Chapter 1 talks about the scope and the purpose of the standard. And as we look at that, we look at into the document, the scope and the purpose of NFPA 13 is to provide satisfactory performance to and assuming 1 fire. Those are the exact words, kind of paraphrased in chapter 1. So when we design a sprinkler system or we install a sprinkler system, it is assumed that there will be 1 fire originating in that building. So we could have a system that has we could have multiple risers on a manifold, serving 200, 300, 1.8, 2.5 million square feet, right? So each one of those risers is a separate system, and that entire building is comprised of several systems. We're assuming that the building has 1 fire, right? So if you didn't know that, part of what that's a little bit mind-blowing, that this entire building is designed for 1 fire. But we see it time and time again. We see, for example, if an arsonist goes through a building and sets 5, 6 fires throughout the building, and the sprinkler system fails, which it wasn't designed to handle 5 or 6 different fires, chances are it could fail. But most of the time it doesn't. It controls this fire. So the other part of chapter 1 talks about is satisfactory performance. And we'll talk about this later on. Is the word satisfactory, does that give you warm, fuzzy feelings that this is like the premium optimum system? No, satisfactory is what was that in high school? It was a
C minus.
It was a C minus, yeah. Yeah, C's. My oldest daughter, who kind of took 3.5, 4 years to get through 2 years of college, said, "Dad, C's get degrees." I'm like, "Okay, well, you're paying for it, so you get what you want to get." But anyway, satisfactory, yeah. C's get degrees. This entire document is based on a C, and sometimes we get really wound up around the axle, like it's got that sprinkler is a ½ inch this way or that way. We get wound up. It's again go back to it's water-filled pipe, it's sprinkler spray, and it's everything's going to be all right. Also keep in mind that chapter 1 talks about control. Most of what the NFPA 13 does is control fire, right? You still need a fire department, and most of what the sprinkler systems do is control small fires, right? We're talking about fires in the incipient stage. 97% of the time, it only takes 1 or 2 sprinklers to control a fire. So when the fire department shows up, they're finished putting out that fire, what they're supposed to do, right? What happens? That's the intent in NFPA 13, is to control. A lot of times when they show up, it's 1 or 2 sprinklers that control that fire, and a lot of times it has put that fire out, but it's still going. The system has worked. Remember, it's satisfactory. There's 2 sprinklers that are designed to suppress fires. Like this room always trips me out because I'm looking around for sprinklers to point to, and they're not here, Jeff. They're not here. Stop looking. So we'll just imagine there's sprinklers in this room. There's sprinklers in the dwelling units, which is cool, but this room is always like, wow. Anyway, I've been here many times, and then Curtis's programs or MyAM's program, and it always fails to. I always fail to not stop looking up. All right, I lost my train of thought here.
Yours sucks.
2 different types of sprinkler.
Chapter 1. Yeah. Oh, yeah. There are 2 sprinklers that are designed to suppress fires in storage buildings, right? The ESFR, the Early Suppression Fast Response, or the CMSA, the Control Mode Specific Application Sprinkler. And we won't talk too much about storage today, but we certainly have a lot of storage issues across the U.S. We build multi-million square foot buildings, warehouses, Walmart, Amazon, whomever, multi-million square foot buildings protected by sprinkler systems. And what's inside those buildings is high power storage, right? High power storage on racks, and the building height just goes higher and higher. Some of the fires we're seeing recently in some of these large warehouse buildings, doesn't really have to go back to, don't really back to sprinkler failure, but it really goes back to a lack of communication. Some of these buildings, and you probably have seen them too, and some of these storage buildings have what's called ASRS, automatic storage and retrieval systems. These are automated mechanical picking systems that ride on a rail or ride on a trolley, or I have robotic features that go and grab a product, drop it in a basket, so it can get shipped to you for next day. So some of those systems are very intricate and they're very proprietary. So and that's where we're seeing some of the problems in the industry today. So, but Chapter 1 covers all. I mean, Chapter 1 covers the intent, the scope, the purpose of the standard. Chapter 2 gets into the reference publications. So as inspectors, we know that there's a code path, right? In order to get to citing something from NFPA 20 for fire pumps or NFPA 22 for tanks, there's a path that we have to take as code officials in order to legally enforce it. So that's what Chapter 2 does in NFPA 13. It gets us to these other standards. This book isn't dependent all on itself. It's dependent on all the other reference standards. So knowing that there's a code path, there's a path to get to the standard you're wanting is important. Also, just so the path to NFPA 14 for standpipes, for combination systems, that's there. 20 for fire pumps, 22 for tanks, et cetera. And on. There's like 4 pages of reference standards. There's also standards in Chapter 2 about manufacturing standards. So where as code officials you should have NFPA 14, 20, 22, 25, and all of that. There's some ASTM standards also in Chapter 2 that as code officials you really don't need. And these are like pipe manufacturing standards and listing standards. And they're there. They're there for the manufacturing side, but not so much for the inspector side. Chapter 3 gets into definitions, and definitions are there's no sexy way of talking about definitions except to say, they're there, and that's what the standard is trying to get to, the defined term. So when you see a defined term in the standard, it applies to that standard. In NFPA land, the definitions in the standard only apply to the standard, whereas in ICC, when looking at the mechanical code, the Michigan Building Code, the Michigan Residential Code, if there's a definition in one of those books, you can use it across all of those books, right? So in ICC, if they define it once, you can go grab it and use it. In NFPA, no, it's only applicable to that standard book. A good example of definitions is the term limited combustible. NFPA only talks about limited combustible, ICC doesn't. But limited combustible kind of sits between combustible and non-combustible, right? It becomes, really it's like this much text to explain that we're talking about drywall, right? It talks about BTU and flammability and non-combustibility, all that stuff. But the term definition, the definition of limited combustible is different from NFPA 13 than it is in NFPA 101. And it's different from the definition in NFPA 221. They all kind of modify the definition a little bit. But that's okay because it applies only to that standard. Definition-wise, there's a definition for automatic sprinkler system in NFPA 13. And it has to do, and it really comes down to the 4 parts. It comes down to water supply, it comes down to water flow alarm, a valve, and a drain, right? Those 4 things make up a sprinkler system. And you're like, yeah, so what, Jeff? What does that mean to me? Well, it means that when the building code or mechanical code requires a sprinkler system to be installed, right? The standard tells us how to put it. So if the code tells us when to put it in, the standard tells us how to put it in. So the how applies back to when, right? So when I talk about a fully sprinklered building, that means fully sprinklered according to NFPA 13. So with that comes with like 125 plus different trade-offs that apply to fully sprinkled buildings. And it doesn't land on the mechanical inspector too much, but you're usually the voice to say to the building side to say, yep, everything's good, it applies. So recognize that. Recognize that the system installed according to the standard is what gives it to the building code all the different trade-offs that apply. So for the last 50 years, we've increasingly ratcheted up the trade-offs that apply to sprinkler systems. And we've seen the most building code and standard growth in this country in the last 50 years. So, and it's changing it seems like every cycle, right? We're dealing with stuff today that we didn't deal with 10 years ago. You know, cannabis extraction. You know, 10 years ago, hell, 5 years ago, we stay in this room and laugh like, oh yeah, cannabis, yeah, that's not going anywhere. It's a multi-billion-dollar industry in Michigan, and cannabis extraction is super important. But that industry itself is changing, right? We get questions all the time. How do you protect a cannabis grow facility? You know, how do you know? Because and the answer to every fire protection question is what? It depends, right? That's the answer. And you can become an expert just like me by saying it depends, you know. But in cannabis, they're growing them on racks and totes, on high-powered racks. They're growing them vertically. There's just so many different methods that, you know, there's really not one protection scheme that covers all that. So again, going back to definitions, trying to get back to, you know, what the standard is trying to cover as technology increases. And being stuck in the 10 and 13 edition is tough. It's tough for mechanical inspectors, especially when you have a brand new whatever facility coming in and you're dealing with an older standard. So, what else in chapter 3? Oh yes, sir.
Does 2016 cover that stuff at all?
No, even the 22 edition doesn't cover that stuff.
That's helpful.
Yeah, very helpful. And the challenge is, from the standards producing side, is testing, right? You know, like the Home Depots and the Lowe's, Bed Bath & Beyond, all those facilities have a sprinkler, specific sprinkler, that in the way they store their product, they went out and tested this sprinkler in this system. So that's why you see Home Depot, Lowe's, Bed Bath & Beyond, all use the same exact system, same stuff, right? On the cannabis side, it's like, you know, every one of their systems has to be designed by a fire protection engineer because there's no standardized way to look at that. That's really becomes the accessibility of NFPA 13 is because it's prescriptive. It's one of the only standards out there you can pick up and go from beginning to end to design the installation and know exactly what the rules are. You know, we as just common people can pick this up and design a system. So getting any industry to test their product and come up with a standardized scheme is difficult, especially the cannabis industry. They're all over the place, right? So yeah, it's not very helpful. The other areas that NFPA 13 does not cover is lithium-ion batteries, right? So the storage of lithium-ion batteries, recycling lithium-ion batteries, you know, the amount, the quantity, 13 does not cover it. Why? Because there's you know, very little standards on the lithium-ion battery end of it. So it's a good point. NFPA 13 doesn't cover everything. There are times we have to go to a fire protection engineer to get our design. Any other questions?
Who do you have to go to?
Fire protection engineer.
Fire protection engineer. Fire protection engineer.
Yeah. They're the ones who would design the system for the areas not covered by 13. Cannabis, lithium-ion batteries, boat storage, carpet storage. There's many. There's many old things, you know, like rolled carpet storage is another one that 13 does not cover. Certainly not new, but even we cannabis. So like the 2018 edition, 2021 edition of the I-codes the International Fire Code has a chapter on cannabis right now and lithium-ion batteries, and for the most part, both chapters point to NFPA 13 for the design criteria, but 13 doesn't have it. So again, it goes back to the fire protection engineer as a specific design for that use or occupancy. Yeah. Same sprinkler, same pipe, same hangers, you know, same everything. It's just they're going to design the water supply for it and the density for it and whatnot for it. So, yeah. High challenge fires, and then Chapter 4 of NFPA 13 gets into general requirements. So the general requirements apply to all sprinkler systems. whether they're partial, whether they're limited, whether they're in a warehouse, whether they're in a house, or whether they're in a high-rise, whatnot. Chapter 4 applies to everything. So a couple things in Chapter 4 are really, really important. One is water supply, water additives. So Chapter 4 tells us we can't put additives in our system to prevent, leakage, right? We can't put salt in our water to prevent leaks in our system, right? But it does allow additives that may reduce like corrosiveness. So there are additives to water systems, to piping systems that reduce the corrosiveness of that water. And that goes upon the owner to investigate. In Chapter 4, there's a thing called an owner certificate. It's been in there since the 2007 edition. And we talked about this last time I was here too, is the owner certificate becomes really important to the mechanical inspector. It's a document that goes from the owner to the sprinkler contractor in the owner's words saying, this is the building I'm gonna build, right? It's gonna be about yay big, yay tall, and I'm gonna do this, and I'm gonna manufacture, I'm gonna store, I'm gonna sell things, whatever. It's in the owner's words. The sprinkler contractor takes that and of course designs the system accordingly. So that owner certificate, I think, is very crucial for a mechanical inspector or the department to get. Because again, 10 years from now, we want something that says, hey, Mr. Owner, this is what you said you were gonna do compared to this is what you're doing now. We need to get back to square one. Hopefully it doesn't take 10 years to get there, but it's really big time. So how many of you guys are getting how many of you are getting the owner certificate with your plans?
With the plan?
With the plan, yep, get the plan review. It'll come in the plan package.
Well, they haven't been coming in the plan package, what we asked for.
Okay, you're getting it.
Eventually.
Yeah. It's eventually, because it's kind of funny, because it actually is the first document. Once the contracting owner and sprinkler contractor is done, that's like the first document that comes back to the contractor. So it should be readily available.
Well, what's happening too on a lot of these marijuana grows is you're getting deferred submittals.
Understood, yeah.
And we have a note in our plan review comment, there will be no work commenced, no permit issued until that engineer of record, first the fire suppression contractor gets him the plan, and then he puts his stamp on it.
Okay.
And I know fire suppression plans don't have to be stamped engineer drawing. However, they are going to take full responsibility for it.
Sure. Well, in the cannabis grow, that's exactly that's the point, right? Yeah.
It's a different world.
It's a you saw it.
And then they like to do them in phases. Okay?
Yep.
And now we're finding they're bringing in paint as C1, D1 rooms. I'm sorry. I don't agree with them, and that's where I'm at right now.
That becomes a struggle with developing a standard every 3 years, right? Is trying to keep up with that. We're, as an organization, we're working on right now the 2025 edition of NFPA 13. We just got done, the 2024 edition of the I-Codes is essentially done. The 2024 edition of the Mechanical Code is done. 24 edition of the IBC, building code, fire code is done. Right now in this cycle, this year, we're in the residential code, the building side, and the existing building code. By September, it'll be done. It won't be published till the fall of next year, 2023. And it probably won't be adopted in Michigan until, yeah, we hope, right? 30, yeah, I think we got 3 in there. But I don't see any, any really good quick fixes for cannabis or lithium ion coming in the next 80 few years. I mean, they're just all over the place. I was in New York City last week. We were discussing lithium ion batteries above the 50th floor. Like lithium ion battery storage above the 50th floor. I mean, you gotta be crazy to have storage that this, and what's fueling this is the birds, the little scooters, right? The charging those scooters goes back to someone who wants to charge them at their home or at their business and earn a little bit of coin by charging them and delivering them and pulling them back. Well, there's been a few fires in these high-rise buildings, these multi-high-rise buildings, right? Like 50, 60, 80th floor. And it doesn't really matter where it's at. When it's at the 50th floor or the 60th floor, it doesn't matter. Access to that is the same, right? Through the elevator, through the stairways, whatnot. There's no way to get to that from the outside. So, very difficult, a lot of challenges, and technology doesn't seem to wait for us to develop rules. And that's been the big change in the last 50 years, in the last 20 years, right? So, Chapter 4, most important part of that is the owner certificate. The owner has a responsibility. One of the big owner's responsibility is water supply, and verifying that the water does not have the overly corrosive properties, such as what creates, mic and other, microbiological creatures that grow in piping. All right, what else we have here? Oh, getting over from chapter 4, next chapter 5 becomes our hazard chapter, right? This becomes the beginning of our plan review, is verifying what classification that building or that space has been determined. So where like the building code talks about construction type, talks about the structural members, type 1 concrete, type 2 steel, type 5 wood. NFPA 13 has their own classifications, and they're trying to classify the space, right? The room that the sprinklers are in. Whether it's light hazard, ordinary hazard, extra hazard. I think you probably all heard these terms before, and it really, if you take nothing from today, take this away. Light hazard, ordinary hazard, extra hazard are just classifications, right? We have low combustibility, low flammability, low heat release, a light hazard. As we go to ordinary, we go up, and as we go to extra, we go higher. So as the flammability, as the fuel oil increases, what are we doing with sprinklers? Bringing them closer together, right? Light hazard sprinkler spacing is maximum of 225 square feet. Maximum spacing for ordinary hazard sprinklers, ordinary hazards, I should say, is 130. For extra hazards, it's 100 square feet. So as that goes up, bring the sprinklers closer together, and when we bring sprinklers closer together, we're increasing the density, right? We're increasing the water that goes through that sprinkler. That's it. If there's nothing today, that's it. If Sue wasn't here, we could wrap up and be done. But she's here, she's gonna make sure we stay in this room till 4 o'clock. Anyway, chapter 5 also talks about commodities. When you get into storage, right? We take the storage facilities, Amazon's, Walmart's, whatever. That storage building is determined by commodity, right? What's being stored. So we have a few different classifications of it. There's class 1, 2, 3, 4. Class 1 and 2 are not combustible. Class 3 and 4 are combustible. Then we get into the plastics. So Group A, Group B, Group C. So that all lands in chapter 5, and it really becomes more of a plan review issue than it does a rough or final inspection issue, right? If they're gonna store Group A plastics to 45 feet, that's a plan review thing. Right, we should look at that on the plan to go, okay, here's the scheme for Group A plastics stored at 45 feet. There's a chapter dedicated to that in the book. We'll get there. So this is often step 1 in plan review. But it's often another step that we hit when we're doing existing buildings. What's in that existing building, what's in that space. If I go back here again, not every building has one classification, right? So in this building, the hotel we're in right now, we're in an assembly space right now. This would, if it was sprinklered, it'd be light hazard, right? The dwelling units, the residential rooms are light hazard. The restaurant, the seating area is light hazard, but the kitchen's ordinary, right? The kitchen's ordinary hazard. The laundry room, which I think I'm sleeping next to, is also ordinary hazard. So it's very common that a single use building, such as this, an R1, has multiple or mixed standards. So, very common. So 13 goes by the space, not by the construction. So chapter 6, 7, 8 really becomes our field inspection. This is the stuff we're looking at when we're going out into the field. We're doing a rough inspection or a final inspection. Chapter 6 talks about listing requirements, right? Or if you can imagine the supply truck to the job site, and on that supply truck is the pipe, the hangers, the fittings, you know, the bit couplings, the sprinklers, all of that. All those things that are required or are allowed to be in the building or in the system come out of Chapter 6. So if you're looking at looking at a pipe and wondering, well, does that comply with 13? There's a table in 13 that says, here's all the pipe that can be installed in sprinkler systems. Steel, CPVC, there's some other non-metallic pipe in there, you know, copper, you know, Schedule 10, Schedule 40, you name it. And also with that table comes an adjoining fitting table. So we'll talk about that as we get a little deeper. But you know, the question of does that valve on a sprinkler system need to be listed? You know, listed for fire protection. The answer comes out of Chapter 6. So there's very, very few things that an NFPA 13 doesn't require to be listed for an NFPA 13 system. Vastly different from an NFPA 13D system. So we talk about sprinklers in homes and townhomes. Probably see more sprinkler systems in townhomes in Michigan than you would in homes, but those are sprinkled according to another 13 standard, what's called NFPA 13D. NFPA 13D does not require anything to be listed, right? So you can use plumbing, the same plumbing pipe that you use for your house. You can use PACs, right? You can certainly use copper, but PACs, multi-purpose systems, are probably the majority installed sprinkler systems in single-family dwellings and townhouses. But the valve, you know, so the valves and hangers and all that need to just comply with the plumbing code. So just because it has a 13 in front of it doesn't mean everything needs to be listed. Big difference from an NFPA 13 system to a 13D system. In between the two standards there's another one, 13R. So this document, in 1896 was the first one. NFPA 13D came along next in 1975, and then NFPA 13R for our 4-story, you know, multifamily buildings came along in 1987. So more useless trivia for you, right? The stuff that lives in my head. Chapter 7 on system requirements talks exactly what it sounds like. Wet system, dry system, pre-action system, deluge system, all in Chapter 7. So those specific rules for those systems lie in Chapter 7. Chapter 8, we spent a lot of time in Chapter 8 because that's all the spacing, the positioning, the spacing of sprinklers, you know, how many square feet, how far apart from each other, how close can they be, how far from the wall, how close to the wall, obstructions, right? Is this bulkhead, is that an obstruction, et cetera, and on and on. Chapter 8. Chapter 8 also gets into where sprinklers are exempted or are permitted to be omitted, as NFPA likes to say. So, you know, concealed combustible spaces or concealed non-combustible spaces, our sprinklers required. You find that in Chapter 8. Fire department connections, piping for fire department connections, valves, different appurtenances to the system, again, Chapter 8. So Chapter 8 really becomes a spot that you spend a lot of time in. It becomes like the junk drawer, right? When they find nowhere else to put this in the standards, they put it in Chapter 8, which is what really triggered the reorganization in the 2019 edition. So they broke out Chapter 8 into like 10 different chapters because that's how much information is in Chapter 8. So you'll spend a lot of time in Chapter 8 in plan review and in field inspection, right? When a bulkhead becomes an obstruction on the job site, when you see that, that's going to come out of Chapter 8, right? All right. Chapter 9 is all about hanging the pipe, supporting the pipe within the ceiling or to the structural members. Thanks be to God, you live in Michigan. You don't have the seismic bracing requirements. Actually, you do have seismic bracing requirements now more than you did in the past. So we recognize in the U.S. that the earthquake zones in the U.S. are out west, right? California, Washington, Oregon, and I sat on your side for many years. And when it came to seismic, I just did this, right? We don't do seismic in Michigan. Move on. But as code officials, you're going to see more and more seismic every single year, right? There are areas in Michigan that are in the seismic design category of C, believe it or not, because of the soil, because of the earthquake activity within Michigan has increased within the last 10 years. There was no earthquake activity in Michigan prior to 2000. right? It's like zero, like not even enough to even record. We've had more activity in the last 20 years than we've ever had. They say it's from fracking. I don't know. That's usually like one of those political grenades you toss out there. I don't know, but I do know we have more seismic activity. So you may see seismic bracing. You may see seismic bracing requirements. I'm going to forego any of those requirements today. But when you do see it, it comes out of Chapter 9, Section 9.3. And the whole idea of anti-seismic bracing is, as that building goes back and forth, to and fro and up and down, because that's what an earthquake does to a building, it's trying to take that network of piping and tie it to the nearest structural member. So if that floor sitting assembly above is moving one way, we want the system to move along with it. So while we have a dead load of piping supported by hangers, the horizontal force, the horizontal load of that piping is also a factor in seismic, when seismic bracing is required. So we're trying to support that horizontal load, what's called bracing. There's lateral bracing, there's longitudinal bracing, whatever. So if you're on a federal job, for whatever reason, as a local inspector, maybe you're doing something with a federal job, or even a hospital. Hospitals that are federally funded require seismic bracing. So that's where you may see it. So, have you seen seismic bracing? Okay. Very low. Yep. What's out there? And if you travel, I mean, when you do retire, if you go to Florida, you're safe. If you go to California, you're not. If you want to keep doing what you're doing, seismic bracing is not difficult. A Michigan boy here can tell you, I can help you out with seismic bracing. So, but we'll bypass that today. Chapter 10 is about underground piping, right? You dig a trench, put the pipe in there, that's underground piping, and the rules for that come out of Chapter 10. And it's also the same as NFPA 24, which is the standard for private water mains and water supply. So often in NFPA land, one standard or code will write the rules, the other standard will extract those and put it in their document, and that's really what Chapter 10 is when it comes to NFPA 13, underground piping. We'll talk about underground piping here in a bit. Discharge rules. So Chapter 11 becomes like Chapter 11 answers the question, how much water? How much water do I need? How much water will the sprinklers flow? All out of Chapter 11. Then Chapters 12 through 21 are all about storage. So if you have a storage facility like a Walmart or Amazon or whatever, right? I don't mean to keep using those as examples, but they seem to be the big ones. Your plan review and your inspection, your rough inspection, final inspection, starts in Chapter 12, right? Chapter 12, that's really what's made the bulk call. So if you recall in 1996 edition of NFPA 13 was like that thick, right? Literally that thick. And now it's that thick. Why? Well, it's because in 1999, we brought in all the storage fire protection standards into NFPA 13. NFPA 231, 231C, 231D, and Chapters 12 through 21. That's all storage, all about storage. So that's what made this book as thick it is now, and getting thicker. So the general rules for storage in Chapter 12. Chapter 13 talks about miscellaneous storage, which is which kind of sits out away from Chapter 12 and all the storage stuff, because you can have miscellaneous storage in any building, and the rules for such are in Chapter 13. Basically, if you have 4,000 square feet of storage, miscellaneous storage, right, on racks, in piles, on shelves, you go to Chapter 13 and grab your criteria from there. So the rest of the storage chapters, are really specific on what they're trying to store. You can see, like Chapter 16 is class 1 through 4 on racks, and Chapter 17 is the same rack storage, but protecting the plastics and other commodities as such. All right. 18, 19, 20, 21, again, more storage chapters. Chapter 21 is probably like the chapter to watch. So some of the newest storage protection criteria lands in Chapter 21. So another thing that the 10, the 13, the 16 edition doesn't cover is expanded Group A plastics. So oh gosh, the enclosed Group A plastics that are expanded, so your styrofoam cups, right? There's very little criteria that covers that in the current edition, or in the edition that we cover. But Chapter 21 comes that place where this new technology does land. So you'll find some new storage protection schemes in Chapter 21 once you get to a later edition. And then Chapter 22 is special occupancy requirements. Again, another spot in NFPA 13 that goes out to the other NFPA documents and grabs the sprinkler requirements from there and drops them in NFPA 13. So like LP gas plants, and there's some battery criteria in Chapter 22, but it's more like lead acid, not lithium-ion batteries. So there's like 42 different areas, 42 different specific occupancies in Chapter 22 that's covered by 13. So it's kind of helpful because you don't really need all the other books. If you're just looking for something that's sprinkler related, it's usually in Chapter 22. All right, so chapters 23, 24, more plan review stuff, like, calculations. When we talk about plan review, we spend a lot of time in hydraulic calcs. How to design a system, and then we do it in a class where we come back and say, this is how you review those calcs. So we have classes that we teach on how to calc systems, and we have classes that say, how do you review these calcs? So that's our plan review class, but plans and calcs, what's required on a set of shop drawings, comes out of Chapter 23. And there's like a 44-item checklist in Chapter 23 that says you got to have the valves on the plans, you got to have the names on the plans, you got the north arrow on the plans, etc., and on and on. So if you're doing plan review, Chapter 23 really becomes that area of, what is the remote design area? How big is it? What has to be on the plan? Do I really need calc sheets? Do I really need a water supply graph? Do I really need, shop drawings? So, and the answer to all those are yeah. Chapter 23 tells us these are all part of the complete review. Plan review consists of at least 3 sets of documents, right? Your shop drawings that come from the contractor, the hydraulic calcs, and then the cut sheets or the submittals. So that really becomes the plan review. So make sure, we're not talking about plan review today, but again, that's what you need to get. And then acceptance. So one of the things we'll talk about today is that Chapter 25, system acceptance. What needs to happen to put that system into service. The 200 PSI hydrostatic testing, the main drain test, and all that stuff comes out of Chapter 25. And then probably the one thing that's probably the most ignored is Chapter 27, right? It's the inspection, testing, and maintenance. It's the shortest chapter in the entire book, and it basically points the user to NFPA 25, which is the standard for inspecting, testing, and maintaining all water-based systems. And NFPA 25 is enforceable by all of you, right? So your building code references NFPA 13, it references the fire code. Through the fire code, you can enforce NFPA 25. NFPA 13 references NFPA 25 to maintain the systems that are put in. So NFPA 25 is enforceable. And it's another good document to have, and probably another good class to have, is to understand what's in 25 and what it's trying to say. And sprinkler systems aren't a one and done, right? We don't install them and leave them. No, they're maintained on weekly, monthly, bi-monthly, and on an annual basis. There's testing, there's maintenance, there's frequencies even at 3 years and 5 years that NFPA 25 requires. Yes, sir.
As you can see, if these buildings aren't maintained, most of the time, if they do have a fire, the insurance company's not going to cover it.
Okay.
A lot of these people wonder why they have trouble getting money out of the insurance company if they don't do that annual inspection to the fire department or the fire inspector. SOL.
Yeah, I've heard it both ways. Some insurance companies, it doesn't matter to them. I don't know why, but to the owner, this benefits the owner, right? Maintain your system, make sure it works. Because when it works, there's very little business downtime, right? We see fires all the time. We see sprinkler saves every single day across the country. And if one or two sprinklers activating and, you know, the water's cleaned up, whatever is put back together, business is done, usually back up the next day. In a non-sprinkler building, we see the direct opposite. You know, the building burns and it gets wiped out. But, inspection, test, and maintenance, again, is super important. And again, enforceable by everyone in this room. And I wouldn't leave it, so a lot of times it's left to the fire department. And we talked earlier that usually the fire department doesn't have a whole lot to say when it comes to code enforcement here in Michigan. But some of them do have a pretty effective ITM program. They'll use a third-party vendor like Brycer or Compliance Engine or iRoll or some third-party dashboard that allows the contractor and the owner to do their inspection, and then the contractor submits their inspection report through this third-party vendor, and then you as AHJs or code officials have that on your dashboard, right? So you can see on a daily basis what system is in compliance, what system has deficiencies, what systems are impaired, and then it becomes your responsibility to enforce that, right? When a system is impaired, that means it won't work, right? A valve is shut off or whatnot. So again, NFPA 25 is one of those areas where in Michigan doesn't get a whole lot of love. Some areas they do, Michigan not so much. But one of the other things that you probably walked in this morning, you didn't know that you couldn't enforce, but you can enforce, and probably should be enforcing. And sorry for adding onto your workload this morning. I always bring good news. Then way at the bottom is marine systems. So the coast, so these are the Coast Guard rules in Chapter 26, which for the most part in Michigan, we're, you know, in the inland, the inland inspectors don't have much to do with this, but the Coast Guard rules for piers and wharves and docks and whatnot land in Chapter 26. So for years ago, the Coast Guard tried to get their rules updated, and they had to go through the CFR, right, the Federal Register. Well, try to tell your senator or your representative, hey, I need to increase the density of this pier suppression system because it's too low. You know, talk to a senator, and they're like, what? We you know, and so it took years for the Coast Guard to get rules updated. So the NFPA finally convinced the Coast Guard and the feds to put the rules in here so they can be updated on a 3-year basis. So there is a little bit of wisdom at the federal government, a little. All right, so organization-wise, you know, we talk about NFPA 13. There's a little bit of a rhyme and reason why they arranged the way they've arranged these chapters, right? Most chapters are arranged to where your most prevalent item is in the beginning of the chapter. Most. I put that in quotes, air quotes. And Chapter 7 is a really good example. So in Chapter 7, most of the systems you look at or review are wet pipe systems. So in Section 7.1 are all the rules for wet pipe systems. The next system you look at the most is dry pipe systems. So 7.2, all the rules for dry pipe systems. And on and on. As you get down that list, you can see, well, I don't do too many refrigerated spaces, Jeff. I don't do too many antifreeze systems, Jeff. Well, right, we know that. And 13 knows that. That's why it's kind of down on that list. So, antifreeze is an interesting animal that has yet to settle on something. So antifreeze was banned 10 years ago in 2012, and it had a 10-year ban with a September 30th, 2022 sunset this year. So in a few months, this sunset's going to occur to where the antifreeze that's installed in existing system has to be upgraded to listed antifreeze. And it's taken the industry almost 10 years to come up with a listed antifreeze. So listed antifreeze, there's 3 of them out there. Lubrizol makes 2 and Tyco makes the other one. But anyway, new antifreeze systems has to use this listed antifreeze, and by September, existing systems have to use a listed antifreeze. So if you have an antifreeze system in your jurisdiction, it could stay that way until September 30, 2022. Then now they got to upgrade. So you want to talk more about that? We'll talk more about that. But that's some of the latest and greatest. And then Chapter 8 is another good, again, I told you Chapter 8, you'll spend a lot of time there, right? You'll spend a lot of time in plan review, you'll spend a lot of time in field inspections in Chapter 8, and spacing and obstruction and all that jazz. And there's a little bit of wisdom here, right? So you look at Chapter 8, what's interesting about this slide here is that each sprinkler type you have your standard spray, upright pendant sprinkler. It's all in its own section, 8.6. So all the spacing and obstruction rules and whatnot for that standard spray, upright pendant sprinkler stays in 8.6, right? And then if you get into residential sprinklers or storage sprinklers, they all have their own sub-chapter within Chapter 8. So, and I bring this up just to make you more efficient as code officials. Not to bore you to tears or put you to sleep or go, oh my gosh, he's talking about a book in the book layout. I bring this up to make you more efficient, just so you know what to look for when you're looking for it. Certainly we do word searches on our PDFs or on our web versions. Certainly we go back to the index and try to find where we're going. But knowing where you're going is a lot better than not knowing where you're going, right? So I guess that's my Google talk. So sidewall sprinklers at 8.8, get to the extended coverage, sidewall pendants 8.8, 8.9. Residential sprinklers certainly are a thing, and NFPA 13, all 8.10. So if we go into the next slide here, what's really important here is that each subchapter of sprinklers is laid out exactly the same. So if you want to know what the maximum distance of a sprinkler from the wall is for a standard spray upright pendant sprinkler, you would go to what, 8.6.3.2, right? How far from the wall can a standard spray sprinkler be? Well, it's going to be 8.6.3.2. When I apply the same to a sidewall or an extended coverage sprinkler, I would plug that subchapter number in, right? If I want to know what that was for residential sprinklers, I'd go to 8.10.3.2. So once you kind of know this layout, finding where you want to go is very specific and very easy to get to. All right. I think you've had enough for now. Let's take 10 minutes for break. All right, so we're gonna, if you've been to Jeff class before, I do kind of find some sweet spots to work through, and I'm gonna, through your handout, I'm gonna skip a few slides, maybe 100, and get to this module 4, which is rough inspection, and we'll get into final inspection, and then if we run out of material, we can backtrack, but usually I don't run out of material. Usually I talk too long. So we'll go to module 4. If you have the handout, it's in there.
What page do you have?
No, I have no idea.
142.
I heard 142 over here.
It says on the bottom of the slide, 142.
We don't go that far.
No.
78. Slide 142.
Slide 142, yep. Yeah, if you got the whole package, it's in there. Is this working out okay? Is the microphone?
No.
No?
No.
I wonder if we can turn it up louder.
Is it on?
I think it's on.
47.
Yeah, break it up.
I get close to my mouth. It's just hard to walk around with a mic like this. It's hard for me to stay put. So I know. I can walk around. I could walk around like this. It's just hard. But if this is what you prefer, I'll do it for y'all. Because you're all mechanical inspectors. I'm the only building guy. You like this better? He does. Okay.
Guys in the back have a real hard time in this room hearing you.
I understand, but there's all kinds of seats up front, guys.
There you go. That's
Yeah.
right.
I told them to have pastors to move up to the front.
Oh, good, yeah. This isn't church. You don't sit in the back, you come to the front. Well, yes, sir.
Hi, Jeff.
Hi, Joe. All right, well, I'll go this way. I'll go this route. And I'll try to remember to turn my head with the mic, unlike I did 3 years ago. All right, rough inspections for sprinkler systems. You all ready? Any questions during break? We had a little Act 54, 407 discussion. The Chapter 9 registration. I don't know exactly where that is in 407, but I do know they have a fire marshal, a fire inspector is doing inspections and doing plan review, they need to be registered. That's kind of like the end of the story, right? They need to be Act 54 registered. And there's
now there's in the state level.
Yep.
There's roughly almost 40 pages of amended comments from 54 and adjusting 407 to comply with the old 54. And it does mention in their fire inspectors, if they want to do what you're saying,
Yep.
what we do, they have to get registered as mechanical inspector.
Okay. Okay. All right. All right, let's move on. Rough inspection, we'll get it underground. So, underground in Michigan is handled by whom? I don't want to step in it like I did last time, so.
Excavator.
Excavator, good, yeah. All right, who inspects it? Plumbing inspector, mechanical inspector?
Nobody.
Nobody, okay.
It's supposed to be.
The fire inspector, there we go.
We never get called.
Underground
Yes, sir.
water engineer. Right.
Yes, sir.
For fire suppression.
Yes, sir. Plumbing inspector, right? Okay.
Before the backflow was done.
Right.
Do the wet backflow preventer.
Okay. How many plumbing inspectors in here? Yeah. All right. So we'll talk a little bit about plumbing inspection, right? We'll talk about this underground, which is what chapter in NFPA 13? We went through all the chapters. Oh, we got to do remedial work already. Oh boy. All right, let me back up a few slides. No.
It's in NFPA 13.
Yes, sir. What chapter?
No, it's in NFPA 13.
It just
That's all
said-
we need to know.
Okay, it's just in 13.
It's in the
Say,
index.
yeah, I just looked at it. It's chapter 10, right? So chapter 10, NFPA 13 is all about underground. It's also the same chapter 10 defined in NFPA 24, which is the standard for private underground water mains. All right, so what are we looking at? This is really what the whole class is set up to, is what do you see with your eyes when you're in the field? So I'm gonna look at a lot of field pictures. I didn't take a lot of these. One of my friends from Oregon did, so some of these may be Oregon specific. So underground, we're certainly looking at for the piping that's approved for underground. So earlier I said chapter 6 tells us what can be in the building. Well, everything with underground pipe stays in chapter 10. So what's approved for underground pipe, go to chapter 10. So your C900, your Blue Root, your cement line ductile iron pipe, the prohibition on plain Jane steel pipe as underground pipe, that's also in chapter 10, right? You just can't bury steel pipe underground and call it good for underground. That's one of those pipes that's prohibited. Not exactly prohibited. There needs to be some additional corrosive measures applied to the outside of that steel pipe. But the rules are going to land in chapter 10. All right. So one of the things we're looking at is the bury depth, obviously below the frost line. And so NFPA 13 applies internationally. So there's a lot of different nuances in there when it comes to burying pipe. So it's got to be at least 1 foot in the ground, but here in Michigan, our frost depth is 42 inches. It's got to be below that. Right? Difference between fire sprinkler service piping versus the domestic service piping is this. Fire sprinklers don't flow water all day, every day, like the domestic water does, right? So water is stagnant. So it's going to freeze quicker than the domestic. So we always usually bury our sprinkler piping lower than our domestic piping. So that's where NFPA 13 gets in, right? So bury below freezing, protection from mechanical damage. What else do we have in here? Restraint. So fire sprinkler piping is subjected to more pressure than domestic piping. That's why a lot of piping, a lot of things are listed in NFPA 13. You may look at a valve and go, well, that valve is the same valve as that plumbing valve or that mechanical valve. Why is this one different? Why does 13 require this to be listed? Well, usually it's due to pressure, right? We have higher pressures than domestic plumbing. So with that, as we dig our trench and put our piping in, we have a couple different ways to resist the pressure of that pipe, the velocity of that pipe through that underground. It's called thrust blocks, right? We can install thrust blocks, or we can have mechanical couplings that act as thrust blocks, like the Megalux system. So thrust blocks are poured concrete, right? They're that photo on the left, and they're neatly formed and poured and finished just like you see there, right? Every single time. You all see thrust blocks like that? Yeah, you do. Usually it's like a cement truck and a guy, or away you go. But really what all that concrete is trying to do is act as the space between the pipe coupling and the virgin soil, right? The undisturbed soil. So when that thrust goes through that piping, it doesn't push that joint apart, it's pushing against that thrust block. So, again, on all the plans, on all your plans, you have the thrust blocking requirements, and you also have, on your plans, in your submittal, you have the piping system, the mechanical piping system, such as Megalog. So again, everything goes back to your plan review. If this is what we looked at in the plan review, this is what we're looking at in the field.
Yeah.
Yes, sir.
So what plan review are you talking about? The mechanic, or the fire sprinkler guy plan review?
Yeah, fire sprinkler plan
But
review.
didn't somebody just say that this is the responsibility of plumbing?
That's, well, it's, yeah, good point. Whose responsibility is, who looks at this in plan review? It's part of the fire sprinkler plan review. Whose responsibility is to do the fire sprinkler plan review? This is part of it.
In our area, it's a problem. We make the fire protection guy be responsible for that main. It's part of his design. But then they tell us in other jurisdictions, it's the plumbing. Well, the problem with the plumbing is the plumbing code allows excavators to put it in and pull it in.
Right.
For what, if you're gonna classify it as a water service. So I'm just trying to figure out
Yeah, I never
what's
quite
the
got it
right
figured
way.
out.
It's gotta be designed, and you can't have a sprinkler guy saying, I only go 5 feet outside.
Right.
And then he has no responsibility if they're bringing a 4-inch or 6-inch, when he needs a 6-inch or bringing a 4-inch. How the whole design goes.
Looking at the plan review to make sure, the calcs work out right, and we use the right material, but the permit and actual inspection, so what we did in Bay City was the plumbing inspector would do the underground. But you're right, they get confused, not the plumbing inspector, but the excavator who's putting in the water service main for domestic says, hey, this is, what you're doing here is totally different than what I gotta do over here, so they do get confused, but we get this guy here.
At the property line out, it falls under Public Act 300, which would be the municipalities of the water provision.
At the property line, right, it goes to the utilities. Yep. Yep. Yeah, it's not really, it's not cut and dry. All I know from my perspective is the fire sprinkler system is installed, we review that, we look at it, it might land under somebody else's jurisdiction. Does that mean we give them that authority? It's no different than a fire alarm system between, building inspector and electrical inspector, right? They're looking at the electrical connections, the building inspector looking at locations. Same difference here.
Because if the plumber's looking at it, he might look at it and say, yeah, it's C900, it's fine. But we're gonna look at it and say, it's C900, but it has to be FM rated, which is a totally different one.
Right.
Now, who's wrong now? We gave the responsibility to the plumbing inspector, he went to his code. And
Yeah, where's your code taking you? Your code is taking you to 13, right?
Right.
And the 13 says this is the way underground goes for fire protection systems. So,
Because I had that and it made them mad when I told them they had to take it all out.
yeah, maybe not. When I was in Bay City,
Well,
I
this was approved already.
too. So, I don't know. At the end of the day, it's someone needs to look at it, right? There's hydrostatic tests that are performed on underground piping. And there's also what's called an underground certificate, which is again part of your inspection. We'll look at that here in a second. But when this is all done, this is another document that you get put in your file for this project, and that's the underground certificate. We'll look at here in a second. So yeah, this is one of the underground tests. So your excavator that's doing domestic service lines, this is foreign. This is foreign language to them. Like hydrostatic what test what? I can't backfill this until when? Until you do this, right? You need to hydrostatic test it. You can backfill a little bit. You got to leave the joints exposed, and this is the inspection. Yes, sir.
In two of the cities I work in, they do third party.
Okay.
The water department's hired an engineering firm because they're on site all day long.
Okay.
As the job's progressing, so it's done by an engineering firm, and then I pick it up. It's weird because then I wind up, as a plumber, I gotta do the store, that's all I get to do.
Right.
That's commercial. But, yeah, that's how we handle it. But then once we get inside, we handle all the flush. They do a hydrostatic pressure test on the mains. And then once we pick it up for the flush and what have you for the fire suppression.
Okay. So you're getting it through a third party, and as code officials, we didn't accept a third party.
Yes.
And a third party report, so. The other part that the standard excavator doing domestic lines can get tripped up on is this flushing, right? Which is like the most important part, one of the most important parts of fire sprinkler systems underground testing is the flush, right? So we never ever connect the above ground piping to the underground piping unless we know that there's a flush test that's been done. Yes, sir, Pat.
Just out of curiosity, I don't know if you touched on it, over in the vicinity, EIVs, your impression on whether or not they're required, and I'm curious who's requiring EIVs.
Okay, questions, who's requiring post indicating valves? You. So PIVs, this is the valve that's installed in the yard, right? And traditionally it's installed in the yard outside of that collapsed zone of the building, right? The question over there was, you know, I don't think we can require them. They get installed, but I don't know if there's a requirement for them specifically. Certainly a PIV is convenient for campuses and large facilities. I don't think we can actually require them, but I'd love to hear anybody else's thought on that.
There's no code. There is a code. Now, like on a campus.
All right, so, oh no. Class is over. Sun is down. Earthquakes. All right, what else do we have here? FTCs, remote fire department connections. Again, this is all coming off your plan. You're reviewing your plan, going to the job site, make sure it's there. Remote FTC is a remote fire department connection. Kind of built off the same premises as PIV, right? It's a fire department connection that's somewhere not attached to the building. And fire department connections are really, when it comes to back to the building code, it says there's a certain location for fire department connections. I think it's section 912 of the Michigan Building Code. It's one of the very few occasions in the building code where the fire chief has to make the decision on where it goes. So the Michigan Building Code will say, fire department connection has to be on the street visible side of the building. Architects like to put them where? Backside of the building, right? So fire chief can make this call on where this building, or where this FDC is located. All we're looking at as inspectors is the connections right, and the underground's right, and all that. In Michigan may have struck out the fire chief in 912, but in the model building code in the IBC, it's one of the very few cases where the fire chief makes the decision, not the fire code official, or building code official, or mechanical, or plumbing code official.
Is there an alternative to a PIV?
Is there an alternative to a PIV? Yeah, there's wall PIV, there's an
What I'm
OSY.
saying is, as far as the requirement,
No. Is there an alternative to
is
the
a PIV always required?
No, PIV is not always
That
required.
was my question.
A valve is required.
Yes.
A valve, one valve per system is required.
Indicating.
Well, that's an indicating valve. Yeah, whether it's a PIV, a wall PIV, a OSNY, a butterfly valve, those all comply.
Indicator valve.
Yep. Yeah, that's the thing with fire protection, is that the valve for fire protection has to be indicated, right? It's got to tell us whether the
the yoke, by the depth of the yoke, or the length of the yoke sticking out, or some sort of indicator, like butterfly valve, that the system is on. All right. Well, there we go. There's the underground certificate. So again, here's like the second point today. Take nothing from this class. Take this. Take this, that somebody's got to give me a document at this underground stage. Now, whether the plumbing inspector's getting called to do inspection or not, or if you're looking at the inspection or not, at the end of the day, you need to get an underground certificate. And this is done by the contractor, the installing contractor, or the sprinkler contractor, whomever. But there's a series of things that need to occur in that underground installation. We went through them very briefly. You know, the depth of the type of material, the depth of material, where it's installed, the hydrostatic testing was done, and more importantly, it was flushed. Okay. So again, you get this in your documentation, and this is part of the permit package. Yes, sir.
So what are other municipalities seeing? Are the excavators allowed to do the work under the mechanical permit, the sprinkler contractor with their supervision? Or are they requiring the excavator to pull his own permit? Can he pull his own permit if he doesn't have a mechanical license? What's everybody else seeing?
They can only pull plumbing. They couldn't pull a mechanical. Mechanical, section 407 doesn't allow it, like the plumbing lines. That's why we have a problem.
Right.
Now, if it's going in and it's doing both, the fire protection and the domestic, okay, but some of them allow that. We're pulling off domestic for the building plus the fire protection on one service line. Then that would kind of be a plumbing thing, you know, maybe. But if it's dedicated for fire protection and then there's also a domestic one, now we got a gray area.
A little bit of a gray area, right? Because it's a sprinkler permit, right?
Yeah.
You have a mechanical contractor pulling the sprinkler permit. Part of that is the underground. Sprinkler contractor usually subs it out to, help me out, plumbing, you know, the plumbing, an excavator. So, question over here was, what's everybody else doing?
Quite frankly, I don't split hairs between the plumber and the fire suppression contractor in my jurisdictions. To me, studying 5 feet of pipe out for a fire line and having the site contractor come up and mate it up together, to me first of all, it's extra joints, it's a waste of time, and we had a recent job, all the elevations were screwed up, the cluster. I prefer the underground contractor bring it in. Once it gets past that footing, I want an inspection on it so I can verify the thrust blocking, the rotting down from the 90s to the first flange. And it works out very well that way because you don't have two different guys. Scheduling, it's in the building, it's done right, no extra joint, it's over with. I get eyes on it, the engineering company gets the eyes on it up to the footing. To me, it's just a senseless splitting hairs of who's going to put their name on a piece of paper.
Right. So full circle on this, it's a mechanical permit. It's not a plumbing system, right? So the plumbing inspector, plumbing permit would address the underground to the domestic.
Correct.
But this underground here is a mechanical system. So by all rights and purposes, it lands on the mechanical inspector. Now, a lot of you do the same, a lot of you have to do dual register plumbing mechanical to the contractor, to the underground contractor. It looks kind of confusing. That, you know, what are you here to look at? I'm a mechanical inspector, I'm looking at this underground because my code says I got to install it underground according to this document. So it's a mechanical system at the end of the
You
day.
can handle that just by permitting.
Right. It's a, yeah,
All
sprinkler
you gotta do
permit.
is do by permitting.
Right. Sprinkler permit covers this. Mechanical contractors use that permit.
And like you say, I'm fortunate because I do both, so I can run my show.
Yeah. Anyone disagree?
The only thing I don't agree with is that if it's being done underneath the sprinkler contractor's permit, he should at least be overseeing that project, verifying that it's flush, verifying that it's pressure tested, and getting
That
that
is
document.
true.
Because I go in on a final that's, you know, I'm doing for somebody else, subbing or whatever, and everybody said, hey, did it get, the fire department's there, we're there to do a flow and alarm test. Did it get flushed? Did it get pressure tested? And the sprinkler contractor doesn't have a clue. He's like, I don't know. I said, you didn't witness this, you weren't a part of it, you know? So he doesn't even have an answer.
Wow,
You
you
know?
say.
And they want to flow the system, and they don't even know if it's been flushed.
Yeah.
Everything in our jurisdiction is recorded. Everything.
I think this is one of the most important things.
It's in the system.
If it's not flushed and tested, then you're gonna have problems down the road.
And that was the problem we had with the job I did.
Yeah.
That's the importance of the underground certificates. So sprinkler contractor or installing contractor signs this, and again, it proves it's flushed. And
Last one I was there, nobody knew if it.
okay. So this document tells us it was flushed. So you should have this, again, if you're doing nothing else, get this. Tells us it was flushed, tells it was pressure tested. You may or may not have been, you may have not been called for inspection. I think you should be. I really think as mechanical inspector, you're part of this inspection. It's your permit to have the sprinkler contractor go, I don't know. Man, I don't know a sprinkler contractor, I don't know a sprinkler contractor at all, across all 50 states that would install above ground to an underground without having this knowledge of it being flush. Because you're right, because that 8-inch pipe or 6-inch pipe underground can hold a lot of stuff, right? Rocks, debris, Starbucks cups, 2x4s. You know, and where's that water going? That water is going all the way through that system to the half-inch orifice, right? So that pea stone is going to plug that sprinkler when that sprinkler opens. That's the importance of the flushing. So we see a lot of stuff, and you know, being my statement, I don't know a sprinkler contractor that does that. There are plenty that do, and I guess I'm making a generalization. But at the end of the day, this document tells you that someone did this. Right. All right. So here we go. A little bit of plan. You know, check the plans versus what's being on site. I couldn't tell you exactly what is going on here, but it's exactly what our job is to do. Right here we have our water utility out at the street. Here's our connection to that. This is from Oregon, so they have underground valve pits. I've been in them. I don't like them. But this is Oregon. But everything we do goes back to the plans. You know, that's why plan review becomes so important because again, that becomes your code, your standard on the job site. So let's get out underground and get into inside the building. I think we can agree that this is totally your work, right? So. So what is a rough inspection? A rough inspection is you're basically looking at the piping and materials, you know, that's going to get covered up. Many of our large warehouse buildings, storage warehouse buildings, you know, are going to be all that pipe, all the spacing, the sprinkler, everything is exposed at the final. Except for the office part, but again, whatever's going to be covered, we want to look at before they cover, and these are the points we want to get. So a lot of times we get into this partial system, you know, because there are areas of the building that are exposed. There are some areas of the building that are covered up. For example, the sprinkler system in a hotel, you know, all that gets covered up. All you see at the end, at the final, is a sprinkler, and a lot beneath that ceiling. So it depends on the building, depends on the occupancy. So,
yeah.
Yes, sir.
Are you going to cover obstructions?
Oh, yeah.
In a separate section or a separate part of your presentation? Okay.
Yeah, we'll talk about obstructions and all that jazz. I definitely will now you brought it up. and anything else, now I'll just kind of go through my spiel here, but if there's something like, hey, I really came here to know this, Jeff. Let me know. It's probably in your slide somewhere. I just don't go from slide 1 to slide 402, whatever the number is. Again, eyes on, right? This is what we're looking at in the field. Looking at, you know, one of the things we're looking at is the pipe. When we're looking at the pipe, a couple different things. One is we're comparing what's in the ceiling to what's in the plans. And this is important because the shop drawings in plan review, you compared the shop drawings to the hydraulic calculations, right? You made sure that the diameter of the pipe was the same in both. You made sure the internal diameter was the same in both, the sizes and all that. You made sure that flow from the furthest sprinkler all the way back to the water supply. You did that in plan review. Now it's time to go back. Now it's time to go in the field and verify everything that was told to you before is done. And I can tell you, as an inspector, it's sometimes a night-and-day difference. You go on a job site, what was on the plans is not what's in the ceiling, right? We've gone from steel on the plans to CPVC in the ceiling on the job site. And that's a whole different day, right? That's like, whoa, wait a minute here. You know, we need some new plans and some new calcs, because the type of pipe that's being used is going to change your calcs, right? Steel pipe has a different C factor for friction loss than does CPVC. So again, those big material changes are pretty obvious. What's not obvious often is the size of the pipe. So if we're in this building, we're in this room, when we look up, we want to make sure what was on the plans, 2.5 inch, you know, the plans call for a 2.5 inch or 3 inch cross main and 1.5 inch branch lines. That's what we want to look up and see, right? That's what we want to verify. We also want to verify that not only the type of pipe is the same, but the schedule of the pipe is the same. You know, the calcs could have had, you know, Schedule 10, the Schedule 10 internal pipe diameter that makes the calcs work out really nice. But, you know, maybe they install Schedule 40. Why they would do that, I don't know. It costs more, but those are the things we verify. You know, the type of pipe, not all steel pipe is made the same, right? Not all steel pipe can go into a sprinkler system. So as mechanical inspectors, you see a lot of like systems, right? Victaulic. You know, you do a ton of mechanical processing piping systems with Victaulic. You also see Victaulic on the sprinkler side. So when you're looking at the pipe identification, and you guys can educate me on more of this than I can educate you, but the type of pipe makes a difference. And when we're looking at the pipe, looking at the identification of the pipe is super important, right? We can tell who makes the pipe, we can tell the schedule, we can tell what standard it was made to, right? Not all sprinkler piping has to be listed as fire protection rated or listed for fire protection, right? We can go back in NFPA 13 in Chapter 6 to a table and say, and find to see if ASTM A135 is an acceptable type of pipe, and it is. There's ASTM A135, there's A795, there's B131, all these different ASTM standards for pipe are in the table in Chapter 6. You want to verify that they've met this, right? You've checked it out in the plans, now you're making sure it's put up. Why? Because sprinkler contractors get a deal, right, from somebody all the time. Some salesman or salesperson is going to come in and say, I'll give you a hell of a deal on this pipe for this job, okay? Bay City was close. So up to a few years ago, Michigan had two sprinkler manufacturers, Globe up in Standish and Viking over in Grand Rapids. Now, in the last couple of years, Victaulic out of Pennsylvania bought Globe. So Victaulic now has all Globe's stuff and Globe sprinklers. They're still working out of the old Globe headquarters in Standish a little bit, but for the most part, Globe is gone. And then you know, Viking remains. But as a building official in Bay City years ago, it was very common to get a set of plans in with Tyco sprinklers or Victaulic sprinklers and have the Globe rep come down from Standish and say, hey, I'll give you a hell of a deal on those sprinklers you put it in this building. You know, the DoubleTree where we'll be next week for CLCM, those are all Viking sprinklers until the Globe rep came and say, you know what, I'll give you all the sprinklers in this building. So if you put Globe in, because, you know, again, hometown pride, I guess. So if it's not listed in this table of NFPA 13, then it's got to be specially listed, right? And there are several specially listed fire protection piping systems out there. CPVC is identified as plastic pipe or non-metallic. It's described as a non-metallic pipe in NFPA 13. There's like this many rules, literally, this many rules for CPVC and NFPA 13. The thing with CPVC is go to one of the manufacturers, Lubrizol or Spears, and download their installation guide. And you know, it's like 60, 70 pages long. But it's important to have. It's important to either have on your iPad to do an inspection, or print it out, throw it in your truck, or have by your plan review table, because a lot of the different nuanced installation rules go back to those manufacturer installation rules. So download Spears, download Lubrizol, one or the other or both. The rules are almost exactly the same. Okay. the little plastic pellet they make CPVC out of comes from Spears or Lubrizol, right? Spears or Lubrizol then sells that pellet to Tyco and Viking and whatnot. So you know, get a BlazeMaster product and maybe distributed through, you know, a local supply shop. But for the most part, it's manufactured by two people, Spears and Lubrizol. The other thing that's, so the installation rules for the two different CPVC manufacturers, again, are almost identical. What's not identical, we'll get to talk about, if we don't talk about this in the final inspection, I'm gonna do it now, is the compatibility. So one of the big lifts to you all, inspectors, is the compatibility of materials against CPVC. So this orange CPVC is susceptible to chemicals leaching and degrading, leaching from another product into the CPVC, and there's been failures. So there's a compatibility, both manufacturers have compatibility requirements. So anything that touches CPVC, Romex, paint, latex or oil-based, caulk, fire stopping, insulation, cables, anything that touches CPVC has to be listed as compatible to touch that. All right? So rough inspection, final inspection, anytime you see anything touching CPVC, you gotta get some documentation for that. Both manufacturers have a list on their site of what is approved. So a lot of fire stopping is approved for both, one of the both. And here's the other thing. The compatibility of a product to the CPVC is different from Lubrizol to Spears. So one tube of caulk that's approved for BlazeMaster may not be approved for Spears. This is one of the, probably my biggest concerns in the industry as representing the industry is this, is that contractors buy a lot. You know, they'll buy a pallet of caulk or they'll buy a pallet of fire stopping, and that fire stopping is approved for BlazeMaster, right? And Spears comes along and gives them a hell of a deal on Spears for a project. Well, that pallet of caulking, fire stopping, is not approved for Spears. A different model or a different type is. And contractors miss that. They miss it all the time. So as inspectors, we got to be very aware of anything that touches CPVC. Yeah, you won't find that anywhere in NFPA 13. Well, you'll find the compatibility requirement in NFPA 13, but the websites, the manufacturer's cut sheets have these details. So again, now all our rules land in this book. They land in other places, and we just gotta need to know where to find it. Certainly, so CPVC, talking to plumbing and mechanical officials here in Michigan, I mean, CPVC is orange, or it could be white, right? Or vanilla, or off-white, whatever it is. They make CPVC in both colors, but the only one that's approved for fire sprinklers is the orange. So if you're doing non-metallic pipe, it's gotta be orange. And there's a polybutylene pipe out there that's approved for 13 also. Well, we don't see it in Michigan, we see it out in Colorado a little bit, but it's a very unique product. But the connections are done by heat instead of solvent. But again, you don't see that too often. CPVC, we see a lot. PEX. So PEX piping systems aren't allowed for NFPA 13 or NFPA 13R. The only time you should see PEX connect to a sprinkler system is in a single-family dwelling or a townhouse under NFPA 13D or the residential code P2904. Copper is certainly permitted, certainly allowed. I don't see too much copper. I've seen two copper systems in my life. One was at the building where they took Abraham Lincoln after he was shot across from Ford Theater. That was a copper system, retrofitted. And then the system I put in my house was copper, just because I could go get copper. A lot more easier than I can run out and get CPVC. Some of the other pipes we have out there, galvanized steel, you know, there's black and whatnot, galvanized again. So, well, here's our chemical compatibility slide. So, again, the Lubrizol, whoever makes it has different compatibility requirements. So again, you got all the manufacturer. And watch out that some contractors will have a leftover from one job to the next, right? So you may see Spear CPVC and BlazeMaster CPVC on the same job site, on the same system. And while that can be done, both manufacturers are frowned upon that. The other part is going to be confusing is what's compatible to what. So not all compatible products are applied to both types of CPVC. The other part to watch out for here is this hybrid, right? This hybrid CPVC and steel systems. So when a steel pipe is connected, when there's CPVC on a steel pipe system, the oil used to thread threads on the steel pipe has to be compatible with CPVC. So a lot of your fab shops like Ferguson or Bull Moose or whatnot that are doing some prefab work for sprinkler systems, they all have threaded oil, the threading oil, that's compatible with CPVC. Both of them, right? Just to avoid that. And they can give you a certificate with that pipe shipment that says such. But it's the stuff that you're seeing, you know, the threading on the job site, again, when the two are mixed, everything that touches CPVC, even on the inside, has to be compatible.
Missing the upstart.
Yeah, strike plate.
What am I missing?
Strike plate.
Oh, well, yeah. All right, yeah, good eyes. You guys are making inspections even as I'm talking. Yeah. Missing the strike plate, which, where does that requirement come from? You find that in NFPA 13?
No,
Mechanical code, plumbing code.
Mechanical code and plumbing code. When you finally do get to the 2022 edition of NFPA 13, it's going to be in there too. So.
Does it call for the extended plates?
Yeah, the 2022 edition does call for extended plates.
I think the one we're on right now does have impact protection, but it doesn't specify extended plates. You get to that through the building code, it's a system that carries water, so it's identified as one.
Okay, good to know. Any other comments on this photo?
On the CPVC, didn't I read somewhere it's only for light hazard?
Oh, yeah, good question. CPVC is only approved for lead hazard. It is approved for lead hazard, and but ordinary hazard is limited to 400 square feet. So you could have a motel or a hotel like this, all CPVC. When it gets into the laundry room, which is ordinary hazard, the kitchen, which is ordinary hazard, as long as that's up to 400 square feet, they can use CPVC. Otherwise, they got to switch over to steel for those larger rooms. So you won't see it in any large ordinary hazard room, or you shouldn't. It doesn't prohibit somebody from trying, and nothing extra hazard. So. Anything else on this photo? This is why I like doing these classes, because you guys pick up so many more things.
Where you're stopping on there?
No, but Joe, this is a rough inspection, buddy. But good point, though, Joe. That's why I like having Joe in here, because he just pops things up every once in a while.
And I thought I was wrong there for a bit.
So, no, you're never wrong, Joe. You're just not right sometimes.
Agreed.
All right, so here's another creature that we deal with too. Maybe not so much in Michigan, but it's the energy code. Right, so the energy code is going to require that this be caulked. That the connection from the vertical wall to the
Building code required.
building code requirement. Yes, yes, sir.
question back to the 400 square foot. Is that per room or is that per system, per riser?
Per room. So if the room is greater than 400 square feet, then you have to bump up to a steel. But you can have multiple. It's not accumulative, right? You can't have. The code is, the standard isn't saying, well, you have 100 over there, you have 400 over here, 600. You know, it's not accumulative. So it can be. You can have up to 400 square feet in each room.
So as long as you keep your rooms less than 20 square foot, you never have to go over to.
Right. And that's where it makes convenient for like some of these hotels, like a 13-hour system. Right, where the laundry room is real small, the kitchen, if they have one, is real small. So that's what the accommodation is actually for. So they can run CPVC from beginning to end.
So with that system, to the kitchen, say the kitchen is 600 square feet. So that has to be steel in that room, and you can exit and convert over to CPVC or not?
Okay, you found a little gray area, which I was hoping you'd find. The gray area is this, right? So if the CPVC, you bring up a good point. The CPVC, if it's in a concealed combustible space, what's that concealed combustible space? Light hazard, right? Even though it's above an ordinary hazard room, it's that concealed combustible space is light hazard. So the debate in the industry is this: well, the piping is in a light hazard, so does the square footage of that really matter? The square footage of that room really matter? And coming from the manufacturers who tested this, the answer is yes. Even though the piping is in a light hazard and the sprinkler itself drops in the ordinary hazard room, they tested it and they listed it to that such. So it's for it's the square footage is what the CPVC is protecting, that room, the spaces that's being protected.
So within that space, you would use steel, outside of it, you.
Yeah, you use steel. So if you have a 600 square foot kitchen in a hotel, above that kitchen, it's technically supposed to be steel or some other piping that's approved for light ordinary hazard steel. Again, I don't necessarily agree with that. Multiple things I don't agree with my own industry on. That's one of them, because we say in NFPA 13 that concealed space is light hazard. That's where the piping is at. The piping doesn't know where it's going, right? It just knows it's in a light hazard space. And it's being protected by some sealing material, gypsum, wood, whatever. Yes, sir?
We have a bed and breakfast, and it's also doing light restaurant stuff.
Okay.
And they ran a lot of CPVC, but up in the attic area, they ran steel because they felt more comfortable with steel up there because it's not real accessible.
Okay.
I even took pictures. You can
Oh, wow.
barely get up in there.
Yeah. Show and tell. Live. Oh, very cool.
I mean, you got a head there. They're going to spray all the ceilings to keep it freezing.
Oh, yeah. There you go.
Yep.
So the dry system's in the attic, and so yeah, you see a pipe in the dry system. All right. Back to the energy code, which somebody said, oh, that's the building code, that's not ours. Well, know that you may see caulk right there, because the energy code says from that air barrier, the energy code says this, right? That exterior wall and that top floor ceiling is called the space between the conditioned and the non-conditioned space. That's called the air barrier, right? Anytime you penetrate the air barrier, it's got to be sealed. So in this case, this is one of the methods to seal that, just to caulk that. But again, we got to look at the compatibility of that caulk and seal. You doing much energy code work here in Michigan? A little bit, yeah.
I got a question.
Sure.
Back there. You got the plastic pipe going up, is that on the outside wall?
Well, yeah. Certainly looks like it's an outside wall.
Now, would the system be considered a wet system or a dry system?
Be a wet system.
Okay.
Yeah.
I'm just throwing it out.
Yeah. It's still considered a wet system. It's in that space, right? And NFPA 13 tells us that this got to be at least conditioned to a 40 degrees or more. That's the threshold from a dry system or antifreeze system to a wet system. So if we can prove or show that that's 40 degrees or better, we're in good shape. Yes, sir.
So if that's an exterior wall, then good possibility that could be spray foam. So that spray foam would have to be compatible with that.
You got it. You're picking up all the little pieces, right? So if it's on an exterior wall and it's insulated, with spray foam, spray foam's got to be rated, or it's got to be compatible to that CPVC. The wet cellulose has to be compatible to to the CPVC. The blue G material, you name it. Even fiberglass bad insulation has to be compatible. Most of them are. I'd say fiberglass is probably the most compatible across all of them. But spray foam, yeah. What's the spray foam? Spray foam we buy at Home Depot, right? The Great Stuff, right? Great Stuff. So if you look at the Great Stuff can, look for a symbol. It's called FBC. Letter F, letter B, letter C, FBC. that FBC symbol or logo or branding is the compatibility for BlazeMaster. So if you go on BlazeMaster's website, look for the CPVC compatibility, that's going to be under their FBC program, and that'll be listed. But any product that has that compatibility is supposed to have that brand on it, just so it's identifiable. All right, solvent cement. This is always a good one because a couple things, right? So CPVC, have you guys had a CPVC class here from IAM? Like just have a manufacturer come in and do an hour?
Not yet.
Not yet? That's a really good one. Because they have approved 1 hour, 2 hour. They'll come in, give you the cutters, glue, and all that stuff. You can sniff glue for an hour or two. It's a good time, right? And then you get a certificate. It's better than this class. I mean, I don't give you anything, any stimulant at all, except for me. Yeah, I give you a good nap, yep. The other part is cure time, which is a big deal for Michigan. You know, when it's freezing out, the cure time is dependent on the temperature it's exposed to. So, can I glue this when it's below freezing? Yes, I can. It just has to be cured for about 24 hours before I apply pressure to it.
What's the coldest the glue can get?
Say again?
What's the coldest the glue can get?
I'm not sure. I don't know if it's set on freezing, 32 degrees or more, but
40.
Is it 40 for the glue? For the solvent?
On the can.
It says, okay, 40 degrees. Didn't know that. That's why I come here, I learn from you. So when you're on the job site, or when you're driving by job sites, here's another just, observance as you're going through your community. CPVC should not be left out into the sun. So unless it's wrapped as you see there. So this can sit out there during the summertime, that's okay, but when it's unwrapped and exposed, it can be out in the sun for, I'm gonna tell you about 30 days before there's a concern. Manufacturer might tell you something different, but if you're driving by a job site today in May, and you go back there in August or something, and that same pile of pipe there is exposed, we probably need a letter from the manufacturer to say, yeah, it's okay. Chances are they're not gonna write it, right? So CPVC does degrade in sunlight. So the way it's set up here is fine. These are protective wraps, that's okay. Just like any other pile of pipe you find in the boneyard or any job site, right? Sprinkler piping, even the steel pipe. Steel pipe certainly can sit out in the sun for a long time, but the way it's handled out there, was it dumped into the mud puddle? Is there mud inside? Is there dirt, rocks, whatever inside there? So anytime they handle that pipe on the job site is again a concern for ours. In a good fitter, right? There's many good fitters. A good fitter is going to lift that pipe up and let all the stuff roll out, look through it, make sure it's clear before they install it. But they don't do that all the time. But now leaving steel pipe out in the boneyard, it may grow legs. Copper used to grow legs, before, but now steel pipe, especially contractors are waiting 8, 12, 15, 18 weeks for a delivery, or more for steel pipe. Now steel pipe on somebody else's job site looks pretty inviting sometimes. All right. The routing of the piping, again, another important part from plans to visual inspection, is that the pipe follows the same, it's in the same cavities, right? It's the same size pipe, it's installed in the same spot. If you go on a job site and your cross main, it used to be in the center of your building with the tree system, is now on the outside and it's looped, right? That should tell you something. That tells you that something occurred between plan review and installation. Maybe a water problem. So the cheapest, easiest install is a tree system, right? So from 1896 to 1994, I can install a pipe schedule system for any building, right? So a pipe schedule system is you start with 20 psi as a static pressure out in the street, and then you apply sprinklers to the diameter of pipe. And a 2-inch piece of pipe could have 8 sprinklers, an 1.5-inch piece of pipe could have 6 sprinklers, and on and on. For 100 years, that's how we designed sprinkler systems until we got into hydraulically calculated systems in the early 70s. and that finally became mandated in 1994. So when I say in the last 50 years we have a lot of advancements, we've had a lot of advancements in the last 30 years. Hydraulic decoupled systems are one of them. So you got on a job site, the tree system was the cheapest and easiest to install. You know, it's the easiest to design. So when you go out there and now your cross mains are on the outside wall, you know, now it's a hydraulic decoupled system. Gridded systems and loop systems have to be hydraulic decoupled. And every system has to be hydraulic decoupled now. I can use pipe schedule systems today for additions to existing systems or small systems under 5,000 square feet. So again, you're looking at your plans, looking at your job site, you make sure that all the piping is in exactly, you know, I don't want to say exactly, but in the spot that is intended to be. You're looking at pipe sizes again and all that. All right. You are looking for these minor modifications. You are looking for trap sections. All sprinkler systems are supposed to drain, all systems are intended to drain back to the riser, right? The riser has what's called a main drain. But not all systems do drain back to the riser, right? Because of trap systems or you move pipe, beams get in the way. So all those trapped areas need a drain.
Yeah.
And we need to be able to drain those systems. Then the last bullet point, we'll talk about drains here in a minute more, but the last point there is minor modifications. What's a minor modification? I guess that's totally subjective. You know, a moving of a hanger, I guess, is minor. But I guess you all have to make that judgment. What's minor? What's going to trigger a new set of plans or a new plan review? You know, minor modification is not submitted it in CPVC and now it's steel or vice versa. That's not minor. That changes a lot of hydraulic calculations. Sometimes I used the example earlier of swapping out sprinklers, right? Dyco, Victaulic, Viking, whatever you plan to review. When it was installed, you have to know what those are. Sometimes it is a big deal, sometimes it's not. Same K factor, same characteristic, same flow characteristic, you're in good shape. But again, it kind of goes back to your judgment. You'll have sprinkler contractors, and you all know them, and other contractors who, you know, try to get the best deal and swap things out all the time. There are contractors out there that you know you have to take a closer eye to than others, right? That's just a fact of life. But how you want to manage that internally, that's kind of up to you. All right. Well, here's a good example, right? Here's our plan on the left, and here's our install on the right. So we have 2 branch lines going through there. There are a lot of things we can pick off this, right? The branch line is perpendicular to the structural members on the plans. We look at on the project, we certainly have that. We have the sprinklers in the center of these wood floor trusses or roof trusses, yep, and we have that there, right? So there's a lot here. These are the branch lines are, I think they're 1.5 inches. If I can see that right at my angle, and we want to verify this is 1.5 inches through here. Right? The spacing, you can see the sprinkler spacing there between each sprinkler of 8 feet. Again, we want to verify it because this is going to get a lid on it, right? This is going to get a ceiling attached to the other side or a drop ceiling attached to the other side. You're not going to see this again. So part of your rough inspection is to verify that so you can check it off and they can install a ceiling on it. All right, what else? You guys see anything else in here I need to know?
I don't see any drops in there. The ceilings are dragging.
Yeah, good point. He says, I don't see any drops in there. You're right, there are no drops. So I made the giant assumption that there's going to be ceiling drops in here. Well, I really can't tell if there's a sprinkler there or not.
Spring up on those.
Yep, these are sprigs. Again, the green lettering at the top says it all. Check the plans. All right. What else we have here? Drains, auxiliary drains. So anytime we don't drain back to the riser, we have to put in what's called auxiliary drain. So wet systems have their own drain requirements, right? Up over 50 gallons, it has to be piped to an accessible location with 1-inch pipe. And how do you know what size of, how many gallons, what the volume is? How do you know that? Yeah, look at the prints, look at the plans. And if you really want to know, there's a diagram, there's a table back in NFPA 13 of the annex of chapter 6 that tells you how much volume a 1 foot piece of pipe has based on diameter. So, you know, if you knew that there was, you know, 25 feet of 1.5-inch pipe in this drop or in this auxiliary drain, you would know very quickly, if you did the formula, did the calculation, right, how many gallons it is. And again, that's your inspector tool to verify, to enforce. But the information comes from the designer, from the contractor, right? Oh, it's 49 gallons, Jeff. Okay, you want to verify that, right? Because it's a tipping point of, you know, it's like the sprinkler threshold at 11,999 square feet, right? I'm going to check the area of that building real close, because at 12,000, we're going to trigger sprinklers for some occupancies. So the volume can be done in the field. You can almost do it in your head. I can't, I'm not that smart, but it is possible. So NFPA 13 gives you these 3 categories. 50 gallons, 1 inch. It's got to be 1 inch pipe, 1 inch valve, pipe to an accessible location, right? So it's got to go to a place that can accept that type of water. A drain, a floor drain, to the outside, etc. Floor drain's got to be sized to handle that load. So 5 to 50 gallons, we can do a 3/4 inch valve, and we can cap or plug it, and then less than 5 gallons, which is a real small, real short run of pipe, we can actually just take care of that with the sprinkler, right? 1/2 inch cap or plug, remove the pendant sprinkler, or attach a flexible coupling to it, and detach the coupling to drain the water. All systems need to be drained. All portions of the system need to be drained. So any trap system needs to have that drain. And at the final, note this on your plans, right? Or note this on your inspection log, your inspection sheet. So you come back at the final and find that, oh, there's a drain right here at the rough. There's got to be a sign. We'll talk about signs here in a little bit. There's got to be a sign, right? Love them, right? Sprinkler drain, right? So note where they're at so you come back and get them later. Dry systems certainly get some more drains. Again, when the pipe changes direction, we're not drained back to the main drain. Dry systems have drains. But the dry system's doing a couple different things, right? The dry system is trying to keep the pipe from getting what? Wet, right, from the inside, because they're in the freezing areas. They're in the attic, they're in the porte-cochere, they're in the area that freezes. So dry pipe system drainage is set up a little bit different. They're set up in this fashion with the 2 1-inch valves, the 2 foot of 2-inch pipe in between, to allow the system to drain the condensate or even the water that's left in there. It fills this small piece of pipe up here. We're to close that upper ball valve, open the lower ball valve, drain the water out. And what we're doing by this process is we're not dropping the air pressure to the point where we release the water into the system. That's the point of this, right? Because back in the dry pipe valve, we're holding back our water pressure with air pressure. And the dry pipe valve does that. When we lose air pressure, that's when that valve opens and fills the system full of water. Now, when we're doing this condensate drain or doing the ITM on this, we don't want to do that. Yes, sir.
Who's allowed to do that?
What's that?
Who's allowed to drain that pipe? Any mechanic or handyman, anybody?
Oh, good question. Who's allowed to drain that? So it kind of gets back into our NFPA 25 discussion, right? Who does maintenance on a sprinkler system? Who's allowed to do maintenance on a sprinkler system in Michigan? And that's probably a little bit of a gray area too, isn't it, right? Yeah. Because NFPA 25, which is the standard, says any qualified person can perform this work, right? And qualified is the word that we probably spend hours on every cycle. Who's qualified, right? Because the Sprinkler Fitters Union has an influence in there saying, we know who's qualified. Our sprinkler fitters are qualified, who's gone through an approved apprentice program. The non-union side comes along and says, well, we have an apprentice program too. So who's qualified? The HJs, the code officials say, okay, who is qualified? Is that a mechanical contractor? It's kind of up to you. And NFPA 25 leaves that up to the code official to determine who's qualified. So, but there are areas. So if you have a large plant, a large facility that has a facilities manager, they can be qualified to do 25. Some of them, right? Can they read a gauge? Can they do the weekly walkthrough and make sure the gauges are at the right pressure? Yeah. Can they do the weekly walkthrough to make sure the sprinklers are not painted or not obstructed or whatnot? Yeah, they can do that. There are certain things they're qualified to do. The maintenance on the system, you know, the test, so it's inspection, testing, and maintenance. You see it as abbreviated ITM. So inspections, eyes on, most people can do that. Not you know, most qualified people can do that, right? I can walk through and read a gauge. I can walk through and I can see things as long as I know what I'm looking at. Again, you have to be qualified. Inspecting, testing. There's a little bit of a gray area there because there's some things I can do. Can I turn a valve to read a gauge? Yes, I can. Do I have to be qualified to do that? The standard says, yeah, I do. Do I have to be a mechanical contractor to do that? No, I don't want to answer that question here. But maintenance, definitely. So to take a sprinkler out, put a sprinkler in, to change this valve out, to put a new valve in, etc. That's maintenance, right? When I have to test something and it fails or it needs work, that's a mechanical contractor all day, every day. Who can drain this system to get the condensate out? I think the facilities manager can do that as long as we've said he's qualified.
You just said that you can change out a sprinkler head?
Sprinkler contractor, yeah.
Okay, sprinkler contractor, but not a maintenance head.
Right. Do maintenance people switch out sprinklers? Yeah, they do, right?
But there's different types of heads.
Right.
That they have to know.
There are. We'll look at the cabinet here in a minute. And, you know, 13 tells us how many sprinklers we're supposed to have. And, you know, when we swap out sprinklers, we gotta know which one to swap it out with, the right one. Usually that goes back to the sprinkler contractor. He or she knows what the right head is. Or the right sprinkler, right? Pitch. So dry systems do have dry systems, pre-action systems, all have a pitch, right? So all that water goes back to the riser, out the riser. So wet site, you know, every system is supposed to go back to the riser and drain. On wet systems though, the branch lines, the cross mains, and whatnot can be dead level. But on dry systems and pre-action systems, there's got to be a little bit of a pitch to it to get that water to drain back. And we're looking for that in the dry system during the rough inspection. Especially in that one photo where we saw that concealed combustible space above, we can see from the floor, we can see it piping is pitched from one end to the next. We don't have to put a level on it, we don't have to measure it, we can visually see that it's pitched. Right? We can see the hanger length, the hanger lengths are different, the distance to truss webs and whatnot, other structural members are different, and we can visually see if that's draining. Do we have to verify it's half inch or quarter inch per 10 foot? We can. The standard says that. I think we can see what that looks like. Okay. And I've run across this in a couple of different inspections where the dry system was dead flat in an attic. Dead flat. And I found it at a rough inspection, I found it at a final inspection, dead flat. And that's an issue, right? The standard says it's got to be pitched, so you're looking for that. What do we have here? Sprinkler drops. Okay, well, good deal. So some of this has to do with seismic zones, right? When we're in a seismic zone, the way that drops, we can't be any closer to 3 inches to a structural member, so as that drop moves, it can't contact anything durable or hard like a structural member. So not too much of a concern here in Michigan. Where we run into drops is the flexible hose. So many manufacturers of flexible hose today, most of the flexible sprinkler hose out there is the braided steel, right? The braided line. So back to your plan review, you know, did they submit drops? Did they submit flexible drops? At the plan review, if they did, they would have hydraulically, you know, calculated them in. They would have accounted for the friction loss for those flexible hose. What if they didn't? You're at the rough inspection, or heck, you're even at the final inspection, and you see flexible hose where in the past, in the plans, they put hard drops in. Is there a difference there? Is there any cause of concern there? Yeah, I think there is a cause, because that 6-inch flexible hose, right? I don't know if that's 6 foot or not, but let's say it's 6 foot. That 6 foot of flexible hose is equivalent to 36 feet of 1-inch pipe. So there's a 1:6 ratio for friction loss between steel pipe and flexible hose. So if you got a ton of flexible hose in the project that wasn't accounted for, probably need to go back and say, hey, we need the calcs change for this. The other part where you're gonna see this a lot is an existing building. You know, an old building that was built, pipe schedule system, and it changes use, and they put in a bunch of flexible drops because they dropped the ceiling and whatnot. So that existing building, that existing system has now added flexible drops on, super convenient to the owner, super convenient to the contractor, changes the calcs, okay? Changes the calcs. So you might want to get a set of calcs for that too. Okay. Every contractor, you tell that in Michigan, I went to a class, Jeff Hugo said I had to get calcs. And I said, damn it, not him. It's true. I mean, we put systems in so they work, right? And this is what verifies. This is what gives us the warm fuzzy that, yeah, the system's going to work. When we have calcs that prove as such. So there are specific listing rules for every flexible hose, whether it's coming from FlexHead, whether it's coming from Italic or whomever, right? There are special installation rules, and every one of them is a little bit different. So make sure you matched, cut sheets of what's being installed. And again, it's another spot where your contractor's gonna get a hell of a deal from somebody just before it goes in. So another spot to point out. The bends are important. So in this braided line, again, it's flexible, we can bend. There's a maximum number of bends for the braided lines. The corrugated lines are more. So when this first came out in the industry, and I think they still have them now, they have the corrugated lines, which you guys see as gas lines all the time, right? There is a number of bends and the diameter of those bends are really important. So they can't, it goes back to the cut sheet and tell you how many bends they can have.
They actually got a tool now
They do have a tool.
for checking the beds, so you guys know that they're all right. It's pretty cool.
And the tool is usually like a handout at a show like this, where a vendor has it.
Yeah.
Yeah.
Did you bring them?
I did not, no. We'll have to invite that vendor next year.
DRS.
Let's invite the CPBC folks, you can do that, and go through that, and go through that program. So. But, I mean, the other rabbit hole I can dig into here is, with one manufacturer left in Michigan, it's Viking in Grand Rapids. They just built a brand new facility in Caledonia, just south of Grand Rapids. Has anyone been there, the new facility? You? So they do run an AHJ program. They'll run contractors through there all the time. But they have a state-of-the-art facility, and they have a whole day program, right? They have a valve lab. Every one of their valves, multiple valves. So you can go in there and take valves apart, turn systems on, turn systems off. They have a spray lab, which is really cool, that flows sprinklers. Every one of their sprinklers. So you can go to the flow lab and through an iPad, through an app, you can turn on the ESFR sprinkler and watch it flow. You can turn on extended cover sidewall sprinkler over there. You can watch that flow. And it's just interesting to see the flow patterns. And Viking, the manufacturer, they're putting in some obstructions in there now. Like they'll bring a ductwork in there, put a piece of ductwork in there, and you can see how the flow is changed. And again, free to every AHJ in this room, every code official. If that's something you want help setting up, you want to do a day run through of that, let me know. I can certainly facilitate that. They have a fire pump room. We can go in there and play with the fire pump. They have a fire alarm room for pre-action systems and deluge systems. We can play fire alarms and fire alarm panels. And they have a room of VR. They have a visual, the VR goggles, and a room of that. So a dozen people can be on VR goggles, going into a system, turning the system on, turning it off, adding foam to it, whatever, you name it. So very, very, very nice. Very nice facility, and I encourage everyone to get to. All right, what do we have here? Flexible hose. What do we have? Okay, not too much there. Oh, in this case, I guess we have a couple things. So here, they're zip tying the flexible hose to the branch line because it becomes a drop afterwards. It's going to drop into the ceiling. You notice on there a couple things. The zip tie, that's supposed to be down, cut loose when you do the final. And the plastic cap and strap is still on this sprinkler as it's being installed. That plastic cap or strap is there to protect the sprinkler. So in the 70s, we did a study and said, okay, 1 in 16 million sprinklers have a malfunction, right? We've all heard of sprinklers malfunctioning just magically in a building. No one knows why the sprinkler just activated, right? It wasn't a fire, it wasn't a broom, it wasn't anybody. So years ago we did a study. They're defective to 1 to 16 million. Since then, we've added these caps, these orange caps and straps on. Again, one of those things, one of the easy lifts here, just make sure they're all off. When they, final inspection's done, make sure they're all gone. Sprinklers don't work really well with the cap and strap left on. So here, here we are, and again, another concealed space with just some bullet points of what to look for, right? Upright sprinklers, we know we're going to conceal. We want to make sure we check those out. If there's drops or outlets or drops, we want to make sure they're in the right spot. What else? Oh, deflector distance. I think I have a couple slides on deflector distance. We'll get to that. So here's deflector distance. I guess here's our slide. So for a smooth flat ceiling, so NFPA 13 differentiates their ceiling configurations in 2 different categories, right? They call them unobstructed ceilings and obstructed ceilings. Not to be confused with obstructions, but unobstructed versus obstructed ceilings is how heat and water flow across the ceiling. It's more or less how heat flows across the ceiling. So in this case, in this room, we have an unobstructed ceiling, which is a smooth flat ceiling. With that, my sprinkler spacing down, my deflector spacing down from that ceiling material can be anywhere from 1 inch down to 12 inches for its upright sprinkler. So basically any open structural member, like a bar joist or floor truss, is also considered as an unobstructed ceiling. We get into obstructed ceilings when we have beams and girders and whatnot in the way, and those beams and girders are spaced less than 7.5 feet. So this is definitely a field inspection thing to check, is to measure or at least verify that that deflector distance is accurate. So is this within the 1 to 12 inches? Yeah, it's fine. Some people ask why the 1 inch? Well, the 1 inch is there, the deflectors, and this is measured from the ceiling to the deflector. The deflector, the measurement goes to the deflector, but that 1 inch is there so we can remove that sprinkler someday, right? So we need that 1 inch space in there to get the sprinkler off. So, so if this is unobstructed construction, obviously it's the same project because it has the same ceiling material. But here now we can see we're at about 14 and 15 inches down. That's too low for unobstructed construction for that smooth flat ceiling, right? So as heat flows across that ceiling, especially in a room like this, we're going to have uniform heat distribution across this entire room, but it's going to take a long time for that sprinkler, for that heat to bank down and get to a sprinkler such as 14 to 15 inches down. So again, 1 to 12 inches down for these smooth flat ceilings. All right, so we have some these wood floor or wood roof trusses. They have the metal. My clicker's not working here anymore. These metal bar joists. So because these structural members are open, they're considered a smooth. They're treated just like a smooth flat ceiling, right? So within those bays, within these joist spaces, we want to make sure we meet that 1 to 12 inches. Here our plan says something similar, and we're trying to see if we can comply with that, and at this point we do. Okay? In this case, I'm not quite sure what my instructional designer here was trying to point out, but I suspect they looked at the plans and they see the deflector on these sprinklers to the bottom of that top cord. And in this case, we're above the bottom of the top cord. I don't know exactly what they're looking for, but this is too close. This is not what they intended. Why? Because the gentleman over here asked about obstructions. With this is certainly probably meets that 1 to 12 inches, but now the sprinkler is so high that this top cord is going to obstruct the spray. And we'll talk about obstructions and beam rules and 3 times rule and all that here in a minute.
Let me ask you, Jeff.
Sure.
I did an inspection on one of these storage places self-storage. They changed the plans and they went to insulation above the sprinkler heads. But they didn't pass insulation in a way that it wouldn't lose.
Oh, yeah.
So, I mean, it's been an ongoing thing, you know, the sprinkler contractor says, I put it in according to NFPA, but whoever drew up the plans for the insulation didn't do the proper job of securing the property. So, like you say, it's been an ongoing deal. I guess at some point in time it'll be approved, even though they repassed it, but it'll have to probably be inspected on a regular basis just to make sure that insulation is approved.
Yeah, that's a real concern, insulation drooping, even to the point where NFPA 13 in Chapter 8 addresses how much does that insulation droop. So the bottom of the insulation becomes the ceiling that the deflector is measured to, right? So if it's drooping too much, you can certainly come in contact, which is a problem.
Yeah, you got that 1 inch, and it could be less than 1 inch.
Right. NFPA 13 also in Chapter 8 has some figures where it gets into normal insulation, and then it gets into droopy insulation, and where to measure when it's overly droopy. So it actually, when it droops down so far, this is so bizarre to even bring this up, but when it droops too much, you measure to the midpoint of that droop, not the low point of the droop. And it's again, it's in there if you need it. It's in Chapter 8 if you need it, but it's kind of hard to explain. But insulation drooping is an issue, an ongoing issue, right? And the day you inspect it for final or off, it could be different than the day that you go look at it again. Yeah. And no one noticed this, but I'll point it out. This ceiling. This is not a hard ceiling. This is a fabric ceiling, right? There's fabric stapled to the bottom of those joists. So does that become a ceiling? Yeah, it does. So for sprinkler spacing, for sprinkler activation time, that material, even though it's a fabric, is a ceiling to that sprinkler distance and whatnot. So it often also becomes a solution to when sprinklers are spaced differently. So if we talk about concrete tees, or if we have a sprinkler line that's too far down, to put a drop ceiling within that joist space, just to make it comply with the sprinkler spacing, deflector down from the ceiling rules, is permissible. Yes, sir.
Where do you find, in what code, what that ceiling has to be because of drip? Some materials will, drip on firemen.
Yep.
Some insulations when it gets hot and stuff. Where do you find that?
Interior finish requirements of the building code.
Building code.
Okay.
Yeah. So with Chapter 14, the building code.
So we just let the building inspector take care of that?
Yeah, apparently.
Okay.
They're putting it on us. Yes, sir.
So is there concern if that fabric is not secured properly, if that gets wet and falls down on the sprinklers, where would we?
Sprinkler, remember, sprinklers, small fires, sprinklers activate, it should never get to that point. Sprinklers are below that fabric, so one of the concerns is, think a little deeper on this. What if I have a cloud ceiling and I put that fabric below the sprinkler or above the sprinkler, right? Fabrics do affect sprinkler patterns, but in this case, we're in decent shape. And the type of fabric, right? So our cottons, our canvases are okay, but our polys, our spandex material and all that, those can fall and shrink upon a sprinkler flow and become an obstruction. So we're concerned with that. Are there any hard, fast rules on that? No, not really. But it goes back to interior finish, Chapter 14 of the building code. Give it to the building inspector, I guess, I hear, so. And it changes too, right? It changes whether it's a sprinkler building or not. So I can get a reduction in my flammability requirements in Chapter 14 if I'm in a fully sprinkled building or not. So for the building inspector's room, that's what we look for, right? We look to see what the classification of that interior finish is, whether it's fully sprinkled or not. That's one of the 125 plus trade-offs for a fully sprinkled building. Okay, we looked at this guy already. Oh, here we go. Here's another uh-oh. The 3 times, so is this sprinkler obstructed by this vertical column? And it depends, right? The answer to every fire protection question is it depends. So one of the obstruction rules we find in NFPA 13 is called the 3 times rule. So for standard spray upright pendant sprinklers, this is in section 865213, 8.6.5.2.1.3. That's the 3 times rule. And what we're trying to do here with the 3 times rule is get this sprinkler 3 times the amount of the biggest diameter, biggest side of that sprinkler away. So if this column is 8 inches, then 3 times 8 is 24 inches. That sprinkler will be 24 inches away. If that column was 6 inches, right, 3 times 6, 18 inches. So imagine, but there's a default, right? There's a maximum distance. That maximum distance is 24 inches. So even if that column was one of these columns, like behind some of you or in front of some of you, which is probably what, maybe 16 inches wide or so, I think that column is. 3 times 16 is 48 inches. The standard's going to say all you got to go is 24 inches, right? You don't have to go to 48 inches. You have to be 24 inches. So, and it doesn't require another sprinkler on the opposite side of it, if you can meet that. Now, if you can't meet that, let's say you can't move that sprinkler. What's the solution to every obstruction rule?
Cap it off.
What, cap it off?
Yeah.
Okay, Joe says cap it off. What's the other rule?
Add a sprinkler on the other side.
Add a sprinkler to the other side, yep. So you cannot meet the obstruction rules and add a sprinkler to the other side of the obstruction, you're in good shape, right? And the standard says that's fine. Sprinkler contractor may say that's fine, maybe not. Depends on when you say it, right?
What's it do to the flow rate?
What's it do to the flow rate? So good question. So hydraulically, when we're looking at our hydraulic calcs, when we're looking at all the sprinklers in that most remote design area, NFPA 13 says we only count the sprinklers that are flowing in that space. All the obstruction rules all the obstructed sprinklers in that design area don't have to be calculated. So if I added another sprinkler on the other side of this, I don't have to recalculate that because I've already calculated the one sprinkler flowing. Because we're only counting on one sprinkler to flow, right? Whether it's this sprinkler or the sprinkler on the opposite side, we're only saying one's going to flow. And we're accounting for that flowing sprinkler. So no obstruction sprinklers need to be added to the calculations. That's a good thing. Oh, what else are we looking at? Oh, dry sprinklers. So there's many different special application sprinklers in NFPA 13. Dry sprinklers are one of them, attic sprinklers are another, concealed space sprinklers, window sprinklers, institutional sprinklers. Those are all special application sprinklers. They all have their special rules. A lot of times those special rules are in the cut sheet themselves. So a lot of times that's why we have the cut sheets and go back to the rules. So codes, the building code, the mechanical code trumps the standard, right? This is the standard, not a code. Manufacturing installation rules trump the standard too. In order to get listed as a product listed, the manufacturer may have to do more things than what the listing requires. So those more things are added to that product approval or to that listing to the manufacturer's cut sheet. That's why having that package is so important. So you can see what it says for special sprinklers. Now for dry sprinklers, they were manufactured by manufactured anomaly for many years, but starting in the 2013 edition, the edition you all are under, this table is now in Chapter 8. And this table, which is probably kind of hard to read, hell, it's hard to read when I'm standing in front of it. I can't imagine what it looks like from back there. It looks like a red blob, doesn't it? This table's in Chapter 8, and all this table is trying to do is determine that barrel length. So this is a dry barrel sprinkler. Dry barrel sprinklers are connected to wet pipe systems for these very spot or unique applications. We see them a lot for that sidewall sprinkler that goes out and protects the balcony. Okay, we see a lot of dry barrel applications protecting balconies in this fashion. And that's exactly what this picture shows.
Question.
Yes, sir.
Balconies without a roof, do they need a sprinkler?
No. So a good question, probably a big old grenade in this room, right? Do balconies, so the building code says we have to put sprinklers on all balconies, all type 5 balconies, protected by NFPA 13R. right? And that's where you're going, right?
Yep.
So the facts, so the wording is to say when there's a roof or a balcony above. So when that got put into the 2012 edition, the intent there was a full roof, a full balcony above. So if I have, you know, I'm on the ground floor, above me is the second floor, so on that ground floor I have a balcony right above my balcony or my ground floor patio, so sprinklers gotta be there. But what if I get on a third floor and above, or on fourth floor and above me, I just have this short overhang? Is a sprinkler required there? The answer is no.
If it's less than 48, no.
So I got a 48 number, and that's coming out of the 2022 edition. So the 2022 edition of 13 finally clarified that, and in 13R say it's got to be 48 inches. And the reason for that number is when that balcony requirement got into the IBC back in the 2006 edition, it was tested with a full balcony or a full roof above.
When you have a fire marshal that says, I want it, what do you do then?
That's, you can call Jeff and say, hey, Jeff told me this, and this is the background. I can tell you the background. Fire marshal, I guess. Fire marshal, we just said, fire marshal has no authority in 407. You're the HJ, you make the decision.
I did.
Thank you for laughing.
Where do you find
And I gave him the vote.
Where do I find what, Victoria?
I want to.
Hey, I got a question on that.
Yes, sir.
Okay, it sounds like, okay, you don't have a roof over a balcony, you don't need it. But boy, oh boy, you sure see a lot of barbecues on those balconies.
You sure do. And so the comment here is, man, you sure see a lot of barbecue grills on these balconies. In the fire, so in Michigan, you can adopt a fire code locally, as long as it's not more restrictive than the state building code. The fire code, chapter 311, there's an exception here that says you can put fuel fired appliances on the balcony as long as they're fully sprinkled. The building and the balcony is fully sprinkled. So that's one of these trade-offs in the fire code. And that's why you see a lot of these property managers building. So the difference here, so your question, the issue you brought up is, I thought you were going down this road is, I have two identical buildings. One's 4 stories, one's 5 stories. The one on the left is 4 stories, was protected by NFPA 13R. The one on the right is 5 stories, protected by NFPA 13. The one on the left has sprinklers on the balcony, the one on the right does not. And you're like, okay, and I get this all the time. You know, I had a Indiana fire marshal call me a few weeks ago. I'm standing on the street, Jeff, I see sidewall sprinklers on this one, I don't see on this one. Why? I said, well, because NFPA 13 does not require balcony sprinklers. It's only a requirement coming out of the building code and now NFPA 13R. The solution to all that is in the 2022 edition, everything gets balcony sprinklers, right? Or sprinklers on the balcony. So I went down the rabbit hole. I don't know if I'm on the same point or not.
Is that only if it's the balcony is made of combustible material?
Yes.
Because we do see once in a while they'll do it and it'll all be non-combustible material.
Right. So
You're not required.
in NFPA 13, if it's over 4 foot and it's combustible, it requires a sprinkler, right? If it's over 4 foot and non-combustible, it's not required. In NFPA 13R, it doesn't matter. It requires a balcony sprinkler. Well, NFPA 13R talks about, well, NFPA 13R says type 5, which I've never seen an NFPA 13R system in a building that wasn't type 5. And if you have, good for you, I just don't see them.
So then,
Sure.
if the code hasn't adopted 2022, you really can't enforce it.
You cannot force it, but it really becomes good guidance on where the industry is going, right? Yeah. Especially in that discussion of, I have a 24-inch overhang on the roof above the balcony on the 4th floor. What do I do? And I know plenty of fire marshals that said, I want it, I don't care. Like, okay, well, that's between you and the contractor and the owner. There's stuff in the code to support that it's not required here.
Can they spray that balcony wood with the product?
Oh, man. You guys hitting all soft spots on me today. Okay, good, yep. Good example. There's a product out there, it's an intumescent paint that makes the claim that you can spray this on your wood and you don't put sprinklers in your concealed combustible space, okay? The answer to that is no, it's mystery, right? It doesn't apply.
There's a difference between fire retardant and non-combustible.
Totally.
Talking about a combustible versus non-combustible, just put a fire retardant coating on it, doesn't make it non-combustible.
Amen. Yep. I can't spray anything on a wood product to get me out of sprinklers. That's like the base rule, right? There's a few claims out there. Can I use fire retardant treated wood to get out of sprinklers? Yes, I can. There's some very specific exceptions in Chapter 8, 815.1.15, I believe it is, that says any combustible concealed space made entirely out of fire retardant treated wood is exempt from sprinklers. But the but here is that the fire retardant treated wood's got to be manufactured according to NFPA 703. And NFPA 703 says fire retardant treated wood is impregnated, right? It's pressure treated wood. So that says I can't spray anything on it. I guess it's got to be pressure treated. So Hoover Wood Treated Products, you know, big supporter of codes and whatnot, they make that pressure treated, fire retardant treated wood. But there's nothing I can spray on it. Contrary to many claims we hear. Yes,
Isn't
sir.
that limited to a certain square foot area?
No, no. So some of the, you know, putting sprinklers in the attic is the devil, right? Because it's the highest, you know, it may trigger a fire pump, it increases your design area, it's a dry system, it's sloped, so you have automatically you have a 60% increase in your design area, which increases your number of sprinklers you're flowing, which increases your pipe sizing, which increases your pressure requirements. So everything under the sun is out there everybody's trying to get to develop a product that says you can eliminate sprinklers in your attic. And the only way you can do that is to make your attic non-combustible or out of fire retardant treated wood. So, light gauge steel trusses is exempt from sprinklers, right? Fire retardant treated wood out of trusses and with the sheeting on it, it's fire retardant treated wood. Doesn't have to be sprinklered, but it's got to be pressure treated. Yes, sir.
This is the first building I've seen of this. They are hanging a space heater in the attic to get away from a dry system, and they put 8-inch thick SIP panels on the trusses. Now, the penetrations through those SIP panels I'm concerned with, because if that fire ever gets into that someplace, I think in Kentwood or someplace in southwest Michigan, they just had a fire that they lost the building. Oh, it was a church, Coopersville. It got up into the SIP panels, and there was no fighting it because the fire department kept cutting holes and could not get to the fire and lost the whole church.
That's your jurisdiction, right?
Well,
Or close to it?
close to it, but I had the same experience when fire sprinkling was required in restaurant, in an A2 assembly, when you had an occupant load of 300 more. It's now 100. Back then, it was 300.
Yep.
So this occupant load was less than 300, so they didn't have the sprinkler. But they used the SIP panels up on the roof. So when you're in the restaurant, you're looking up, you're looking at the bottom of the SIP panel.
Yep.
They had a kitchen fire. It was a Mexican restaurant. They couldn't speak one word of English. The guy grabbed a 5-gallon bucket of water, threw it over top of the grease fire, got on the walls.
Oh, man.
It went up and started the fire on that OSB, on the bottom piece of OSB of the SIP panel. And then it got into the foam of the SIP panel, and they lost the whole building right through the ground because it just traveled through the whole building. They couldn't determine where it was at. I mean, typical attic space, you can knock a hole in it, you can fight the fire, but in those days, it's enclosed.
Yeah, that's some of the challenges of these new materials. And the SIP panel's not new, it's a challenge, right?
But I mean, even the interior finish in the bottom of the panel, the paint material that they use on the bottom of the panel was a retardant material. Didn't make any difference, I think, planed up and
Right.
going.
Yes, sir.
You talk about impregnated wood, you know, pressure treated, so that's the truss has to be that way, the plywood on the roof,
Yeah.
plywood below, so then where's the cost factor come in? You're gonna spend more money on those materials than it would be to sprinkle the attic.
Potentially, yeah. Potentially, so the comment was, you know, you can really increase your cost by adding fire retardant treated wood, trusses, sheeting to the project. Put sprinklers in. And I guess that's my vote too, right? Since I'm a sprinkler guy, but it depends, right? So in the Midwest, where we're at, our pressure, stacking pressure,
you know, all the way through the Midwest is running around 50, 60 PSI, right? It might go up a little bit, may go down, but for the most part, we're dealing with 55 to 60 PSI of static pressure. So in a 4-story building, I'm right about at that cusp of whether or not I need a fire pump, right? And when I get a sprinkler system into that attic with the 60% increase for dry and soaked ceilings, that may trigger the fire pump. And that's what people are trying to get out of. So you add the fire pump, let's say starting at about 80,000 bucks, right? That may offset that cost. It's a business decision. I'd go with sprinklers, but I'm just a biased sprinkler person. But I've seen it done. I've seen it done with lead gauge steel attic trusses or lead gauge steel roof trusses. Not too popular in Michigan, but Indiana, Ohio do a lot of lead gauge steel. Have you seen lead gauge steel roof trusses?
Yeah, not much.
Yeah, not much at all, but they're out there. I don't know if they cost compared to fire retardant treated wood or not, but probably not because it's steel. So, all right, back to dry barrel sprinklers. So dry barrel sprinklers attached to a wet pipe system. Here we have CPVC. You can see that real small barrel. And what we're trying to do with this table is determine barrel length. And you probably can't see it very well, but it's up there. That far left column talks about where the sprinkler is at. This is the exterior ambient temperature. And it goes from 50 degrees or 40 degrees, whatever it is, all the way down to negative 50 degrees. So Michigan kind of lands in this negative 20. Yeah, it can probably go lower. It can probably go higher. But here's negative 20. The 3 columns to the right of that deal with the interior ambient temperature. There's a column for 40 degrees on the inside, a column for 50 degrees on the inside, and a column for 60 degrees on the inside. Well, as code officials, do we know 40 or 60 or 50? Do we really know what that temperature is? No. We don't know. We don't really care. But how does that make a difference? And the answer is yes. That 40, 50, or 60 column changes that barrel length. So at 40 degrees, the barrel length for negative 20 outside is 14 inches, right? 50 degrees, it's 6 inches. 60 degrees, it's 3 inches. All right, what length do you think the sprinkler contractor wants to use? The 3 inch. Do you know at all times that that space is going to be 60 degrees? No. Can we verify that? Yeah, I guess we can do some energy calcs. We can get some proof. We can, with our heating system at a certain point, yeah, we can probably say, yeah, it's going to be 60, but I don't know. This is where I disagree with my own industry. I say, you know what? Forget this. As code official, where am I going? I'm going right there, baby. I'm going for the 14-inch barrel all day, every day, because that gives me the most conservative. I can handle that. All right. Is there a cost difference between 14 and 3 inch? Yeah, there is. Right. Over 12 inches, they charge by the inch. So again, another planner thing to get to take care of. Now, to the sprinkler contractor's defense, I can play both sides of this. To the sprinkler contractor's defense, the architect usually doesn't give me the space for that barrel. Doesn't give me a soffit to put that barrel in or to put that pipe in. So I'm kind of stuck as a sprinkler contractor. So it's not all the blame on them. But again, it's one of those things you got to verify on the plans, verify on the project. So, yes, sir.
I have seen now a flex that is a dry sprinkler.
You have. That was going to be my saving grace to all this. McCulloch makes a flexible dry sprinkler now that works really well in tight spaces such as this. So you've seen it on the job already?
Yes.
Yeah, they're relatively new.
I don't understand how they work because how are they designed so that that flex stays proper and that rod?
Oh, mechanically how does it work on the inside?
How do they work on the inside?
It's proprietary. I don't know. I think it's full antifreeze. To be honest with you.
Okay.
So where these typically have a mechanical link from the operating link back to here, right?
Mm-hmm.
That classes when there's a fire. I think on the Victaulic flex, I think they're antifreeze. But they haven't told me.
Is that free charge?
Oh, yeah, just the drop.
Just Right.
Yeah.
Okay.
Yeah. So when you're doing that barrel length, here's the other caveat you gotta remember, is that that 14-inch barrel, that 3-inch barrel is measured here, from the inside of the exterior wall to the fitting where it connects into the wet pipe system. So account for the width of the wall, the exterior wall, etc. So they're not ordering just a 14-inch barrel, they're ordering 14 inches plus the 2x6 plus the dense glass plus the porcelain on the inside. If they have brick on the outside or whatever, they gotta add that to it, right? So again, one of those things that you wanna check on the plans, make sure they're on the right page, and then you verify and feel that they're installing the same, in the same manner. All right. You're not here yet. 2016 edition of NFPA 13 requires venting on wet pipe steel systems. So in wet steel systems, there's what's called an air vent required for that system. Okay? But the 2010 to 2013 doesn't require that.
Does that go by size of the building or the size of the sprinkler as to how many?
No, so it'll be one per system. So
Regardless of system size.
regardless of system size. One for each system. So if you have a manifold of many risers, every one of those risers will have one. So it's one per system. Wet pipe, steel pipe. What's that?
It's gotta be fully accessible.
But it's gotta be, it's, you know, I love it when they do this. The manual, so a couple different ways to do this. You can do this by, AGF makes this air valve. There's a few other manufacturers of air valve. So you can get this automatic air vent. You can put a manual in where you can, release that air pressure at a certain time. You can do it through the remote inspector's test valve. So there's many different ways you can do this. But does it have to be accessible? No.
What manual should be accessible?
Say again?
It says manual should be accessible.
Yeah, manual, well, yeah, 'cause you gotta turn the valve to get it to, yeah.
In my opinion, on this one.
This is 2022?
2016 it starts.
That's a year.
2016, so you're not there yet. You may see it. But, all right. Hangars, so one of the things you're looking at the rough inspection is hangar locations. I wasn't the planner here that got too fussy on hangar locations on the plans because it never got followed regardless. But hangars certainly have to be in place. And I never really had a problem with the sprinkler contractor shortchanging himself on hangars, right? Because usually the hanger is there to assist the fitter putting the sprinkler piping in the ceiling. Where I find it, and where I find hanger problems is usually when another trade. I can't mention HVAC trade in here because you'll just throw stuff at me. But it's usually the HVAC trade going through putting ducts in and moving hangers and not putting hangers back. None of you guys or gals in here. The other people are not in this room. They do that all the time.
They can't hang their ductwork off of that?
Can they hang their ductwork off that? Funny you say that, but in the edition that you're under, no. But starting in this edition, yeah, they can, as long as they get the hanger. So hangers are listed, right? They're so can I hang other mechanical systems from my sprinkler hanger? The answer is yes, but it's got to be qualified by a PE. So it's common. Can you hang your piñata from it in your Mexican restaurant? No, that's not very good. I won't ask Joe this question because he won't tell me the truth, but what time's lunch here? Is it?
I think it's right about now.
Yes, I'm asking Joe about that. I see Dell up there walking around looking for lunch. Is it usually noon?
Yeah.
Okay. I missed the break. I apologize. You guys are supposed to tell me when break happens.
Break.
Except for Joe. All right.
I'm not right.
All right, hangers. Lots of different hangers out there. A couple things to know is that device up there, that part, and that part are listed. So the hanger, the clevis hanger, the attachment to the structure is listed. So it's got to be a listed product. It goes back to certainly your plans and whatnot. The all-threaded rod that connects the two isn't listed. So I can go to a hardware store and get all-threaded rod all day long and tie those two together. So your plans, while I'm not a hanger person, a big hanger person on plans, I do want hanger details. Because look at this hanger detail for this SAMI screw, right? Look where it's at. So we have a SAMI screw right in the center of that joist. And exactly, the exact application here is done on the job site. It's like, wow, look at that. It can be done. All right. So, Sammy Screw, this is certainly right dead center of that joist, dead center of the joist. This is what they told us that they were going to do, and that's exactly what they did. Great.
Where does it say it's got to be in the exact center of that joist?
That drawing, the picture.
From your drawing, right? So
It says, it shows it on the drawing that it's in the exact center, but where does it say it has to be?
It would go back to the manufacturer's listing, go back to Sammy, and see how they tested it. They tested it in that lower third, it would be there.
Okay.
Yeah. Yeah. It's also gonna tell you in that listing whether or not it should be in the center, whether or not it can be drilled and attached up to the bottom like this, or if it's gotta be a top bar. So, yeah, a lot of details there that we often overlook or often go, well, does it matter? Yeah, I think it all matters. So here we go. Here's one. Same plan, same plan review, right? Same detail, but look how it's applied. Looks like we have a sleeper or a purlin here on the roof, and we have attached it to the side of that sleeper. That's not going to fly, right? Because the sleeper itself, that purlin, the sleeper is acting like a purlin. We don't know if it's rated or structurally, structurally able to support the piping. Because again, this all goes back to your plans. I just can't, like, fire sprinkler shop drawing plan review doesn't just begin and end with that shop drawing, right? You have to have the architecturals, you have to have the structural plans to do a really good review. And this is where you're gonna find some of these details. Did the structural engineer account for piping? Did it account for the sprinkler system? And we find that on the structural drawings. And a lot of times it goes back to the building department to verify that. So in this case, I guess my challenge back to the contractor would be, all right, well, tell me that the structural engineers accounted for this, and we're good, right? If not, it probably needs to be hung in a different spot. All right, here's another, oh, that's a good one. So, my apologies to all the plumbers in the room, but you can't support sprinkler piping by that plumber's tape, whatever you call it. What do you call this again? Strap, lumber strap, yeah.
Banding iron.
Banding iron, yeah. So, banding iron plumbing strap is not permitted as a hanger, ever. Well, I guess in NFPA 13D, for a single family dwelling, you can do this. But say NFPA 13R, that's a big negative. All right. The other thing we look for too, I mean, yeah, the strap is bad, but also the distance from the hanger to the inline sprinkler. I think there's a slide coming up here on it. Oh, here's another good one. This was yours, right? This is your. Can I hang it from my ductwork? Right. So here we have I don't know if this is sprinkler piping here or not, but we have a pretty decent hanger, threaded rod. Then we have this guy here being supported by a bent all threaded rod. So, like it. All threaded rod can't be bent, right? Once it's bent, game over. We don't know what it's rated for. So, good stuff. Hanger spacing for steel pipe is basically two distances, right? Up to 1.25 inches. 1 inch, 1.25 inch is 12 inch or 12 feet, and then after that it's 15 feet. So there should be a hanger every 15 feet. Should be a hanger for every piece of pipe. Okay. Usually, again, like I said, fitters use a hanger to help them support a pipe while they're lifting the other side up to connect it. I don't really run into too many problems. Where I run into problems is when another trade takes them off to run something else, and they don't replace it. Or, before they bend it, they get something out of the way. It happens, right? That's why we're there. That's why we always have a job. We'll always have a job as inspectors, right? Because these things will always happen. No matter how many classes you attend, how many times you tell a mechanical contractor or sprinkler contractor or whomever, it will always be there. So on support, how far can that pipe be from the end of the inline sprinkler? Well, there's a table in 13. This is pretty much summarizes that table. 36 inches, 3 foot away for 1 inch pipe, 4 foot away for 1.25 inch pipe, and 5 foot for pipe that's 1.5 inches or greater. So that pipe can cantilever out there depending on how big its diameter is.
Jeff?
Yes, sir.
So on that last slide,
would you measure your 12-inch maximum to the higher point or the lower point, or go in the middle of that, like you said?
Okay, so the measurement here would be center line of that sprinkler, right? Center line of the sprinkler to the hanger. So
No,
Oh.
from the top of the head.
And then height.
From the top of the head to the ceiling. 'Cause
Oh.
you got about a 3-inch offset there with the,
The corrugated.
yeah.
Yeah. So
Would you go in
okay.
the middle?
Okay, good question. So NFA 13 addresses that, and it talks about the corrugations up to 3 inches. So when the corrugations are no more than 3 inches in depth, then you measure it to the bottom of the corrugation. When it's more than 3 inches, then you measure it like that flaky insulation stuff, right? You measure it to the top. So measure the top of the corrugation. Now, I don't know, have you run into floor pans that are with corrugations greater than 3 inches? I don't think so. I haven't seen it, but the rule is there if you need it for whatever reason. Arm overs. Do arm overs need a hanger? They do when they're more than 24 inches. So, and it's cumulative, right? And it's just a horizontal part. So I can come. So if this is my crossmate, I can come up. I can come over. I can drop down and go over and drop down. As long as those horizontal pieces don't match, don't get greater than 24 inches, I don't need a hanger, right? So every 24 inches for horizontal run, I need a hanger. What do we have? A spray on fireproofing. So a couple things to note here. One is anytime you scrape off that spray on fireproofing to put a hanger in, put a C-clamp in, a bar clamp in, then they have to go back and spray on that spray on fireproofing. So a lot of times what sprinkler contractors do, or any trade will do, is go and spot their hangers in there. Put something in there so it doesn't get clogged up, so the sprayers can go through and spray it all, and then come back and clean it up and put their hangers in. So that's the preferred way. But when you're going out and doing an inspection, and this doesn't really fall on you as mechanical, but it'll fall on building. They scrape away that spray on fireproofing material. They got to come back and respray it, which is pretty normal for them to do. Somewhere down the line, the sprayer's got to come back for something. So we just got to make sure that they've done that. The 2021 I-code actually says that spray on fireproofing comes down a foot. So it comes down a foot on that threaded rod. It comes down a foot on any secondary structural member. So I don't know if that's, it's definitely not in the code you're under, but it's in the 21 code as a new change. So I don't know if that's trade, or what, but watch out for it. What else do we have here? Okay, well, bracing. So we talked a little bit about seismic bracing. This is a lateral brace for seismic loads. So if you've never seen this, as this piping system is moving back and forth, up and down, to and fro, that brace does exactly that. It ties that, it takes that horizontal load and ties it back to a structural member. And if you go out west, you go to California, you go to parking garage or wherever, you will see these braces. There's lateral braces, there's longitudinal braces, and they're spaced about every 40 feet or so. Okay, that's kind of like the rule of thumb. Every 40 feet, there's one of these braces. All right. So here we're checking on some plans. This is definitely out from my buddy in Oregon. They do a lot of seismic bracing. But again, same process. If we had seismic bracing here, right, in some hospital projects, you may run into it. Some federal projects, you may run into it if you have jurisdiction. But again, it's on the plans. Check, verify. No different. You don't have to know anything about seismic bracing, right? So you check the plans and you check the site. And that's really like all of today. And again, that's what they have here. That's a lateral brace tied back to the structural member. All right. Hydrostatic testing. We'll talk about this at the end of the day. But here's a little bit of a caution. Contractors will probably know what to do better. But any piping that's concealed, the standard of the code isn't going to tell us it's got to be hydrostatically tested because it's concealed. But man, it really should be before they go burying that. Those contractors should do this so they don't have to go and rip out drywall or find the leak afterwards. But I know some AHJs push this, some code officials push this, and more or less in areas of the country where they can have home rule, right? In Michigan, we don't have home rule. We have a mini max code, we have one code statewide, and then we can make anything more restrictive statewide. There's many states like Illinois, Colorado, Washington State, California, Utah, Arkansas, Missouri, that can make ordinances, local ordinances, more restrictive than their building code or their standard. So some of them do require a hydrostatic test before it is covered up. And we can't. It's a good recommendation.
You could call it out on the plan.
Say what?
You could call it out on the plan.
That you want to perform this. Okay. Okay. Yes, sir.
Give 15 minutes to get out before lunch.
Okay. So
It's 1:45.
quarter to, so you're saying now? Okay. Is lunch here? Or
Lunch, I believe, is in lunch.
I'm gonna turn this over.
Guys, we'll come back at 1 o'clock. Let's, lunch will be in the.
Thanks, ICC. It's a privilege to have ICC here. I don't see them at every conference, but to have them here and tell you what's going on is certainly a good thing. I'm gonna grab my clicker here. Any questions during break? Any revelations? Any issues? Well, a lot of issues, right? No? No questions? You looked all this stuff up during break, right? During lunch? Yeah?
Absolutely.
Yeah?
You're 100% right.
Cool. Well, the Saginaw guys back here are pretty quiet today. Yeah, there they go. Hey, guys. All right. All right, so we had you have the slides. You have everything I'm going to go over. You have more than what I'm going to go over today. That's just the nature of the beast. When I get in front of you, when I'm talking about sprinklers, but we had some questions. Tom, go ahead. We had some questions about obstructions earlier today, and I'll make sure we cover that before we get too far. Make sure my clicker works here. Come on, clicker.
Light flashing on the end.
Is it? I mean, what does that mean? I can't remember what that means.
Battery.
It's not battery. Stand by.
Technical difficulties.
Yeah, no kidding.
Probably needs a little bridge.
Yeah. It might. This thing flopped on me last week too. I was in New York City. And then those guys wanted to leave early. I'm like, you can't leave early. Come on.
Okay.
And Ed, I said somewhere in the 3 o'clock hour, not 3 o'clock. So 60 minutes to 3 o'clock. It'd be 3:01 to 3:59.
I guess that's what you gotta do.
Yeah.
That's the.
Come on.
That.
Standing electricity with all this abundance of air conditioning.
Yeah.
I don't know.
All right.
Uh-oh.
Woo. All right. Well, I don't know what to do now.
Power down, power back up.
You wanna set it?
You got a clicker? Oh, there you go. Ed, you just knocked off like 30 minutes to that. That's what I just told you.
Good job, Ed.
Oh, boy.
Good up, Ed.
Keep it up there, man.
I knew there's a reason to have that around.
Yeah. He gives us early lunch, long breaks, and he has a spare clicker.
Pretty close.
Be the man, as they say. Yeah. All right, give it a second to think. You plugged a little dongle in, right? Yeah, you did. That works. Oh boy.
All I can do is
Like
try.
auto mechanic changing parts until you find it doesn't work.
That's right.
Yeah, I see an arrow.
Arrow showed up.
Oh yeah? Sometimes it doesn't like when I do that.
Oh, that might have done something.
It works. All right. We're gonna, I busted Ed's clicker too. So earlier today, and this is slide 83. You're in your on your presentation and the program guide. So we did go backwards 100 slides or so, And because we talked about a little earlier today about obstructions, so we want to talk about obstructions where we got too deep today. And obstructions can be, you know, it's simply a plan review thing. In plan review, we're trying to find as many obstructions as possible so we can address them on the plans so they don't become a problem at the final inspection. Doesn't always work that way though, does it? Plans don't tell us everything. Even when you have the architectural plans and the mechanical plans, and everything's at your disposal, something's changed. So knowing what the sprinkler obstruction rules are at is important. And there's actually two zones where sprinkler obstruction rules land. And most of them land in that first 18 inches. So from the deflector down 18 inches, pretty much about the distance this bulkhead you have running around here, about 18 inches, maybe it's a little bit more than 18 inches. But that first 18 inches is important. And that's where most of the obstruction rules apply. Why? Because when that water comes through the orifice, hits the deflector, which way are the droplets going? Right? They're going sideways, horizontal. So anything that gets in the way of that horizontal spray pattern becomes a spot on the floor, right? A dry spot, an obstruction, whatever. So we have this obstruction, most of our obstruction rules land in that first 18 inches. We'll talk about those. And then in that lower zone, which is from 18 inches down to the floor, there's really one big fat rule that addresses those. So we'll hit those. Look at that. So the first one here is it's called the beam rule. And if you're in the NFPA 13, it's section 8.6.5. So you've seen this figure in NFPA 13 forever, right? It's been there forever. It's been there since the 40s, this beam rule. And all we're trying to do here is get that sprinkler. All we're trying to do with any obstruction rules is get water under, water over, or water on two sides. And that's what we're trying to do here is get that sprinkler far enough over and high enough up or low enough to get water underneath that beam. Now, they call it the beam rule, but if you do a word search in your PDF or online for beam rule, you won't find it because this is just like a trade term, right? So section 86512, figure 86512, and table 86512 all come from here. So it is all simple dimensions, right? A to B. So the further over we get the sprinkler in dimension A, the higher we can be above from the bottom of the obstruction. So I mean, 43 inches, if my A dimension is 43 inches, I can be 12 inches up from the bottom of that obstruction. Pretty simple, right? So the beam rule applies to anything that acts like a beam to that horizontal water spray. So it could be a soffit, it could be a true, it could be an I-beam, a glue lamp, an LVL, whatever. But it doesn't have to be. It could be one of these lights, right? It could be a bulkhead. It could be anything non-structural too. So the beam rule is structural and non-structural. All right. A couple other things to think about this with this rule. So we talked about the deflector distance down from the ceiling, 1 to 12, right? So it's still that sprinkler still needs to be in that 1 to 12 zone. So we can't move that. We can't drop that sprinkler down and get out of that 1 to 12 zone. Maybe I'll rephrase that. We can, but now that sprinkler is outside of its listing, so then we have another problem. So what do we do there? We put a sprinkler on the other side of the obstruction, which we talked about earlier, right? We can meet any of the obstruction rules by putting the sprinkler on the opposite side of the obstruction.
Question.
Yes, sir.
What happens if that obstruction doesn't continue all the way to the ceiling? Can I move my sprinkler head up, get over top of it?
Sure. So the question was, what if the obstruction doesn't go all the way to the ceiling?
I mean, a piece of duct work or whatever.
Okay, good question. So that's one of the remedies to this here is to get, one of the remedies to your question is drop whatever down below 18 inches.
Well, sometimes they don't have the ceiling height to do it.
Right, right. So even if it does, there really isn't a table to say, okay, how high can we go to get over? So there isn't a table that does that. Yes, sir.
a real problem. I mean, that's the biggest problem.
Yeah.
That's a real problem. So if you go up besides 1 inch, you go.
Yeah, so over here, so you brought up something I've brought up for years, is increase the pressure, the hell with obstructions, you know, put more pressure, put more water in the compartment. What does it matter, right? If I'm in a small compartment, I fill that room full of mist and droplets, does the obstruction rules really make a whole hill of beans difference to controlling that fire? The answer is no. But to get back to your question is, the standard probably looks at this more like, even if that's dropped, treat it as if it goes to the ceiling. And so that would solve some of that ductwork issue.
No, it doesn't solve it. I mean, there might not be an opportunity to put a head on the other side of the ductwork.
Right.
And there might not be an opportunity to drop a head underneath the ductwork.
Right? So you put a sprinkler on the other side of the ductwork.
Well, you might not be able to do that.
Okay.
There might be more ductwork on the other side of that one ductwork I'm talking about.
Right.
I mean, ductwork, the people who install the duct are not conscious of the fact that we got sprinklers that are right here.
Amen.
Sprinklers go in first, then they come with ductwork to block every sprinkler head.
I've heard the other way. Sprinklers will last. Always the last on the job. So, are you, okay, so mechanical rooms are always trouble because they're full obstructions.
Corridors.
Corridors, okay.
Corridors are a bigger trouble.
So where's the sprinkler going in the corridor? It's going above the ceiling?
Yeah.
Okay. Well, then above that ceiling, above the ceiling there, you have a sprinkler and you have the sprinkler space, right? Sometimes, let's go back to sprinklers control fire, right? Once sprinklers flow water, they trigger the water flow alarm, fire department comes on its way, blah, 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 right? So we're controlling fire. This is a prescriptive standard, and sometimes we gotta apply some performance solutions to it. Sometimes there is not a prescriptive solution for your issue here, or your problem. Some cases, well, let's take a look at extra hazard, right? In extra hazard occupancy, I can have shielding of combustibles. So I can, what I guess the idea is here, raise the density to compensate for that, compensate for that obstruction. So maybe in that concealed combustible space, where there's just ductwork everywhere, there's a sprinkler stuck in the middle of that corridor, and that concealed space about yay tall, and there's really no where for sprinkler spray to go. There's really no place to put another sprinkler, right? But it is a sprinkler space. And I guess what I'm kind of getting to is sometimes that's the answer, right? Is sometimes there is no solution.
Can't you use the intent to meet the code?
The intent, yeah, the intent is to provide a sprinkler in every part of this building, right? Sprinklers throughout the premises, and that's what we have. So whether there's an obstruction there, what's in that corridor, what's in that ceiling that is so critical? So, yes, sir.
So he's mainly talking about concealed spaces, sounds like the application, right? Well, the CC1 heads, they have the flat deflector anyway, and they're throwing the water pretty much horizontal. And they can go longer distances, a lot of like your attic sprinklers, right?
Right.
It'll throw down the middle of the attic.
So the concealed sprinkler, that's where I was going to go to, was there's a specially listed sprinkler called CCs, Tyco makes them. They're a concealed sprinkler, they're a concealed space sprinkler. The deflector is shaped so it has this flatter throw across all these obstructions, like webs and bar joists and ductwork and whatnot. That is a solution for these really short combustible concealed spaces. Does that hit every one of your issues in this space? I don't know, but probably a little bit better of an application.
The solution is not forward.
Aren't they required in any space over concealed combustible space over 30 inches?
Are they required in every space?
The special concealed head over a certain dimension, I thought.
I thought it was under 24.
Under?
Yeah.
Okay.
Yeah, so if you got a sprinkler space that's under 24 inches, you have to use a special application sprinkler. But I don't know what your distance is there.
Well, you see a lot of times in hospitals.
Yeah.
You hardly got any room up there.
Right.
And by the time they put all the process piping and all their ductwork and all their ventilation air and all their water and all of their what's that? Yeah, communication stuff and all their little mechanical pieces. I mean, there ain't hardly a place up there for water even to flow. After a little while, you get 2 feet away from that sprinkler head, there's an obstruction in every direction.
I question though whether that's a concealed combustible space.
That is a concealed non-combustible.
Okay, then it's not required to be sprinkled. If it's a concealed non-combustible space with limited amount of combustibles, then 13 exempts that space from sprinkling at all. So look out for that. So even like the space, let's say this was, I don't know what the type of construction this building is. Let's say it's a type 2 construction. Most hospitals are type 1 or type 2. That concealed space above the ceiling is not required to be sprinkled because it's non-combustible.
Well, let me, so it's a panel, it's a suspended ceiling.
Okay. So the sprinklers come, figure in there, but they drop
Right.
to the, yeah, okay. But that's fine, because the ductwork is above.
Yeah.
Okay. The concealed space, that's fine. It's not combustible, it doesn't require sprinklers. So that's what I was trying to get to, is what is actually in the space. I don't know if there's any wood hotels left or not
The
hotels.
only way it requires sprinklers is if it was CPVC pipe and they didn't use heavy enough ceiling pipe. They gotta protect the pipe.
But what if the, okay, the question was, what if it's CPVC pipe and you gotta protect the pipe? The ceiling tiles suffice for protecting that CPVC pipe.
If it meets that certain spec, they don't.
Right, yeah, there is a spec. I don't know of any drop ceiling besides residential, single family dwelling, drop ceilings for your basement wouldn't comply, but I think everything else commercial would comply. I think.
Making the ceramic hybrid is really
Okay.
I've seen it where it didn't meet it. So you had to put sprinklers up just to protect the CPVC pipe.
I thought CPVC pipe could be in a concealed space without protection, without
Well,
sprinklers.
it's not considered concealed if the tile wasn't of the proper spec.
Okay. Probably goes back to the spec of that, the ceiling tile.
Yes.
Okay. Yeah, there are nuances, all these rules, right? Different applications. It's a thick book until you start getting into some of these nuanced questions. And you're like, oh, we don't really address that. We don't really address that. We don't
I
address
think
that.
that's all in the listing of the CPVC pipe. though.
Right.
Not in.
Which I told you earlier, I said go to Lubrizol, go to Spears, download that, have it, just because there's like another 60 pages of rules that we don't even cover in this book. Yes, sir.
So if you have an open ceiling, so it's not concealed,
Yep.
not combustible, non-combustible, everything, the whole building's a type 2B building, let's say.
Okay.
And you got ductwork that runs parallel down the corridor, maybe you got two or three trunk lines that run next to each other.
Yep.
Sprinklers, they try to put in the center because they want to get even coverage all the way around. So on one side, you got these 3 ducts that are running in there. How do you sprinkle that floor area? When there's no way to get around from those ducts not being an obstruction,
So you would drop a sprinkler below the obstruction.
every one of them.
Yeah. You'd follow the spacing of the sprinklers above. And it's just poor placement.
Or sidewall.
Or sidewall, yep. Yeah. Yeah, it's
The ones above it.
the design, right? So,
Well, see, the guy that's designing the sprinkling system doesn't know where the ducts are gonna go. This is all after the fact, and you come in there, and you're looking at it and saying, man, you got all these ductwork that runs down this entire corridor, it's an obstruction. You're gonna add sidewall sprinklers, or you gotta add a sprinkler underneath all these ducts.
yeah, I don't know if I would accept that as a plan reviewer, that excuse. I'm not saying this as a challenge or anything, but the spindle contractor has access to all the architectural, mechanical, electrical, plumbing plans to pull their shop drawings from, right? So they shouldn't be able to say, I don't know if ductwork goes here, I just put sprinklers in. And it's like, I don't buy that. That's what you're being told, I get it, but are they paying attention, are they jamming us through it? I don't know, but it does go back on them to provide this protection, either above, below, on the side of that ductwork. One of the solutions is to drop that stuff below 18 inches, and now if the ductwork doesn't go above 48 inches in width, then you don't have to put a sprinkler, you don't need that additional sprinkler. So, yeah, a lot of nuances. All right, good stuff, good stuff. Well, here we go, here's that. I think this is one of your situations right there for these wide obstruction rules. I think we missed something here though. Yeah, there's a beam rule, there's a soffit rule, there's a 3 times rule. We talked about the 3 times rule already. But for some reason, it seemed to be out of place. So we're gonna go, let's go back. Let's talk about this rule, this from 18 inches down, right? And that's this situation here. So from 18 inches down, there's really one obstruction rule, and that's the 48, that's called the duct rule, right? So any duct work, anything that's over 48 inches, requires a sprinkler underneath. They call it the duct rule because this is typically ducts that provide this large obstruction. But the rule starts at, it's greater than 48 inches. So you could have a duct that's exactly 48 inches, you don't have to do this, so it's greater than 48 inches. So what they're saying here is, I think I have maybe not. In the 2016 edition, they're allowing the sprinkler to come down within 3 inches alongside that ductwork, or come down and arm over and be within 1 to 12 inches below that ductwork with the same sprinkler that's at the ceiling. So that's how you install that obstruction sprinkler now. In the 10 and the 13 edition you're on right now, those rules don't exist, but starting in the 16 edition, they're there. So there finally is placement rules for that obstruction sprinkler. Okay? Within 3 inches on each side or directly underneath, they'll treat the bottom of that ductwork like a ceiling and be 1 to 12 inches below. Say again?
I thought you said you were doing 2 heads off 1 T or something on that. What was you saying about above and below the duct?
Okay, so right here, in this picture, we have sprinklers at the ceiling.
Yeah.
But these ducts are large enough to where they're, greater than 48 inches. So we need to come and drop the sprinkler underneath that if it's greater than 48 inches.
Not off the same T from the one above.
Certainly. Yeah. Because we're only calcing one. So earlier in the day, someone said, what about the additional sprinkler, the obstruction sprinkler screwing up the calcs? And I said, no, because we don't calc that obstruction sprinkler at all in our calcs. Because we've already calced the ceiling sprinkler.
Thank you.
Yeah, so we're only banking on that one sprinkler to go off, right? Or, the design area sprinklers. The obstruction sprinklers, it's either the obstruction sprinkler or the ceiling sprinkler that's going to operate in most cases. But that's what 13 tells us to do. Oh, these are all jumbled up. There's the 3 times rule. So the 3 times rule, we talked about it. I pointed at these columns here and said, okay, 3 times the maximum width of that column is the distance of your sprinkler, and then your default, or the maximum, the sprinkler can be is 24 inches. So regardless how big that is, 24 inches is the A dimension. If it's under, certainly it's got to be 3 times away from it. So if it's 4 inches away, 3 times 4 that's 12. So the 3 times rule is applicable to standard spray sprinklers. For extended coverage sprinklers and residential sprinklers, it's a 4 times rule. So you go 4 times the amount away with a maximum of 36 inches away. So the 3 times rule applies to structural members only, in light hazard and ordinary hazard. So this could be a fake column and it wouldn't apply. If it's a legit column, then it would apply. It also applies to the horizontal members of any structural members. So here we have the bottom of the bar joist. We got to be 3 times away from the bottom of this bar joist. We treat it the same exact way. So that's why you see sprinklers in the center between bar joists, between the webs. So they're like exactly dead nuts in between that web and 1 inch down. They're like there for a reason. They're there for that reason, so they meet the 3 times rule up in that bar joist area.
Can you go back a slide?
Yep.
Thank you.
Yeah, one that gets missed a lot is, it's related but it's not, is the high power storage, well, sprinkling those columns too.
Right. So on some of the high power storage criteria, the building code also got to one point where you could use sprinklers on columns to provide fire protection if your column was greater than 20 feet in height. That's not there anymore. It might still be in the 15 code, but it's gone. I know it's definitely gone to 18 code. Yeah. NFPA 15 covers some of those fixed water spray systems and fixed fire protection of structural lines. Is it 15 or 16? 16, okay. One of those. All right. I want to get the final inspections here, so let me jump. one more time. There we go. It's rough.
I got a quick question for you.
Sure.
So, when you're talking about the sprinkler head that's below the ductwork, is it set to go off at a different temperature than the higher ones, or are they the same?
Good question. So the obstruction sprinkler below the duct, or below the obstruction, is the exact same sprinkler as the one at the ceiling. Again, this is another 2016 change that finally specified what that sprinkler is. So if there's an ESFR sprinkler at the ceiling, and there's an obstruction below the ESFR, below it, you put an ESFR sprinkler there. If there's a, K5.6 standard spray, 155-degree sprinkler at the ceiling, there's obstruction, we put the exact same sprinkler underneath of it.
Okay, thank you.
Yeah. Again, another clarification in the 16 edition. All right, we'll go to final inspection then. Cool beans. All right, so some of this is, okay, so we go back to the owner certificate. We talked about this earlier. The owner certificate kind of grows from edition to edition. It's like this big in the 2007 edition. It's like 3 pages long in the 2022 edition. So they keep adding stuff to the owner certificate, which is super important, as I said earlier, to have, because now you have a document that the contractor, the sprinkler contractor has, written by the owner, that you can use as the AHJ or the code official to say, this is what you said you're going to do, and this is not what's here right now. We need to make some changes. So Ken and I were talking about owner certificate during lunch. So
Yeah, we had a bad example, really go south, huge building. Commodity was classified as standard commodities, but it was all this North Face clothing and what's the other, Under Armour and stuff. It's almost all synthetics.
right.
In synthetic packaging. It's crazy. And
Plastic.
that wound up as all Group A plastics.
Yeah.
Huge malfunction on sprinklers.
Yeah, well, I mean, the shirt I'm wearing would be a Group A plastic. The performance wear that you wear, the Under Armour, is all Group A plastic. It's put in a box, in a cardboard box. It's with other cardboard boxes. There's bubble wrap, there's wrapping around it. A lot of times the pallet that's supported on is plastic. So again, all that just kind of jacks that commodity up to a Group A. And it really comes down to storage warehouses are either Group 4 or Class 4 or Group A. From you all on your side of the table, make it all Group A, right? Because that's the most restrictive. And you can put whatever you want, wherever you want to put it, depending on the sprinkler you use, right? Whereas on the owner's side and the contractor side, let's see if we can get a Class 4, because there's a big water difference between Class 4 and Group A. And that's, you all get the phone call, right? Hey, I'm doing this at this height, with this packaging, on this pallet, blah, blah, blah. What do you think it is? Not your call, right? You're not the designer of record, you're the AHJ. You would say, hey, that's a Group A plastic. And they say, well, I disagree, Mr. Becklinger, it's a Class 4. Well, have your engineer show me the docs, right? Because they can prove to you what that commodity is on what packaging. They can get it to Class 4 if they really want to, but yeah, storage, love storage. No, I hate storage. Actually, storage is one of the easiest. Storage seems complicated, but it's probably one of the easiest plan reviews to do. Once you get the commodity figured out, there's a process you go through, very similar to your plan review and whatnot. But, storage is very prescriptive in here. You just got to find the right table, get to the right sprinkler. And it's actually getting better. So in the 2010 edition, storage wasn't all that great. So there's 3 editions in NFPA 13 I really dislike. 99, well, 2002, I guess there's more, 2007. I don't really care for 2010 either. Why? Because they finally got some of the storage right in 2013 and accurate. So, and then once we get into the 16, the 19, the 2022, it's all been storage work, it seems like, in those newer editions. Why? Because we're doing a lot of storage. Yeah. Question back here? No? Okay. Oh, what do we have here? The owner certificate. So again, comes one of our documents. Once you get later into the adoption, so the ICC guys said, hey, we're wrapping up the 2024 edition of the IBC and the IFC, that's true. You have yet to see it, but in the 2018 and 2021 edition of the International Fire Code, I know it's not your code, but it's important because it starts to correlate. One of the things that really went sideways in ICC and NFPA up to the 2015 edition was NFPA 13 had the list of commodities in going in this direction, and then the International Fire Code had a list of commodities going in the other direction. The two documents were as far apart as possible in 2015. And so, surprise, surprise, right? Two documents that don't correlate. So that's what we worked on a lot for the 2018 edition of the Fire Code, was to get this document, in fact, this edition, 2016, to correlate with the 2018 edition of the Fire Code. So if you're in the Fire Code, you have Fire Code Authority that's working on this with you, it finally starts to match. Because there were times that you could get the Fire Code to give you a lower hazard or lower commodity than what NFPA 13 would allow you. So it's like, that's not right. The code rules the standard, and the code is saying something's less than what the 13 says, you gotta design it to. So again, that's some of the work that we do at that code level. In the 18 and in the 21, the big change here is the improved storage layout. So the 2018 IFC said you have to post a plan of that storage or that warehouse in a conspicuous place by the riser or whatever. And on that plan are the aisles, the racks, the commodities, where the commodities are stored, the storage height. There's like 12 different things that have to be on this plan. It's basically your plan review up on the wall. And then the 2021 IFC said you have to maintain that plan, maintain that storage according to that plan annually. So earlier we talked about NFPA 25, and it's like 25 is the inspection, testing, maintenance of sprinkler systems. The one thing that 25 does not do and cannot do is determine an existing building sprinkler system, right? The oddest thing about NFPA 25 is this. NFPA 25 assumes the sprinkler system was installed accurately, or according to a plan, according to a standard, according to code, and it was done, installed right. So the minute you walk in, after that system's been installed, everything was installed right, even though it looks wrong. Okay, I know that sounds bizarre, but that's the way 25 is set up. So the change in the 2018 Fire Code and the 2021 Fire Code saying, here's the plan, and here's the frequency you got inspected to, overrides 25. Because 25 doesn't give anyone the authority except for the owner to make those changes. So now the 21 Fire Code is going to say, hey, you got to inspect, Mr. Owner, you got to realign your storage according to the approved plan on the wall every year. And that could be the code official doing that, could be the owner doing that, could be the contractor doing that. But why do we do things like that in the code? Well, because the standard couldn't do it. One of the greatest, fire sprinklers are like 96% reliable, right? Wet pipe systems, dry pipe systems in hotels and motels and hospitals and whatnot. Storage gets into like the 80% reliable and effective at 78%, 82%. And it's like, why? Well, because commodities change and storage height changes. There's a lot of nuances in storage. So. Anyway, want to adjust rabbit holes. All right, final walkthrough, obstructions. So you're going to look at obstructions that might not have been at the rough inspection. Kind of hard to do with rough inspection to see a soffit framed out or any of these other items here. So you have some ductwork that may not have been installed, that's exposed. This is probably your situation right there, right? Everything's in the ceiling. Yeah, probably tighter than that. You can see light through there. So. And some of the building features that weren't yet built. So certainly that restaurant there with that little eave inside is an obstruction, and there's an issue here, right? Because we can't spray to the wall that is supposed to go to. See, so all those obstructions would be noted on your. What else do we have in here? Painted sprinklers. Painted sprinklers are verboten, right? We can't paint a sprinkler on site. If there's any sort of paint on that sprinkler, it's got to be removed and replaced. Manufacturers can paint their sprinklers, but painters can't paint sprinklers as much as they think that they can, so.
Is there a shading area in 13 like there is 13R of missing
Yeah, there is. So what he's talking about is shadow areas.
shadow?
Yeah.
Sorry.
So I think I get to that. Let me check. If we don't get to it by the next break, let me get to that because it is an important part of our discussion on sprinkler spray. Yes, sir.
And the other thing we gotta look for is, sometimes the painters will put tape over the head.
Oh, yeah. Yeah.
I mean, I find it all the time, you know, they'll miss some of the top heads.
Yeah. There's a Walmart, Curtis, in Carroll, Michigan, that has a bag on a sprinkler in the back southeast corner. That's probably still there to this day. So, I gave it to you, Curtis. I passed that problem on to you, buddy. And you have since passed it on to somebody else.
Now you can sleep at night.
Yeah. The orange caps and straps technically stay on until final. At final, they come off. They don't work too well, sprinkler-wise. So I don't know if this is an uh-oh, and I don't know if you can see in the back what's really happening here, but
Popped out of the discussion.
there you go. Popped out of the discussion. So this is probably a recessed, semi-recessed sprinkler, which is okay, but somehow we've lifted that sprinkler is lifted up, and the discussion is outside of this discussion. So they gotta correct that, right? It's gotta be. That's again one of the things we look at. Discussions and cover plates. We go back to this slide here. All right, that's got a pointer on his. That's pretty cool. We gotta watch out for these too, because that creepy energy code, the energy code folks. When they do their blower door test, sometimes they blame sprinklers on being leaky. So they'll go through and they'll caulk the sprinkler shut. They'll caulk the concealer plate to the ceiling. And these are people that are totally unaware of what that device is. They just see a leak and they go caulk it. Well, the energy code prohibits that. So in the 2012 edition, we went into the energy code and said, guys, you can't do this. And, you can't do it before. I mean, 13 doesn't permit it. 25 doesn't permit it, 13R doesn't permit it, and now the energy code says you can't do it too, so sometimes we gotta hit it in 8 different ways in order to get it to work out. So these are listed. The cover plate for these sprinklers are listed, so a residential sprinkler, a quick response sprinkler with a cover plate, that's listed, no paint on it. But it's a little bit of a question on whether or not this discussion is listed with the sprinkler or not. So if it's listed with the sprinkler, go for it.
How far can the head be up inside the escutcheon?
Look on the cut sheet. The cut sheet's going to tell you how far that deflector can be from that ceiling plane if it's a semi-recessed or recessed sprinkler. This is too far. It's usually like 1/2 inch, 3/4 of an inch maximum as a recessed sprinkler. But each sprinkler is a little bit different. So you got to go back to the cut sheet and read it. All right. Nothing just rabbit holes here. Oh, we got another one. Oh, this is an easy one. All right. The painter said, yeah, I want a white wall, I want a white frame, I want a white deflector.
So how do you guys make sure they didn't just clean those sprinkler heads?
You get the head
Give
back.
me the old ones.
Perfect answer, I love it. Used to have them on a box or a baggie hanging on the riser when you go to do your final. You got the count, they got the type of heads.
Cool. All right, yeah, that was an easy one because of the, it's painted, right? The painter painted it, it can't happen. This is yours, right? Here we have a bag. Yeah, we bag the sprinkler. The painters bag the sprinkler, not get sprinkler spray on it, and then they come back and remove the bags. So, bad deal.
I think that's the sprinkler contractor's job. He needs to go back and follow up with this.
Okay.
Yeah.
But that's, I mean, ultimately, it is his responsibility, right? It's his system. Am I too hard on painters?
Well, to me, it's not a skilled trade, so you
Oh,
can't expect
okay.
much of it.
Yeah. Nice. I like that. I like that answer. Yeah. Painters aren't a skilled trade, so it's not their responsibility. They don't know any better. That's what we're saying. All right.
They should be painters in the room.
There are no painters in the room. I verified beforehand. There's one.
They should be doing their own quality control inspection before they call for it.
Yeah, right. Just like you close your pole alarms and stuff, you know, your corn stripes.
Oh, boy. What a grenade. Yes, everyone should be responsible for the work they do at electrical systems. All right, here we go. This is the green one. The discussion here is in place. I can barely see that from being here. I don't know what you see back there, but it looks good from here. And this is really comes to one of the issues with sprinkler inspections, right? Not all ceilings are 10 foot, 12 foot high. So getting up into those 40, 50, 60 foot high buildings, I don't know how you're verifying without getting on a lift. You know, maybe binoculars, but good heavens. My eyes are hurt. Drones, there you go. We've done a lot of inspections with drones in the last couple of years, haven't we? So drone inspection is certainly acceptable and permitted, and it's used a lot more in the last couple of years than it ever has been. So even like some facilities are using drones. It's kind of interesting. They'll geomap the drone to avoid the bar joist, avoid the obstructions, and actually go through the facility and do this ITM, this Integrated 25 inspection. Even though 25 says you do your inspection from the floor, there are some facilities that do this with a drone. And the drones are on autopilot, right? They're doing their own thing. They're sending back their images to a network. Someone's reviewing that footage, and this is the next phase, right? Next phase of your career and my career is going to a group of monitors to some undisclosed location to review footage of some inspections. India. Yeah, India. We're seeing it now.
It's gonna be AI taking over, right?
Yes, yes. All right, whoops. Uh-oh, I had to push the button here. Uh-oh, I saved myself. Well, that's not right. Oh, radiant heaters. So we talked about radiant heaters earlier. Somebody brought up radiant heater up in the SIPS attic. They do that to condition the space, to get rid of sprinklers or get rid of the dry pipe system. And sometimes it's easier to do it that way. But any heat source, NFPA 13, chapter 8, 8.3 tells us, you know, how far away from the heater we can be, you know, what temperature sprinkler can be in what distance. So, you know, it's typically like in this unit heater, usually it's in that 20-foot throw. From the front of that 20-foot in front, you know, in that area, that's when we increase the temperature of our sprinkler. We don't remove sprinklers, we just increase the temperature. NFPA 13 says that the entire building gets ordinary or intermediate sprinklers throughout. So this is the 155, 135, 195, 225 sprinklers throughout the building. When we get near a heat source, we can increase that temperature of the sprinkler to accommodate for that increase. So we have a steam main going through there. We have a heating object such as this. We have sprinklers that can get up to 650 degrees as an operating temperature. So they're out there. So the guy from ICC who was from Colorado, I was in Colorado a couple weeks ago. I toured one of the new developments. I found a purple. No, I've seen a lot of marijuana plants. Yeah. Well, so in one of the mechanical rooms of one of the buildings, one of the houses I toured, they had a purple bulb sprinkler in that mechanical room. Like, purple bulb sprinkler. I mean, I've had my run-ins with some of the counterfeit sprinklers and some of the Asian knockoff sprinklers you find on Amazon. I've had enough experience with that in the last couple of years. We could talk another hour on it. But the purple bulb threw me for a loop. I've never seen a purple bulb sprinkler. So I look at NFPA 13, and lo and behold, the purple bulb sprinkler is an ultra-high sprinkler. It's ready to go off at like 585 degrees. So there's no way this sprinkler in this mechanical room, this single-family dwelling, is ever going to get that. Well, yeah, it will, but it'll be too far gone for that.
Well, you just have to catch fire first.
Yeah. Gotcha.
According to this stuff.
Oh. All right, signs. Hey, not a super sexy topic, but signs that are required by NFPA 13. We'll hit some of the sign requirements, and this is really one of the some of the lowest hanging fruit that you can get. Signs are important because everybody knows today where everything is at, right? We just walk through the building, all the trades are there, the contractors are there, the owners are there, they know what they bought, they know what they have. But think about down the road, 10 years down the road, facilities managers change, owners change, people change, right? So signs are important to identify what is going on. So in this case, we have signage on all the control valves. These are all requirements that come out of NFPA 13. Some of these requirements come out of the building code too. So signs for control valves, especially when control valves get into, there we go. Especially when that control valve is not really at where it's at controlling the system, right? We have control valves. We talked about this PIV earlier today. You know, a PIV doesn't have to be like right in front of the building it's serving. Typically it is, but a PIV in the ground, we have no idea where it goes. So signs on that PIV is important. Signs on any valve is important. Not important, but required. But identifying what it controls, especially in a larger building where you have multiple valves, the standard is trying to get us to identify what parts of the building that control valve hits. Okay. Test connections, drains, so any auxiliary drain. So we talked about auxiliary drains earlier for wet systems and dry systems. This is one of them. I don't necessarily agree with how they did this, but it's I guess it's okay. So if we had an auxiliary drain right here in the ceiling, architect's going to just have fits that we're going to put the sign there. Well, it's got to go there. The standard says it's got to go there. Whether it stays there, I don't know. But we need to do our job. Drains, main drains, test and drains all get signs, right? So that floor control valve in the high rise or mid rise, it gets a sign because it's a valve. And the hydraulic nameplate is certainly required. Hydraulic nameplate, probably one of the more recognizable signs on a sprinkler system. Typically we see this attached to the riser. In fact, we've all seen this as a sticker attached to the riser, right? Seen this? Seen this? Standard doesn't allow that. I've had many, with my name on it. Many stickers attached to a riser. The standard is actually saying, hey, put this on a placard, attach this placard to the riser with some durable material, like a chain, in this case, like a gold chain, right? Gold chain is certainly more impressive than a galvanized chain. So, my attempt at humor. So. Oh, I get it. Thanks, Joe. Finally. You're slow, but you get there, buddy. The other sign we get is called a general information sign. And this is somewhat new. It's new, 2010, so it's not new for you, it's newer. So a general information sign is coming from the contractor to say, this is what this system does, right? Here's the design area, here's the water supply information, here's what's going on in the building, here's the storage height, here's what's being stored. So it's kind of the mirror of the owner certificate, but in the contractor's words. This goes by the riser. It identifies other areas of the building that may have valves. It identifies other areas that may have like an antifreeze loop. So again, this is also required by NFPA 25. So NFPA 25 doesn't require any retrofit anything, right? I told you earlier, when you walk in a sprinkler building, 25 says everything's okay. This is the only thing in NFPA 25 that's required to be done new. So, and contractors gripe about it, building owners gripe about it, but any of your buildings that you're enforcing 25 with has to have this general information sign.
Got a question over here.
Sure.
What was the RPC on that?
RPC on which one?
That one. They're right below that tamper switch?
I don't know. Why does it need an RPC? I don't
Double check. You need double check. You need something, don't you?
Yeah. Oh, well, double check assemblies, RPCs aren't required by NFPA 13, right? You know that.
It's got a double check.
It's got a double check. Okay.
Especially didn't cross conviction rules before it too.
Right, so the double check, the RPC is coming out of the plumbing code. So, NFPA 13 says 0 about requiring backflow and double checks and RPCs. So, our NFPA 13 requires one single check valve. They call it a directional valve, right? To get water going in one direction. As far as water quality and all that, that comes out of the plumbing code or utility. But 13 does say, if it's required by a local authority, it's gotta be installed, and it's gotta be accommodated, and the friction loss has gotta be calculated and all that. You don't get a free pass just because 13 doesn't say you gotta have it. All right. What else we have here? Antifreeze systems. Antifreeze system, a new antifreeze system today has to use listed antifreeze. Here's one of them, LFP. And then after the sunset date of September 30th of this year, then all antifreeze systems required to have listed antifreeze. Okay. Except, y'all know this, right? We read a rule with 4 exceptions, right, with it. The exception is, and this is yet to be determined, so the NFPA process is very similar to the ICC process, but at the end of the process in ICC land, the code officials vote on the changes, right? So like the end of this year, in the fall, you'll be asked to cast your vote against the proposals that are in the current cycle. Maybe you do this, maybe you don't do this, whatever. In NFPA land, any member can vote on an issue. And their voting session comes up in NFPA once a year at their annual conference. So usually Wednesday or Thursday of that meeting is a technical session. And that's where you go and vote on specific issues. This year, in a few weeks, there's a couple different specific issues that affect antifreeze. So the 2023 edition of NFPA 25 is going to come out and say, as long as, so you don't have to switch to listed antifreeze if your legacy solution is within the same installation gravity, right? So if you're basically saying, if you don't have to add new antifreeze to make this work, then you can leave it in there, right? If you have to add new material, new antifreeze to get your concentration up, then you got to switch to listed antifreeze. That's one of the things that we voted on here in a couple weeks in NFPA in Boston. So the sunset of September 30th of 2022 might get a little altered here in the next few weeks. So that isn't a hard fast rule. Going to listed, eventually every system is going to go to a listed antifreeze, because eventually that antifreeze solution in that existing system is going to get diluted through condensation, new water flow, or whatnot. So eventually, all antifreeze systems will have to use listed antifreeze. This just buys those existing systems a little bit of time. All right, signage, low point drain. So here we go on the general information sign. I told you this was new. This was new in the 2007 edition. So here's the location on the general information sign where all those low point drains are at. The ones that the architects don't want to put signs by, they're going to be identified there. FDCs need signage to tell us what building they serve. So with these remote FDCs, definitely got to tell us what buildings they serve, what systems they serve. Yes, sir.
Back to that for a second.
Yeah.
I think somebody else had a question.
Hey, Jeff, is there a height requirement for the bell? I had that question the other day, I could not find it.
For the exterior bell?
Yeah.
No, even when it's a horn strobe. So NFPA 13 does not require a local water flow alarm. So that bell, they recommend it, but they don't require it. The IBC requires, IBC requires supervision, but the bell, there's no height requirement. Even that water motor gone, there's no height requirement for it. So, yes, sir.
I just can't stress enough how important it is, because we ran into several buildings that were limited area sprinkler systems. Maybe they just had to sprinkle the basement because of the distance, travel distance, or what have you, or obstructions. Fire department has no clue that system only serves the basement. So they connect to that, and you could lose firefighters because we don't have that sign correctly. So we need to make sure that happens. And also, especially those strip malls where they have maybe a couple fire department connections, they change tenant spaces and they alter this stuff around, and it's real nightmares trying to sort out which piping, which FDC goes to which shops, which addresses. It took us months to figure a couple of those out and get it
That's where that signage is important, because right now we know where everything is, but 10 years from now, we have no idea. So, yep. Sounds, like I said, it sounds just like a, you know, a make-work project, but it certainly has its advantages down the road. So this is, I talked to you this earlier, this is a 2018 International Fire Code. Again, not your code, but it does have to do with sprinkler systems. It is something that you're gonna see coming down the road, is having that approved storage plan posted. So this is gonna come through the fire code, but again, this is supposed to assist in these annual inspections of these big storage buildings. So we put everything on this plan, and then the 2021 edition of the fire code says you got inspected. Not you, somebody's inspected, right? The building owner. It's a building owner system. It's their responsibility to maintain it. All right, pumps and riser rooms. The building code and the fire code has rules for pumps and riser rooms. So again, there's adequate work. So the IBC language says that there needs to be adequate working room around this equipment. It's kind of more of a plan review thing, but again, at final inspection, we're making sure that that room exists. Riser rooms are dedicated to sprinkler risers, right? And NFPA 20 tells us for fire pumps that nothing can be in that room but the fire pump equipment. We don't necessarily get that specific language in NFPA 13 for sprinkler rooms, but the idea is there, right? It's not supposed to be the catch-all for any other missing equipment. It's supposed to be there dedicated to the riser room. When it's a fire pump room, it is exclusively dedicated. There is nothing else that goes in there goes in there. So when we're thinking about adequate space, we're thinking about the space it takes to maintain that equipment that's in there, right? If I gotta lift up that 8-inch valve, how do I get that 8-inch valve out? And how do I replace that 8-inch valve? You know, do I need a lift in there? Do I need 2 people? Do I need a cart? That's where the working space or working clearance comes from. And it's very subjective, like, you know, how much room do you really need? Well, I don't know, but the code says you gotta have sufficient clearance. Can certainly have access, so nothing really requires a riser room, but if one is installed, all these items need to be addressed. And this isn't in, well, in the 2015 Michigan Building Code, it just says pump and riser rooms do this. Later edition says, the 18, the 21 edition talk about the heat in the room, the access to the room, the key, the marking of the door, and all that. So you don't quite have all of this yet until you get into the 18 or 21 code. Okay. Spare sprinklers, we hit some of this earlier. So let me just, again, this doesn't seem very important until that sprinkler is replaced after a fire, right? So we have that spare sprinkler box there, and when that building has less than 300 sprinklers, you got at least 6 of each type, or 12 of each type when you're over 300 sprinklers. How do we know how many sprinklers are in the building? Plan review, right? And plus, I would suspect that most of you charge your permits off a number of sprinklers. Yeah? You charge your permit fees off, yes, okay. So there you go. What? That's just, getting the number of sprinklers in there is one, but getting the wrench in it for each type, that's another one. How many wrenches do you see in these boxes?
As many different ones as what the heads require.
Yeah, that's what.
Could be one, could be.
Could be, yeah, could be many. Crescent wrench? No, can't. You just can't throw a crescent wrench in there and call it good. So.
What about the heads that use the socket to get them out?
Yeah, that's part of the wrench. So even some of these concealed, these new concealed sprinklers, the cap, the orange cap becomes the wrench to get them in there. So the new sprinklers that are in the cabinet will have that cap on there. So you don't see the cap in there, but Viking has some orange cap sprinklers. Senju has some orange cap sprinklers. So, yeah.
Excuse me.
Yes, sir.
What's the paper in the box?
The paper in the box. That's zigzag.
No, back one more.
Should be this schedule for what?
Head legend, you mean?
Yeah.
Information?
Yeah.
Oh, headlight.
Inventory.
So there's a list in the cabinet of all the sprinklers in the building. And it's basically that you know, a cut from the shop drawings.
I just had, instead of failing them on the final, I said, take your pocket knife and cut it out of your set of drawings and keep it in the inside and we're done.
You're a nice guy.
The right numbers on there.
You're a nice guy. All right.
I don't want to go back for that.
Yeah, I don't know, but if that's the only thing, yeah, I don't blame you. All right, so I don't know what's the issue here, but it looks like we have 1, 2, 3, 4, 5, 7 sprinklers, and they all kind of look different from each other. So I don't think we have a minimum of 6 of each type in there, certainly. Looks like we have a smattering of a few. So again, final. Yeah, you know, head box. Very rarely do you see a head box like this. Usually head box are head cabinets, right? Because we have multiple types of sprinklers in a building. Dry barrel sprinklers, got to be at least one dry barrel sprinkler and a few dry barrel sprinklers installed. All right. Where do we want to go from here? You know what we want to do right now is take a good or quick 5-minute break. That's what we want to do right now. Let's do that. All right, well, I'll be true to my word. Get you out before 4:30. Did you have something, Sue?
The board meeting is at 4:30.
So can we do the board meeting and class at the same time? All right, there you go. I will be out of here. Yeah, somewhere there. 3 something. 3 o'clock somewhere. Ed went to 3 and I said, nah, that's a bit much, buddy. Wow, I'm gonna miss that. I'm gonna spend all that money at Jay's as soon as I walk out of here, so whether I have it or not. All right, before we get to final acceptance, a couple of slides here I thought were really interesting because again, my instructional designer did some of this and I'm like, oh, this is pretty cool. So again, what we're trying to protect here is the storage or not. So if it's, you know, so if it's not storage, this is pretty handy and it's in your slides, it's in your handout. But if you're new at this, you're like, okay, what's the difference between a hazard classification and a commodity, right? Hazard classifications are everything non-storage related. And if it's is storage, then it's classified as a commodity. So this space would be a lead hazard space. But if we put racks here and south house storage here, it would be classified as a commodity. So this here covers the room or the space that the system is protecting. This in storage, we're classifying that room or space by what's in there. What are we storing, right? We're storing polystyrene, coffee cups and cardboard boxes on plastic pallets and shrink wrap and all that jazz, or we storing concrete blocks on a wood pallet, right? Or mayonnaise in glass jars or mayonnaise in plastic jars. Those are all commodities. So if it's commodity, the classification still is in chapter 5, but your beginning chapter, your starting chapter for plan review or inspection starts where? Anybody? Chapter 12? Yeah, I heard that too. Chapter 12, that's beginning your storage stuff, right? So chapter 5 also addresses these hazard classifications. Okay. Does everyone know where to find the lists of examples of commodities and hazard classifications? Does anyone know where there's a list of that exists? It's in the code, right? Well, yeah, it's in the code. Back in where? Back in the annex of NFPA 13, right? So in your 2010 edition, 2013 edition, go to the annex. That's Annex A, A.5.2 for light hazard, A5.3 for ordinary hazard. And there's a list of different commodities, different hazard classifications. Schools, nightclubs, unused attics, plastics processing, flammable spray finishing. All those examples land in the back of the annex of NFPA 13 to help you make sure that whatever design is coming in front of you is on the right track. Same with commodities. There's like 10 pages of commodity examples in the back of NFPA 13 of Chapter 5. So go to the annex of Chapter 5. There's just pages upon pages upon pages of these different commodity examples. The 2018 and 2021 International Fire Code has the same list of commodities in Chapter 32. So that was one of the big projects we did with the ICC, the NFSA and ICC did a few years ago, was to get all that correlated. So they all match. All right. I think it's a good slide, good handy slide if you're wondering where to start with. All right. Any questions?
And those commodities, does it have it in there for boats?
For boats?
Diesel or wreck fuel?
Ooh, wreck fuel, boats. Like as far as storage? So that would be handled by, so any flammable or combustible liquid is handled by NFPA 30. So it's the fire protection criteria for protecting flammable combustible liquids comes out of NFPA 30. The criteria for that, the density and whatnot, the application installation of sprinklers would come out of 13. So 30 would say, hey, it's got to be ordinary group 2, extra hazard group 2, install it according to NFPA 13.
Does quantity fall under the building code?
Quantity. So good question. How much stuff can I have in my building? So quantity lands in the building code. It's also in the fire code, and it's also in NFPA 30 as far as the material maximum allowable quantity. Yeah. Yes, sir.
Flammable liquids is like a bourbon or spirits. Is that in NFPA 30 also, or is that following something different? Like these new micro craft distilleries.
So distilled spirits. Let me slide this over here.
Maybe 16%, right?
Yep, 16%. Let me open this up. I got a few blank looks when I said this, so I just want to make sure you know where I'm going here. So anything in NFPA 13 or any NFPA standard that where there's a number that's followed by an asterisk, if you're in the PDF, you hit that asterisk and it takes you back to the annex. So the annex gives you the explanatory text of the rule. So the rules land in chapters 1 to 27, 28. And the annex, when it has an asterisk, has some sort of explanation to that rule. Not every rule has it, but this is what I was talking about. So back in the annex, we want some examples of light hazard occupancies right here. Oops. Use my finger here. And then you had the same for ordinary hazard. It's kind of hard to do this with one hand, twisted, but yeah. Ordinary. So earlier I said the seating area for restaurants is light hazard. The kitchen area is an ordinary group 1. Parking garages. So parking garages, you can see up in ordinary group is an ordinary group 1. Big change in 2022 is now it's an ordinary group 2. So that hazard has increased. Yep. Distillery. So the distillery question is kind of an anomaly. Yep, it's right there. It says it right there. Well, I don't think it's 100% accurate because the distilleries have a lot of different things going. So the 16% is an issue, but I can tell you this. Factory Mutual, FM, has a data sheet. So we live in ICC, plumbing code world, mechanical code world, Michigan code world, NFPA world, right? That's where we live in. But there's another part of our world called Factory Mutual. Factory Mutual is an insurer, right? So they underwrite properties, usually big properties, and they have their own data sheets. And their data sheets are more restrictive than NFPA 13 or the code or whatnot. So FM does have data sheets on automatic storage and retrieval systems, if you have one of those systems in your jurisdiction. They also have a data sheet on distilleries and distilled spirits. I think it's FM data sheet 8-29 or something like that. So there's some rules in there, some design densities in there to protect the warehousing of distilled spirits. Wood barrels and racks, wood barrels stacked on edge and on its flat. So there are some rules out there. The 2024 International Fire Code will add a new chapter to start to address distilled spirits. Part of that is the design densities. Most of that, to boil all that down to a higher concentration of alcohol, is that a lot of it lands in ordinary group 2, all right? But the design area is large. Like, all the sprinklers in the building are calculated to go off. So whereas in this building, if you calculated the sprinklers, we're looking at maybe, what, 10 to 15 sprinklers as our calculation. In a distillery, all the sprinklers would be calculated, so you have a giant water supply to handle that. Ken?
A lot of them would be H occupancy too, in trigger.
Oh, true.
Because the majority of, it doesn't take much open use or open quantity of flammable liquids to trigger H.
Yep, a lot will start in H, and that's what's going to trigger the sprinkler system. The sprinkler system design is going to go to 13, 13 is going to send you to 30, 30 is going to send you back and say, do it to 13, and getting our criteria is sometimes the difficult part. So here's a list of some of the commodities. Like I said, there's like 10 pages of these different commodities if you're doing storage. It's all in here, right? And not everything. So earlier I got the hairy eye from some of you saying, hey, 13 doesn't cover everything. I said, no, 13 doesn't cover everything. It's not intended to. There's a list here back in the annex, for example, right here. These are the commodities not addressed by NFPA 13. Boat storage, stored in racks. You know, empty wooden crates, butane lighters. So the pod storage, so the container of the pod, the UODS pods, you know, there's no criteria for that. So 13 is trying to come out in front of this and say, hey, we don't have nothing for this. Don't go look for it. It's not in here. But again, it's back in the annex.
Where do you find in-rack? In-rack is the question. Where you have the heads have to go inside at each level of the racking.
Okay, question is, where do I find the requirements for in-rack sprinklers? So I would start in chapter 12 of NFPA 13, and from there, depending on, actually the rules for in-rack sprinklers are in chapter 12, but you don't put in-racks in until another chapter says you gotta put them in. Confusing, right? For the most part, ESFR sprinklers do not have in-rack sprinklers. That's why they're preferred by owners and contractors, because they can handle the Group A plastic, they can handle high pile storage, and without in-rack sprinklers. Owners like that because they hit them all the time, right? We get into the CMSA sprinklers or the CMDA sprinklers, that's where we'll run into in-racks. So we talked a little about ESFR or CMSA sprinkler. A CMDA sprinkler is nothing special, it's nothing different. It's the terminology we use for a standard spray sprinkler when it's used in storage. We call that a CMDA sprinkler. And there aren't too many, I can't talk and click at the same time. There aren't too many standard spray sprinkler design criteria that go over 15 feet, 20 feet, and not for anything super flammable either. All right, am I in the right spot? There I am. We could talk sprinklers for days. And I think I could wear you all out with it, right? Couldn't I? Yeah, you wore my ass already, Jeff. Come on, done. All right, acceptance testing. So we've done the rough inspection, we've done the plan review, right? We issued the permit, we've done a rough inspection, we've done our final inspection, and now it's time for acceptance, right? So back in chapter 25, 26 of NFPA 13, we have our acceptance testing. This is where we're going to put the system through some tests to make sure it can handle the pressure, make sure it can deliver what it was told that it could deliver, and then we can put it into service and call it good. So there's hydrostatic testing, there's pneumatic testing for the dry and pre-action systems, there's some operational tests like a main drain test, and there's this mysterious thing called the instructions for the owner. And this is really kind of neat because no one really enforces this. As an AHJ, I didn't enforce this even though I said, did you do this? And the contractor's like, yeah, I did this. So we'll talk about that as we get through there, get close. And then at the very end, there's another certificate. So we have the owner certificate, we have the underground certificate, and at the end of this process, we'll get the above ground certificate. So again, if you learned nothing from today, there's 3 pieces of paper you need to get from the sprinkler contractor. Owner certificate, plan review, underground certificate. By the time they connect the underground to the above ground, underground to above ground, and then and when they're all done, they're supposed to give you an acceptance of the above ground certificate, right? And if that's all you take from today, and that's an improvement to your plan review and your field inspection process, good deal. We'll take it from there. Sue's already trying to sign me up for the fall class, so. You're not here yet. When you get into the 2018 edition of the building code, you're going to get into what's called NFPA 4. So because of that, I won't even get there. I won't even go there. That's another whole animal. That really has nothing to do with sprinklers or acceptance testing, but it's another part of the process that we need to get involved in when you adopt the newer code. All right, so hydrostatic testing. So the system's in place, everything's in place, all the sprinklers are in, and we're ready to turn this building over. One of the first tests we do is called the hydrostatic test, and this is where we apply 200 psi throughout the entire piping structure, piping system, right, at 200 psi. And we pump it up, we fill it full of water, we pump it up 200 psi, and we leave it for 2 hours. Why? Well, one of the things, because sprinkler systems do get a higher pressure than your normal plumbing system, because we have that fire department connection at the exterior that the fire department's going to connect to and supplement that pressure. So we need to account for that higher pressure. We account for the higher pressure when we do the hydrostatic test. It's not just one of the misnomers is it's not just 200 psi. It's 50 psi over your maximum static pressure. Which in Michigan or the Midwest, we don't have 150 plus, static pressures at the road. There's some areas of the country, Colorado, Denver, Colorado Springs, Salt Lake City, Utah, do have pressure. Their pressure problem is the opposite. They have way too much pressure. Yes, sir.
I was gonna say, I did a plant over in Ypsilanti, a work plant. They had an old system and I wanted 200 psi's, but it was probably an 80-year-old system. So I went back and only made it put like a 50 pound test on it. Because I was afraid it was all cast iron and everything else like that.
Cool. Yeah, so you brought up what Ken and I talked about during break was hydrostatically testing modifications to the system. So for a brand new system, this happens throughout the entire system, right? Let me come back to modification. Let me finish this one first here. So we pump the system up. We wait for 2 hours. When we look at the gauge, if we lost any pressure, the hydrostatic test failed, right? When we look at that gauge, exactly the way we were standing in the first place, and we see a drop, then the system fails. If we see a leak, the system fails. Okay? So automatically, see a leak, test is done, system fails. Fix the leak or leaks and call me back or call us back. We'll come back and take a look at it again. Most good contractors are doing this way before you show up to witness this to make sure they don't have any leaks. So, watch out. There's a couple of things to watch out for here. One is it's kind of up to you. So the sprinkler foreman is going to pump that system up. Sometimes you can witness them pump it from 0 to 200. Sometimes that takes some time. A lot of times what's acceptable to you all is watching the last 15, 20, 10 pounds, whatever, being applied, seeing them disconnect the pump and putting the pump away so the pump doesn't automatically kick on and keep the system up to 200 psi. Make sure they disconnect the pump. The leak, I told you earlier, don't overthink this. Well, there's a parts of this standard that we do overthink, and it has to do with leaks, right? What's a leak? How do you define a leak? And the definition of a leak is when that droplet leaves the piping, that's a leak, and it hits the floor, that's a leak. When that droplet forms on that pipe and it stays in that pipe for 2 hours and doesn't drop, it's not a leak. Leave that. That's in the standard, right? Then it's like, okay, someone overthought this, but that happens. Watch for that pressure gauge drop or increase during the day, especially like today when it was like 55 degrees this morning, and now it's like, I'll rub it in. It's like 82 and sunny out right now. You wouldn't know this because you've been sitting here all day, but it's really nice outside. Watch that because you know, when we have a temperature increase like that, we're gonna add more pressure to that system. And just vice versa, when it gets cold, it's gonna drop. So a couple pounds without any visible leaks is usually pretty acceptable for the hydrostatic test. Usually, because I don't want to get back myself into a corner here. Modifications. So the standard, NFPA 13 says when you're modifying up to 20 sprinklers on a system, you don't have to hydrostatically test the entire system, right? The existing system you brought up, at one time, we're assuming, hate to use that word, but I'll use that word, we're assuming that at one time there was a hydrostatic test done to that system. And this is like a one and done, right? Everything was done at one time. We don't know when, but it was done. Now, when we're moving system, we're moving sprinklers, modifying the system up to 20 sprinklers, the standard says we can just test that at system pressure, right? Whatever that system pressure is, we turn it on, watch it for 2 hours, if it leaks, it fails, and move on. We don't have to pump it up. When we get over 20 sprinklers, then the standard says, yeah, sure, hydrostatic test the system, but you're allowed to isolate the new sprinklers, right? So if we've added on, if we've gutted this entire room and, you know, relaid out the sprinklers and it's over 20, we can isolate this room, pressure test it to 200 PSI and call it good. Standard also says if you can't isolate it, like it's impossible to isolate, we can work at system pressure. We can test that system pressure. Usually when there's a disagreement between you all and the contractor, right? What's impossible to isolate? Well, is anything impossible to isolate? No, I can break the system anywhere, put a cap, put the pump on it, call it good. It's just, you know, when does it become unreasonable? And that's a judgment call that you all gotta make. So, you know, a sprinkler, let's say this room is a sprinkler, right? And let's say we replaced a couple sprinklers, we put a divider in there, and we had to move a couple sprinklers because we added a room. And then, so a couple sprinklers over there, and we've done that throughout the building, right? We remodeled the building, we moved 25 sprinklers throughout the entire building. How do we do that? It's tough to isolate those 25 sprinklers. And, you know, the piping, the fittings, the sprinklers, the equipment, everything in that system can handle that 200 plus PSI. We know that from the manufacturing standards, but sometimes we just gotta let it go. But anyway, just
All right, this is my question, white box. You go in, the whole white box is done, you have one unit on the far end. Then, 6 months later, you have 2 more tenant spaces built out with drops then all of a sudden put in because they have a drop ceiling. And then 6 months later, you have the rest of the units filled. Well, each unit may only have 12 heads.
right.
What, when you say 20 heads, is it 20 heads per job? Or is it 20 heads for the system? Because that's a whole nother argument.
Yeah, 20 heads per permit. That's all I look at. Oh boy, look at the time. It says 20 sprinklers per system. And we've already identified what a system is, right? A system is a network of piping that has a drain, a water flow switch, water supply, and a valve. That's the definition of a system. So if that strip mall is all one system, you've already hydrostatically tested it when it was a white box or a spec building. And now you're going in and updating that system, and that's where you have your, you know, is it cumulative? I really don't know. You know, if we do 10 sprinklers today and 18 sprinklers next year and 40 sprinklers next year, we know that the majority of that piping has been tested.
Yep.
And that gives us some comfort. You know, the new pipe being in there, you know, do the best you can do.
And it's the difficult fire marshals that really hold the feast of fire.
I understand. I talk to those guys and gals a lot about this situation. And some of them get to the point where, yeah, we put 2 sprinklers in that new room there, isolate it and test it. We put 4 sprinklers in the other part of the room, isolate and test it. I'm like, is that really reasonable? What are you afraid of? What are you fearing? What are you trying to accomplish? So we gotta watch that.
In a strip mall, if you did that and you only had your mains at the beginning for your hydro test, would those mains would have to be designed for every square foot of that building, even if there's no walls in it?
Right. Right, so his white box.
Size it for that.
Right, so his white box spec building is sprinkled throughout, right? And right now it's all on the ceiling, and we have yet to lease out the space and drop all our sprinklers. Now, a good sprinkler contractor, a good layout technician, a good owner is gonna spec that building to at least an ordinary group 2. Because with that, at least I get my spacing down to 130 square feet. I have the highest amount of density for typical most strip malls, right? Most strip malls are either mercantile business, ordinary hazard, or light hazard. So I can cover that with that ordinary group 2, pretty much consistent across the board. I can even do some miscellaneous storage with ordinary group 2. That's my advice, is designing that entire white box, that entire spec building is sprinkled to ordinary group 2, and then you drop down when you build out. And at least that way you have, hey, you have a hydrostatic test done at that system when it's at 90% or 90% done, and sometimes that's close enough. Yeah. Close enough for sprinkler work, right? That's, yep. But you know, yeah, here we go. Modification effect, 20 plus sprinklers. That can be isolated up to 200 psi or 50 psi over. So the other point here was all other modifications are just hydrostatically tested to system pressure. Okay. So whether you're doing this and then doing your final walkthrough, that's when I kind of made it convenient, right? As an inspector, I got to go there and do the final inspection. I was there on the building side. I was there with the mechanical inspector doing final inspections. We do our final walkthrough, and then wrap up within our 2 hours or come back within 2 hours. So we kind of did the final inspection and acceptance test at the same time. There's many different ways to pump up that system. Here's just one of the manufactured hydro tests, compressors, right, gauge, etc. Ed, did it again, there we go. The hydrostatic testing is always done at the base. So the pressure for that system is applied at the bottom. I don't have to get 200 PSI at the top of my system, no matter where that's at. You know, we could be hundreds of feet in the air. It's 200 PSI down here at the store, right? What else do we have? So 13 does allow us to test the system without sprinklers in place. We can plug it and then test the plugs, and the standard says we don't have to retest it when we put the sprinklers in. So there are times, especially during construction, we will plug that system with the plug and come back and put the sprinkler in later. That's okay. We get into dry pipe and pre-action systems, we can air test those. Anything, you know, the hydrostatic test, water, is preferable. So there are times though, the standard does allow us to use air pressure in freezing temperatures, which, you know, is pretty normal for us from November to, last week. Right? Yeah.
Let me ask you, if they do it that way, they still got to put a hydrostatic after the weather changes, right?
Right. Yep. Yeah, the air test doesn't cover them. You still have to do a hydro. So the hydrostatic test becomes that really big test. The other one is some of the operational tests. So hydrostatic test tells us that the system stays together when it's under pressure, right? And operation test tells us, okay, the system can perform at this level. So the one is, let's get into these. Maybe we won't get into these. What are we doing here? Oh. All right, I guess we're getting into water flow alarm. Okay. Water flow alarm. So the IBC, the building code, requires electric supervision for the valve. So this butterfly switch is electrically supervised, and the flow switch is electrically supervised, and then it's off-site monitored somewhere else. So with the water flow alarm, whether it's a water flow switch, a paddle switch, or air pressure switch, we have to test it. We test it by flowing water. right? So the wet system, right after that flow switch, so the flow switch in a wet system is that paddle. It's attached right to the system piping, right in the riser, there's a paddle in there. We tune that paddle to the flow of one sprinkler. We go to the inspector's test, open that valve, and we're trying to get an alarm within what time frame? Anybody? 90 seconds, yeah. Yes, sir.
Yeah, flow test, when you're doing that flow test, still 90 seconds on flow test?
Yes.
Max.
If you really want to get sprinkler nerd out, NFPA 13 just requires in what? 5 minutes.
300 seconds.
300 seconds? Oh, it's 5 minutes. Well,
No, it's 300
yeah.
seconds, that's what.
Yeah. Had to do some quick math in my head there that I wasn't expecting to do. Hear a little pop back there. The 90 seconds comes from the fire alarm code, right? NFPA 72 says you got to do this water flow within 90 seconds. And that's where we get our 90 seconds from. 13 doesn't care. Well, 13 does care. Just that they have 5 minutes. Hey, the 2022 edition, they finally correlated to everything, 90 seconds. So, yeah. All right. So the test connection on a wet pipe system is usually right on the riser. In a dry pipe system, it's no branch line. It's the one that's in the far corner of the building, right? And we're pushing it outside, and we're testing to that one sprinkler to the outside. That's the inspector's test for the dry system. Well, there we go. There's our 5 minutes. Or if you're in Clare, it's 300 seconds. That's cool. Wow.
5 minutes.
Yeah, 5 minutes. 5 minutes, or if you're got the fire alarm code, which the fire alarm code applies to every sprinkler system installed through the Michigan Building Code, 90 seconds.
See, that's where all the fire marshals come up with, you have to have 911, call them back within 5 minutes.
Ooh,
Is that required to have sight and sound on it as well?
no,
Not
Just the
required?
bell.
just go.
But AHJ can require auditor visits. Oh, yeah.
I don't know where the callback comes from in 5 minutes. That might be NFPA 1142 or 1143 for response times.
Yeah.
It might be. Which I don't think they have the authority to go there to the fire code. I don't think that's
They,
the direct
they
reference.
use the AHJ.
The badge?
Yeah.
So, more of the fire marshals are getting police cars across the U.S. So the Long Island Fire Marshal, Long Island, New York Fire Marshal did last week. They're all carrying Berettas or SIGs, right? 9mm. And so imagine being an instructor and there's 100 AHJs out there with firearms. And it's like,
Perfect.
yeah, it works well. I mean,
Yeah.
yeah. That's right. You said 3 o'clock.
That's what it says in the book.
Yeah. All right. Water flow alarm. There is no video here. Oh, there's a video. Look at that. Oh my gosh. So I guess we're going to do a water flow alarm. There's no audio. Golly, I should review these things before I stand in front of people and say this isn't going to happen. Amazing. So wet pipe system, it has that test and drain on it. Drain is going to a removed location. You can hear the water flowing through there. Are you guys timing this?
About 30 seconds.
30?
Now we screw it into main drain position. Get the main drain read.
I didn't lose my hearing through rock and roll. I lost my hearing through fire alarm. Yes, sir.
Is that just for demonstration?
Was that just, well, that was an actual water flow test.
Why did, what? Okay, so is that being monitored, or yes or no?
I think so, with all the bells.
Yeah, this is supervised. Is it monitor? The difference between supervision and monitoring.
Okay, yes, because you're gonna do that test, you are gonna call them and put it on standby.
Okay.
And then you're gonna call, like, you're gonna call the police department, who would get the signal and tell them it's gonna be on standby
Right.
before you do any of those tests, especially when you get when you have people in that building.
Yeah, yeah. Yes, sir.
That fire marshal from that municipality standing right next to me.
Yes. Right.
They will have contact and monitor the 911, if I don't know, we're gonna do a live test for a certain address, and we can check to make sure it comes through correctly.
Yep.
And then we'll put it in test mode, and then we'll do all of our on-site tests.
Yep.
But what's funny about that, none of the fire stations are monitored.
Ha!
They're there 24/7.
It depends on where you're at, depends on where the signal goes. NFPA 72 allows it to go to a local station, an on-site station. There's many different nuances in how that can be monitored acceptably.
We don't ever call the alarm company though and let them know it's gonna be a test.
No.
We never do that. We do tell 911, because the fire chief calls them and lets them know, hey, we're gonna be doing a test. Just let us know when you get the call. But we never ever tell the alarm company that we're doing it.
No, we do
We want
call-
actual response time.
We do call them because if they're gonna be testing the supervisory alarms or the, we'll say annunciation alarms or a device alarms, and they're doing that for repair or testing, yes, we call them.
Yeah.
We'll be standing right there with the fire marshal, myself, the fire alarm company, and the parts of pressure
Right.
contractor.
Yeah, we never let them know we're doing it, because we want actual response time. Not that they're gonna be sitting there, oh, he's gonna be calling me in 2 minutes, the alarm's gonna go off. Bam, it's instant response. We don't want that. We want them to be actual time.
I guess it depends on the municipality.
Yeah. I did all my own fire departments. They would just call on the radio, hey, we're testing this address, away we go. They're not bad to have, we do. Trip tests, so trip tests, we're doing off the inspector's test for dry pipe systems. So we're trying to get water to the inspector's test, right? And the default there is 60 seconds. But it depends on the size of the system. Dry pipe systems are not all 60 seconds. It depends on the volume of the system. Where do we get the volume of the system from? Where do I go for that? Plan review, right. The answer to everything today is go back to the plans, right? On the plans, it'll tell you the volume of that dry pipe system, right? So from 0 to 500 gallons, I need, there is no water delivery time. From 500 gallons to 750 gallons, there's a 1-minute delivery time. If I can't get my 1-minute delivery time, then I gotta put what's called a quick opening device on my dry pipe valve. Most of the time, you'll see contractors put the QOD on, the quick opening device on, regardless, because chances are they're gonna need it. And then from 750 gallons over, the system must have a quick opening device. So from 0 to 500, delivery time can be whatever. You thought it was 1 minute, but it's not. It's 60 seconds here, pal. No. It depends on the volume of the system. And up to 500 gallons, there is no delivery time. Yeah. Yeah, no. Joe woke up.
I got it, I get it.
There's also a delivery time based off a computer program. You look at NFPA 13, section 7.2, you'll see a table. In that table, will tell you what the delivery time is based on a number of test outlets. Know that that table, because I get lots of calls from HJs and code officials say, hey, they don't meet the delivery time based on this table. That table in NFPA 13 is based on a computer program. So they can design the system to hit certain parameters with a certain number of openings open, and they got to test that certainly at the final. But they can design the system to open more sprinklers. Anyway, long story short, what's that?
What section was that?
7.2.3.
Thank you.
No one uses the computer system. All right, no one uses that. Tyco makes it, and it's a listed computer program. Believe it or not, listed computer program, listed software. I haven't really run across anybody who uses it. So if you all use it, you see it, let me know. I'd love to see you part of that testing or plan review or look. So.
Dry pipe fire sprinkler systems.
Oh yeah, here's the dry pipe system
that are part of
and activation. I knew this video was coming out.
under pressure. The heat from a fire individually activates
I
the
don't-
fuse or bulb in a fire sprinkler,
kinda in a bad
causing
spot,
a
but-
release of air pressure. That in turn permits the pressure from the water supply to open the
Dry pipe
valve.
system
Water then flows
says
into the
exactly it, right?
valve
It's a
the
dry pipe
activated
system.
sprinkler.
We're holding back that water pressure at that valve. I can't get it to,
Dry pipe fire sprinkler systems have automatic
this air
sprinklers
pressure
that are
system
part of a
holds this
piping
valve
system
down
containing
until
air
we've
or
opened up
nitrogen
enough sprinkler that the air compressor can't keep up,
Fire individually
and then it
activates
sends the
fuse
water.
or bulb in a fire.
So where I said before, oh, here's the slide I was looking for. Look at that, under 500 gallons, no delivery time. So you have this slide, and it really kind of summarizes section 7.2.3. Under 500 gallons, no delivery time. All these are without a dwelling unit. Between 500 and 750, no delivery time with a quick opening device. Without a quick opening device, it's got to be 60 seconds. Over 750 gallons, you got to have it. So that's 7.2.3. Dwelling unit can have a dry pipe system, but look at the delivery time, 15 seconds. Ooh, that's pretty tough, right? That's real tough. Why is that? Why is it only 15 seconds? The system is small. What's going on in that dwelling unit? People are sleeping, right? We know, that's why we have the quick response sprinkler in light hazard occupancies. Right, that's that 3 millimeter bulb, and that's why we have the same quick response technology in residential sprinklers, because we need that sprinkler to open quicker, faster, right? Usually in about a minute is when that residential sprinkler or quick response sprinkler opens. Whereas your standard response, your 5 millimeter bulbs open in about 3 minutes. Three minutes, yeah. It's been a long day, pal. Here's the computer program for dry systems. You'll see this table in NFPA 13. And hopefully there's no NFPA attorneys in the room, but this is a copyright violation from a trainer's perspective, so that's a no-no. But don't call on me, okay? I'll make it up to you soon, like 20 minutes. All right, main drain test. Another operational test that tells us a couple of things. This is the one test that we do every year. So we'll do it when the system is in service. We'll get a reading, and what it tells us what the static pressure is beginning. Static pressure is water at rest. Residual pressure is water flowing, right? So we know what static pressure is, and once we open that up, once we let that gauge kind of settle down, we'll get a residual pressure. So we'll record that when the system is first put into service, and then every year through NFPA 25, we do this again. And we do this every single year for the entire length of that system, entire life of that system. Why? Because right now, when the system's installed, we have a system designed according to a water supply. We see the sprinkler calculations compared to the available water, right? We see our graph. During plan review, we identify all that. If we had a plan review class, we could talk about that. We don't have a plan review class yet, until Sue hires us. We got to do a plan review class, which she said she was going to do for fall. So plan review class is coming, I guess. Anyway, when the system's installed, we do the main drain test. Now we're comparing it to the water supply. The water, the flow, the pressure will not match the water supply that we looked at in the beginning at plan review. And that's okay. The pressure is going to be different. That's okay. All we're saying is through the calculations, the system's going to work compared to the water supply. The main drain test tests that water supply to make sure we have the flow and whatnot necessary. So we take these readings, and then from there on out, for the next 20, 30, 40, 50, 80 years down the road, we can measure the water supply based on that main drain test, right? Every year we do a main drain test, and we map that, we look at that. And that's part of the NFPA 25 process. So when that level gets down, so if we're good today, and next year or 5 years, once we go below our initial main drain test, that should ring some bells in our heads as AHJs, as owners, right? When it goes below the original test, there's a problem with the water supply. There's a shut valve, a partially shut valve, or the water supply has just gone bad. There's so many systems on that water supply that we've drawn that water supply down. So that's what the main drain test is there to do. It shows It proves the longevity of that system year after year after year, the longevity of the water supply, okay? So, again, another good reason to do NFPA 25. It's not only required, but it tells us these things. It tells us when the owner has to update water supply or fire pump or whatnot. They don't like to hear that news, but this is why we do what we do. All right. Yep. Bullet point number 3, just highlighted everything it took me 5 minutes to say. Baseline strength of water supply. The initial main drain test does that. Hey, backflow preventers. Since the 2007 edition of NFPA 13, we've had to accommodate the forward flow testing of backflow preventers. So we want to have enough openings in the system to push water through that backflow preventer at system demand. So if our system demand is 381 gallons a minute at 59.3 psi, that's what we got to push through the backflow preventer to make sure the backflow preventer opens up. And again, it's another operational test. Forward flow, though, we're going to run that water from the supply through the backflow preventer and then out. So we got to accommodate for that flow. We call that forward flow testing. We can put some outlets in there. We can use some hose valves. The 2007 edition, the 2010 edition, and correct me if I'm wrong, I think the 2013 edition says that you have to accommodate for the forward flow test. In the 16 edition, it says you have to install the means for a forward flow test without dismantling the system. Because right now, what happens, they'll take the check valves or the little clappers out of the FDCs and they'll flow backwards to the FDC and call it good. Usually with those 2.5 inch openings, we can get our forward flow through there. Now the standard says you got to have a permanent way to forward flow test without messing with those clappers on the single check valves and whatnot. Make sense? Okay. That's another annual test. And then after all of that, you get another certificate. This is the above ground certificate. And as the bullet point says, it applies to NFPA 13 and NFPA 13R. So all your multifamily dwellings, you'll get this for. You'll get it for all your other NFPA 13 protected buildings. But again, there's a ton of different things on this list. If you're really looking for like a checklist of what to look for raw, for final, these certificates work out really well to, what are we looking for? What are we looking, and that's really what this entire program was based on, was the underground and the above ground certificate. So so the certificate's going to go through the number of sprinklers through the building, were plans approved, were plans submitted, yes, no, were quick opening devices installed, and it goes from top to bottom. It's a real complete check of everything. So, what do we else? Yeah. So, at the end of that, on the flip side, the back side of that is actually this field right here, witnessing. So it kind of gets down to one of these other grenades in the room is, do you sign this certificate? As the HJ, as a code official, do you sign this? And the answer is no. There's nothing on that signature box that says, hey, code official, fire marshal, mechanical inspector, plumbing inspector, whomever, sign this. It's a document that goes between the owner and the contractor. You can see this here. So the name of the sprinkler contractor is on there, the property owner is on there, then the sprinkler contractor signs it too. As a code official, I've signed these because someone says, hey, here's a certificate, sign it, see witnesses, yep, sign it. So I've signed it. And at one time I talked to my municipal attorney and I said, should I really be signing this? There's, in this room, we could probably get a 50-50 split of whether or not we should sign this. And I took this to my municipal attorney, I work for the city, and I said, should I sign it? He's like, no. Well, don't put your name on anything, you don't have to. I'm like, well, that's good guidance, okay? Good guidance. But at the end, there's really nothing, you really didn't play a part in this installation of the system, right? You're not owning the system, you didn't install a system. As an AHJ, you're just a witness. Yes, sir.
Do they put your name as a witness on?
Can you put your name that you witnessed it?
I'm not saying me. Like we did one yesterday, and the fire marshal ended up signing it, but it was like 5 or 6 of those two.
Oh, wow.
Could they put all their name in it?
Can they? I guess they can. I wouldn't want my name on there. I mean, my name's already on the inspection, right? I've done this. I was here at this day, I witnessed this on my inspection log, but I wouldn't put my name on here, because guess who's gonna come looking for you when there's a problem, right?
And then when I was a facilities manager, it was worse than 16 years. I had to do these fires.
Yep.
Myself and somebody said they did not call 911. I actually had to call 911.
Okay. Okay. As a facilities manager, yeah, your name goes on here. As an
Oh, yeah,
HJ.
no, I'm talking about that. I'm talking about- That one's done. We went to the-
Yeah, no, I got you. It's there. Any pushback to signing this? Oh, no one wants to fight this late day.
Anything ever where it says witness here, have the code official or fire department, you should witness all these tests, not perform.
Right. So comment up here is, as code officials, we're witnessing these tests, we're not performing, right? We don't put hands on valves, we don't flow water, we just watch somebody else do it. And then we say, yeah, we were there. Does the code, here's a good one, does the code or the standard require you to be there? Not really, I heard not really.
It just says it's got to be witnessed, it doesn't say right there.
The fire code, the building code, I don't know what the mechanical code says. Even the sprinkler standard says you got to be notified. Notify the HJ, you know, when it's occurring, but nothing in the fire code, the building code, or the standard says you have to witness or you have to be present at the test.
You can ask for an affidavit saying it was done.
Right on. The chapter, section 901.3 of the fire code says, hey, you can get a document from the contractor that says, we did all these things, we did them on this date, this is what's happened, this is what we did, and you can accept that. And I don't know.
I wouldn't accept it.
I was going down the road, I'm like, I don't think I like that. But that's what it says. But there are plenty of HJs who do accept that at face value.
Because they're the ones who are liable for it. And if they were putting it on an affidavit, that's a legal document in court saying that they performed it and you're off the hook.
Yeah. Yeah, yeah.
Well, I understand that, but I want the people that are in that building, the occupants of that building, to be safe. I want to know that it works the way it's supposed to work.
Yeah, I want to sleep at night going, I saw this, I saw it work. And my name's going on the C of O, so I should probably watch this happen, right?
Yep.
All right. Okay, here's another grenade in the room. So at the end, so even on this document, even on this above ground certificate, if you can read this, and you can read this, you can see this all the time. Under instructions that I asked, did you, the contractor, give the owner the instructions to the system? Yes or no? Yes. Did you give the owner a copy of NFPA 25? Yes or no? Yes. And it's like, you know how many times I actually saw this happen? Very few. But they always mark yes. Why? Because if you mark no on any of those certificates, you got to have a reason, right? So, and a really good reason, because they're all pretty much mandatory requirements. If you mark no, it's like you didn't do something you're supposed to do. Why didn't you do it? So that's got to be explained. But every NFPA 13 system, every NFPA 13R system gets this. They get a copy, the owner gets a copy of 25. Why? Because it's their system to maintain. Just like we talked earlier, it's their responsibility. You all enforce that, but it's up to the owner to actually do it. So contractors are supposed to buy this document and give it to the owner with all the other cut sheets and instructions with that system. Sounds like a great idea, doesn't it? So, pretty much like the packet of mechanical instructions, HVAC instructions, right, that go back to the homeowner. This is the same idea. You see this? Yeah? No, not that. No? No?
I've never seen it.
You've never seen it. Some people have never seen it. All right. All right. Well, look at that. Hey, Ed. I got out early, buddy. Any questions? Of course not.